Hey guys, this is Martin. We are in the SQL injection section, and today's lab is SQL injection union attack, determining the number of columns returned by the query. So in this lab, we have a SQL injection vulnerability in the category filter. And what we are going to do, we are not extracting data as yet. We simply want to know how many columns are present at that point in time, right? So let's head over to the lab and let's check this out. So first of all, we can choose any category filter here, like gifts. And in order to verify this, so I'm going to send this over, like I sent the gifts over to repeater. And to confirm SQL injection vulnerability, I simply put a tick sign, hit send, and I get an internal server error. All right. So now I put in union select, and I try it first with one column, which I assign the nil value, and I terminate the SQL query with the dash signs. Now, in order for this to work, I will also need to URL encode this. So the plus sign in URL encoding stands for blank. And I try this, right? So I hit send and I get an internal server error. Okay, so that means that there is more than one column, basically. So let's add another column. So let's try, are there two columns here? And no, there's also more than two columns. So let's add another nil value. And then let's hit send. And now we get a 200 okay. Let's render this. And so basically, we now have figured out that there is 3 columns in total, right? So we have no longer received a SQL error. And so there's 3 columns in total. And if I go over to the lab, you can see I have solved the lab successfully because I determined how many columns are present. I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in the SQL injection section, and today's lab is SQL injection union attack, finding a column containing text. Okay, so basically we start off very similar to the first lab. In the first lab, we were determining the number of columns first and foremost, and then we also want to identify a column which is compatible with string data, because there might be different columns, like some is just for numeric values and things like that. So we want to find a column which is able to handle string data. Okay, let's head over to the lab. Let's choose a category. First and foremost, you see up here, make the database retrieve a string called this, right? Like this is basically what we are supposed to retrieve. So we went over to the pet section in the category filter. So let's send this request over to repeater. And we confirm our SQL injection by simply adding a tick, and we get our error. So as before, we start off with the union select attack, union select nil, and terminate the query. So what this command is basically doing is, hey, is there one? So I'm basically asking, is there one column? And I hit send and I get an error, 500 error. So that means there must be more than one column. So I try with true. Are there 2 columns? No. Again, I get an error. So are there 3 columns? Correct. There's 3 columns. So we now identified that there is 3 columns present. So let me copy the string here. And now I need to figure out which of these 3 columns actually can hold text. So I try with the first one. And how to do this is I put this in ticks and the string I want to retrieve, and then I hit send. And I get a 500 internal error. So it's certainly not that column. So what I'm going to do is I replace that text. So that means that the first column I just tested is probably just like holding numbers, right? And is not string capable. So let's try this with the second one and see what happens here. And the second one worked. So I was able to retrieve that text from the second column. So to verify this, I can simply go here and search for this. And then I get 3 matches. And down here, you can see it. So it was retrieving that value successfully. If I render this, I will see here that this is the string I was supposed to render, and it worked. So let's head over to the browser, and you see the lab has been successfully solved, and we were able to retrieve the string requested. I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in the SQL injection section, and today's lab is SQL injection union attack, retrieving data from other tables. Okay, so we will be utilizing a lot of the techniques from the previous chapters, but our goal really this time is to extract information from a different table called users. Okay, so and within that users table, we have columns called username and password. Okay, so let's head over and let's do this step by step. So let's first of all choose a category, and then basically this category I'm going to send over to repeater, and I see if it's vulnerable for SQL injection, and I put a tick at the end of gifts, and I get a SQL error. So this is a good indication. It's not always the case, but it's a good indication that it's vulnerable to SQL injection. So first of all, let's find out union select the number of tables. Like done in the previous video, does it have one table? No. There's more than one tables. Are there two tables? Yes. So there are two tables. We already verified that. Now we see whether we can extract data from these tables. So basically we try ABC in the first table, and we try DEF in the second table. Then we hit send, and down here you can see that we were able to successfully retrieve ABC and DEF in our, it doesn't render properly here, but you can see it in the source code and in our output. Okay, so now let's construct the attack. So union select, right? And then, but now we want to actually extract usernames and passwords, right? So let's start here and say like username, because we've been given that information, comma, blank. So the plus is a blank URL encoded, password, okay, and then a blank, and now we say from. So that's a SQL command where we basically specify the table where we want to extract it from, and we want to extract it from users. So there's two columns, username and password, and the table is called users, and we terminate the SQL query at the end. Let's hit send, see what happens. I still get an SQL error, and let's see why that is the case. Union select username plus password from users. So it's, if you look back here, it's actually called users. Okay, the table is called users, not user. So let's rerun this again, and we get a 200, okay, which looks good. So let's render this, and down here you can see now I am able to successfully exfiltrate information. So I exfiltrated username Carlos and the password, administrator and the password, Vina and the password. So let's go down here, look where administrator is once again. Here's the administrator and here's the password. Now our job is to go to the application and to go to my account and now log in as that administrator with that password we have just extracted, and that worked, and that solves the lab. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin. We are in the SQL injection section, and today's lab is SQL injection union attack, retrieving multiple values into a single column. So very often in pentest engagements or bug bounty hunting engagements, you may find the problem that you can only control one column, but you actually would like to retrieve multiple columns or information of multiple columns. So what you can do is you can do it step by step. Okay, so for example, you retrieve the usernames first, and then you run the attack again with the password column. This can become tedious, so there is a way of basically concatenating the results together. and then you can extract everything into a single column. Okay, so in this lab, again, we have a table called users and then 2 columns called username and password. Let's get started. Let's choose a category first. Let's choose the pets again, and let's send that request over to Repeater. I put a tick at the end and then see if it's vulnerable to SQL injection. It's not always vulnerable when you put a tick, but it's a good indication if you get a 400 server error. Okay, and then first thing we do is union select. So the plus is always like a blank sign, okay, URL encoded. So first command here is like, is there one column? Okay, there's not. So there's more than one. Are there 2 columns? Yes, correct. So now next question is, which one of these columns can hold data? So can the first one hold data or a string? No. So this is exactly the problem I predicted earlier, is basically if you only have one table, right? So if only that table can hold data, then you can only retrieve into this specific, in our case, the second one. Okay, so now with that information, I can start crafting my attack. So I know that I have to fill the data or exfiltrate that into the second column. So what I'm going to say here is basically username, okay, because I've been given that information, and then I put 2 pipes, and then tick tilde as a separator, and another tick, and then 2 pipes again. So what that does effectively is it's concatenating this into one table. So you have the username information and the password information. You get this outputted into one table, and then we say from and the users table, right? So let's hit send, see what the response is, and this looks good. And basically what I get here, see, I get the Wiener, and then I have the tilde separator as I specified it here, and the password of that specific user. So I was able to output this information into one single table. Sorry, one single column. So here, this was like we were supposed to output this into a single column, which was possible. So I'm copying the password of the administrator. I go on over here, I go to my account, I log in as administrator with that password, and the lab is solved. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the SQL injection lab, and today's lab is SQL injection attack querying the database type and version on Oracle. So it's important that you need to understand that there is different commands you can use or you have to use on different database types. So first of all, there is something called the SQL injection cheat sheet from Portsrigger, which is really, really helpful because, like, for example, if you want to retrieve certain things, like, for example, the version, then you need to use the select banner from $version command. So this is different, as you can see this here, like for Postgres or for Microsoft or MySQL and stuff like that. So this is important. So we are heading over here. Basically, our goal is to retrieve the following strings, like basically the banner. So it's also referred to as the banner, which is like the version information and stuff like that. So let's get started. Let's pick a category here, gifts, for example. Let's go over to Repeater. Let's send the gifts to Repeater. Once again, confirm the SQL injection here. Yes, this is all good. And I'm not going to show you how to enumerate how many columns you have, because we have done this in the previous videos. I'm going to show you now with a command basically how to extract that version. So first of all, we would say here union select, as before, union select, and then we want to output, say, ABC, and then DEF. But now the difference is that if you do this on an Oracle, you need to add something called from dual, which is basically the Oracle command to extract this. You didn't need this on MySQL, but there you need it basically, right? So I get a 200 OK. I scroll down here and I say I was successfully able to exfiltrate ABC and DEF, right? So this also indicates to me that both of these columns can hold strings. Okay, so I can just put one of them. I use the second one and to use for my exfiltration and put the first one to nil, right? Because I only want to extract this from one specific one. So what I would now say is union select nil, or let's do it the other way. Let's actually do it like this. Okay, so, and then I say here, union select, and what do I want to select? Well, basically, I want to select the banner, right? Like, as you recall from here in the cheat sheet, like, in order to exfiltrate this, is like, I need to select the banner, right? And then I need to say, I need to extract this from version, which is, again, Oracle specific. So the command is v $version. And then I hit send. I get a 200 OK, and I was able to successfully exfiltrate the version information of this specific database. So let's come over here and see that the lab is solved. Okay, I hope this makes sense, and I see you in the next video. Hey guys, Martin here, and we are in the SQL injection section. Today's lab, SQL injection attack, querying the database type and version on MySQL and Microsoft SQL. So pretty similar task than in the lab before, but the syntax is different because the Microsoft and MySQL syntax differs from the Oracle syntax. So once again, I recommend using the SQL injection cheat sheet. You can see this here, how to get the database version. This is the cheat sheet on Portstrigger. And so you will see these commands are identical basically for Microsoft and for MySQL. So let's head over to the lab. Let's go to the lifestyle category. Let's look at the lifestyle category here, send it to repeater, and simply verify we get a 500 server error, which we do. And once again, I'm not going through on determining how many columns exist because we have done this before. So we can simply say union select, and then we basically have two columns here. And in the first one, we want to output ABC. And in the second one, we want to output DEF. Okay, now an important difference is you need to use the hash sign at the end of any query to a Microsoft database, right? Because otherwise you get an error. So if you would try the dash, that does not work for this particular database. But you see, we were able to successfully exfiltrate data to ABC and DEF. And now what I want to do is I only need one column basically to actually exfiltrate the information. So I set the second one to nil. And in the first one, the syntax is basically at version. And I hit send. And I go down here and I see that I'm able to exfiltrate the version successfully. So let's go back, and the lab has been solved. And this is how you basically query the database type and version on both MySQL and Microsoft. I hope this makes sense, and I see you in the next video. Hey guys, here's Martin. Today we are taking a look at the SQL injection attack, listing the database contents on non-Oracle databases. So this is a bit more sophisticated than the previous labs. So effectively, we know, for example, that it's a non-Oracle database from reconnaissance, and we may have also obtained, or we assume that the database contains a table that holds usernames and passwords. However, we do not need, we don't know at this point in time the table name, and we also don't know the column names, right? So we need to extract this. So first and foremost, before even starting, let's head over to the SQL injection cheat sheet from Portswigger. And there you can see basically what commands we need to use. There's basically in Microsoft, for example, or in Postgres or in MySQL, there is something called an information schema.tables, which basically lists you the tables, and then you can work yourself through that and then launch subsequent queries. So it's always good to refer back to here to construct your attack. Let's go over to our application and let's go to the gift section, select gifts here, and simply send this over to repeater as before, right? So we do this, and then we hit send, and you can see this is fine. If I put a tick at the end, I get a 500 server error, which is also fine. So in this sheet here, I have constructed like a couple of commands, and we will go through them one by one. So the first thing I'm going to try is, well, I'm enumerating the number of columns, right? So in this case, I already know it's 2. If I would remove 1 here, then it will give me an error. So this is one of the earlier labs we have completely done, explained that. This was like my first try. And then I also want to see if any of these 2 can actually hold string data, right? So I'm trying that as well, and hit send, and yes, I'm able to retrieve the content here, A, B, C, D, E, F. So those are my first tests, so both of them can be used for data exfiltration. Now we launch the union selected tab, where we say union select table underscore name plus nil. So that's basically the second column will be nil. So we are extracting into the first column, and then from information underscore schema.tables. As you recall from the cheat sheet, that was the correct syntax. So let's put this in here and see what happens. And we get a 200, which is good. So which means our thing obviously worked. And now you can already see like the tables in here, right? Like you see, like there is a lot of different tables. And what looks interesting to us? First of all, I would say users looks pretty interesting, right? Like the users table. And it has like this special, not determinable abbreviation. So let's copy this out, and then let's put it in here, right? So what we are doing now we are looking at the column name, okay, from, and then second column is nothing, again, from information schema dot columns, not tables this time, columns, because we are specifically looking for the column where the table name equals these users which we have just extracted. So let's take this command and put it in here. So it's always like a step-by-step process. And by the way, you would not do this in a real engagement manually. This is just for you to understand the different commands and things like that. So this worked nicely, and we are able to extract like a password column basically. And there should also be a users column, correct? And we put this in here. So now the next command I'm going to use is, I now say union select username. So I'm getting information out of this username column, and the password from the password column. Okay, and then from users, from this specific table, right? This is the specific table I wanna extract information from. So this is, once again, so I'm using both of my columns in this case. So the first one is for my usernames, the second one is for my passwords, and I'm extracting this from the table users, la la la. Okay, so I'm taking this and I put this in here, and let's see what happens. And if all goes well, I should be able to retrieve information. And let's go through this. And yes, I was able to. So here you can see this is Carlos and the username of Carlos. Here is Vina and the username of and the password of Vina. Here is administrator and the password of the administrator. I copy this. I head over to my web application and then I sign in as administrator with those extracted credentials, and that solves the lab. So I hope this makes sense. And once again, you don't do this in a manual fashion in a real world engagement. You use a tool called SQL Map, which we will discuss in a later section. Okay, thank you very much. Hey guys, this is Martin. We are in the SQL injection section, and today's lab is SQL injection attack, listing the database contents on Oracle. So it's very similar to what we have done in the previous lab, but this time around it's an Oracle database, and we know there's a login function, so that there must be a table, and there also must be like a column for usernames and for passwords, but we don't know the names, so we are not able to extract this. So first and foremost, before you start out, go over to the SQL injection cheat sheet, and then you can see that if you use Oracle, the syntax is different. So you have like something called all_tables if you want to retrieve information from the tables, and then you also have like once you found the table you want to extract information from, you have a command like all_tab_columns where the table name is that table name you found with the first command, right? Like, so let's get started here, and we go over to gifts, and I've prepared a couple of statements, a couple of command injection SQL injection statements already. So this is where we're going to work with. So the first one is basically seeing if I can use, so presumably I've already determined that there's two columns, and now the next step I want to find out whether these two columns basically can hold string data. And I do this, and yes, I confirm this. We have done this numerous times in the previous lab, so I'm not discussing this any further. But the next one basically is I'm going to send this command, which I'm going to put in here in a second. And that's effectively saying union select the table name from all tables, basically. And I input this into my first column and just leave the second one to nil, to blank. I hit send, I send the request, and then you can see here immediately I get all the tables basically. So I get all the table names, and now I need to walk through these table names. What's interesting? So what is interesting to me usually is like something users and roles. So I search for user, maybe, or this one looks much better, like, right? Like, so this is a bit of trial and error and stuff, but this looks like a users table to me, right? I copy this out, and then I say in the next command, union select column name, and then in the first column, the second column I leave blank from all_tab_columns where the table name equals users, right? Like this is the one I've just found. So I'm sending this out now. So hopefully I can retrieve all the columns now from this specific table. And I go in here, I put that in, and I hit send. And this doesn't work because I need a blank here. And the HTTP 2 I only need once. Okay, like this. And then now I look again for users, and then I see like, hi, here is basically a username column. I need certainly that, right? And I also need something called password column, right? Like username, password, and this is the password column extracted. All right, and this now allows me to basically finalize my final payload, which is select the username. So I want to select the users, and I want to put this into my column 1, and I want to also extract the passwords, and I want to put this into the second column, right, which we identified, and then from this table, from the table we identified in the previous step. So this should be the right syntax now. I take this and copy this in here and hit send, and I get a 200, which is very promising. And down here you can say we were able to successfully exfiltrate the administrator and other user names and the associated passwords. So let's head over to the administrator, to the login panel, and log in as an administrator, and that solves the lab. I hope this makes sense. And once again, this is just from a learning perspective. It's good to learn like this. But in the next couple of labs, we're going to use SQL Map because it speeds up the process and it's more real world, right? It's important to understand what's actually going on behind the scenes. But in order to really use it in practice, you use SQL Map. Okay, and that's it for this section. And I see you in the next one. Hey guys, this is Martin. We are in the SQL injection section, and today's lab is blind SQL injection with conditional responses. So in this specific lab, the SQL injection vulnerability is basically in something called a tracking cookie, right? So it's not always in a parameter like in the previous examples. It can also be like in a cookie value. And so basically this cookie is used for analytics purposes, and it performs a SQL query containing the value of the submitted cookie. Okay, so it is a blind injection because there is no results being returned and no error messages are displayed. So whenever you have this condition, we're talking about a blind SQL injection. Now, these days, most of the SQL injections are blind because the framework has gotten better over the years and less verbose. And whenever you find a SQL injection these days, it's usually blind, right? And this is one of the scenarios, for example, where you would use SQL Map, right? And we are going through the solution together just for you to get an understanding, like how it actually works. But in reality, you use SQL Map, and I will show you this as well. So first and foremost, like if you go to the solution, so the tracking ID cookie is vulnerable, right? Like it has a value set, and if you do like a query like this, tracking ID equals XYZ and then end1 equals 1, it basically verifies that a welcome back message appears in the response. So you will get a welcome back. If you change it to a false condition, if you say 1 equals 2, the welcome message will not appear. And that's basically your condition you can now use to exploit this. And then what you can do is basically in the next step, is like you will craft a SQL query like this, like select A from users, limit 1, so just one position, and basically verify that the condition is true, confirming that there is a table called users, basically. So this is to verify there's a table called users. And then you can make it more complex. Basically, you will then say like where username is administrator, so you can basically verify that the username administrator exists, right? So all based on this condition, like whether the welcome back message appears or welcome back message does not appear. And then you can start, so now you know that there is an administrator password. You can then basically start doing like, is there a password? Is there a password in length of larger than 1, which should be the case. If this condition is true, then it confirms that there is a password greater than 1. Then you repeat the same query with number 2. Then you repeat the query with number 3, and so on, and so on, and so on. And you can actually do this in Burp Repeater, like you could automate this. Sorry, not Repeater. You would use Intruder because Repeater is slower. And so in Intruder, you would then simply mark this particular position, I believe it's shown here, whereby you basically then just reiterate through this. I think they show it somewhere. Yeah, like here, all right? Like then you can basically reiterate through this. Whenever you see the both of the paragraph signs, that's like the payload position in Burp and things like that. But to be honest with you, you don't do this like in the real world. You wouldn't do it like this. But the purpose of going through this, and please read through this again, is then basically reiterating the password. Like is the first character of the password an A, and if the condition is true, then move on to the next one. Right? And then, or if it's not A, then try B, then try C, then try D. So you go through all these conditions and you just have this one message, the welcome back message appears or it doesn't or it doesn't appear. And then you run through the whole exercise and you can read all this, but this is typically not how you do it when you exploit this in a bug bounty program or in a penetration test. So what you're going to do is you use something called SQL map. And I'm going to show you how to automate this very, very easily. So this is the SQL map command, basically. So SQL map -u for the URL. So that's the URL along with the parameter which we are going to try, right? Like, so the category pets, which is not vulnerable in this scenario because the vulnerability is in the tracking ID in this one here, right? But you have to supply the cookie values, and you have two cookie values. One is a session value and one is a tracking ID value. So if I show you this real quick in Burp, it's over here. Like you can see, there's a tracking ID and there is a session ID, and you need to integrate them in your SQL map command. And then you use --level 2, and so, which is like an intensity level in Burp, and then you specify that kind of database you're targeting. So in this case, it's PostgreSQL. SQL. Now, if you don't know this, right, what you would do is you would simply let it run like this, like without these additional commands, just level 2, and then it will return you which database it is. It just takes longer, but if you already know the database and you can append the database, you say dump the database and you use 5 recurring or concurrent threads, basically, right? Like to run this. And then you just punch this into SQL map, and then what you will see is like here it started off, up here. So this is the command I've just shown you, and then it basically at some point it finds that the tracking ID is vulnerable, right? And here it says cookie parameter tracking ID appears to be and Boolean based, what we just discussed, blind injectable, basically with the welcome back message. So the SQL map successfully has seen this error, and then it's basically doing its work, and it's starting to retrieve all the information. And then at the end of the day, you get like a table with your administrator and the password and all the other users as well. And then you simply head over here to Burp and log in. And this should basically solve the lab, right? And it's always good to use SQL map, like for SQL injection. It's important to understand how this is done. And this is why I recommend, again, to read through the solution and really understand every single step, how you could do this manually, and maybe even run through it once manually. But in practice, you're not going to do it like this because it's very time consuming, and you're normally bound by time limits when you do a penetration test. So this is why you have SQL map. But please take a moment and read through this. But this is basically blind SQL injection with conditional responses. Hope this makes sense, and see you in the next video. Hey guys, this is Martin. We are in the SQL injection section, and today's lab is blind SQL injection with conditional errors. So it's once again a blind SQL injection, which means you don't get distinctive error codes and you don't get verbose message outputs. Blind SQL injections are some of the ones which are most common these days because frameworks simply got better and developers got smarter, but they exist. Okay, so this time around it's similar to the previous one, but this time we are dealing with conditional errors, with error messages. So in the previous one we were dealing like with the welcome back message, which wasn't an error message, but this time we get a distinct error message. So to understand what this means is if I put the tracking ID cookie as XYZ and then I put a quote, and then I get an error message. If I put 2 quotes, I do not get an error message. And that's basically the condition we are going to exploit. And you can then, for example, run a query like this, where you simply can then say from, not a real table, right? Like, which doesn't exist, and you should get an error in this scenario. And if you choose something like this, on the other side, like from users where row num equals 1, and if this table exists, then it will not return an error, basically, right? So this is how you basically exploit this, and then you work with the so-called case statements. So when you use the case statements, like for example here, select case when 1 equals 1, which is a true condition, then do a divide by 0, which results in an error. If the case is not 1 equal 1, but 1 equal 2, for example, then it will not throw an error, because then it will not do the then statement afterwards. It will straight jump to the else, right? And so leveraging all this, you can then, for example, use the same conditions we have done before, or in the previous lab. You can then go in here and say, like, for example, when the length, select case when length of the password is greater than 1, then do a divide by 0. So basically, this is a true condition, but it will throw an error. So it's kind of an inverted logic, right? Like whenever you have a true condition, it is an error. When you have a false condition, it's not an error, right? Because it will only divide by 0 when the password is greater than 1. And then once again, you would run through, like, I encourage you to read all through all this. You would run through like all the different positions, and you can do this in Burp Intruder. So you would then simply track when you get a different response, and then you basically are at the level of the password length. And then from that on, you basically can use like a condition like this, like it's described here, where you then need to set the password, first of all, the character you are testing, and then also like the position, and then effectively you can run through this. And you want where username is administrator, because you want to get to the administrator password. And then basically it would look like this, where you then simply have a variable which you run through Burp Intruder in order to reiterate through all these different positions until you have like the first character A, B, C, D, E, F, G, and so forth. And then once you have the correct condition, then you jump to a second character, third, and so forth, depending on the password length. It's very, very time consuming to do it manually, but I encourage you to read through this manually to understand how it works. But in reality, you use SQL Map, right? And so we just go here over to pets, for example, and then in there we can see there's basically 2 cookies, which are set. One is the tracking ID and one is the session ID, so to speak. So those are our cookie values. And then we construct a simple SQL map command, SQL map -u for the URL. And then we can put anything in here, right? Like any category, it doesn't matter. The pets category is not necessarily vulnerable. It's not vulnerable in this case, because the vulnerability, the blind SQL vulnerability, is in the tracking ID, in the cookie, or in this one here, right? But you need to add it, and then you say --level 2, and then basically you just run it. Like I already ran it. If you don't know the database you are up against, you simply leave this blank here at the end and run it for the first time. So you uncover the database version, and then afterwards, once you know the database, you can basically run a command like this. So we are dealing with an Oracle database, and then we want to dump the database contents with 5 concurring threads. Okay, and once this is done, it looks like this. So once again, it runs through the whole thing, and then at some point it basically detects that the tracking ID appears to be vulnerable to Oracle and Boolean-based blind SQL injection. So it's injectable, so it gives you the error message and all that, and then it's actually going through this, and it takes quite a while sometimes because it's blind, so it has to go through all the different positions like what I just explained, but it's simply automating this for you, right? And at the end of the day, it will extract the administrator password, and I take this password, I hop over to my account, I log in with the administrator, and that should solve the lab. I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin. We are in the SQL injection section, and today we are talking about blind SQL injection with time delays. So this is one of my favorite injection types, especially when it comes to blind SQL injection and bug bounty. So in bug bounties, very often you do not want to actually dump the database for PII reasons and all these kind of things, right? Like, so if you just want to prove the vulnerability, you always use or you try to use time delays instead of instead of running a full dump. So basically what's happening here in this particular lab is you have a tracking cookie, once again, which we already know. We already know that the tracking cookie is vulnerable. And like in the previous labs, and I'm just going to show you how to exploit this. But before that, we also know in this specific case that we're dealing with a PostgreSQL. So this is different, like the sleep commands are different based on the SQL database you're dealing with. So if you go to certain repositories on GitHub, like payload all the things and stuff like that, you find a lot more and a lot more bypasses and things like that for time-based conditional delays. So this is again like the cheat sheet from Portswigger, which is available on the Portswigger website. So let's head over, go to the pets, for example, here, right? And then we simply take a look at the pets category. We send it over to repeater, and the tracking cookie is vulnerable. So what I'm going to do is I remove the tracking cookie and just put an X at the end, right? Like an X, and then try something like this and see what happens. Nothing really happens. So this is because it's blind, right? So I don't get the 500 error message, but blind injection is like, for example, I try now to induce a SQL command, and as I know from the cheat sheet, if the PG underscore sleep is like the one for Postgres, and then I put it to 10 seconds, right? Like I put it to 10 seconds, so I see the outcome, and I terminate the query, and then I hit send, and now you see nothing is happening. And in fact, there is something happening because now I instructed the database to sleep for 10 seconds before my response is actually being returned. And that's what just happened, right? So I have successfully induced a SQL sleep command, the PG sleep command for PostgreSQL, and then I terminated the SQL command right here with the 2 double dashes. If we head over, you see the lab is successfully solved. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the SQL injection section, and today is blind SQL injection with time delays and information retrieval. So based on our previous lab, we simply were able to introduce a time-based condition so that the response took like 10 seconds to respond. Now we want to leverage this and actually extract information from the database based on that fact. Once again, you would not do this manually because it's way too time consuming. You use SQL map in practice for this, but let's run through this quickly on how you would do this manually. So if you have your tracking cookie, once again, you simply introduce like a select case here, right? Where you say 1 equals 1. If 1 equals 1, then sleep for 10 seconds. And if that condition is not true, then don't sleep, basically. And then it takes 10 seconds because the condition is true, right? And if you would put 1 equals 2, then it would not sleep, the application would respond immediately, right? And based on this, you basically can then create clauses like, for example, if there is a username, select case when username equals administrator, then sleep for 10 seconds. And if there is no administrator, then return the information right away or don't sleep. And so because the condition is true, it took 10 seconds until it was confirmed, but that confirms that the administrator is there, right? And then you would do the same thing here, like with the password length again. So username is administrator and length of the password is greater than 1. If that's the case, sleep 10 seconds. If it's not the case, don't sleep at all, right? And you would do this with 2 and with 3 and up all the way up until you have basically the length of the actual password. Once you have the length of the actual password, you would do something similar what we have done earlier, like username equals administrator, and then password with the characters and the reiteration here. So you're running through with burp intruder, right? So you take first of all the first character, and then you make all these conditional checks. Is it A? Is it B? Is it C? Is it D? If it holds true or false, you will get a time delay or you will not get a time delay. And then, so yeah, basically sleep for 10 seconds or do not sleep for 10 seconds. And then you go to the next position and all the way up until you have your 20 positions or however long the password is. So it's a tedious process. And also, if you use the sleep 10, you spend a day doing this, right? Like, because for every single character, you have to wait for 10 seconds, potentially, right? So it will take a lot of time. So versus if you do this with SQL Map, it still takes a lot of time, but it is automatically adjusting the acceptable timing value, so it's a lot quicker. And here, once again, you can see like how you can inflict those conditions. So the conditional time delays and the ones I've just shown you, they are basically also in the Portswigger cheat sheet. Let's head over and do this with SQL Map. So if you go SQL Map here, you will basically see that I supply a URL, right? And that's the URL along with any category. It doesn't matter, again, the category, because the vulnerability is in the actual tracking ID in the cookie. And then I already know that it's a Postgres SQL, so you would probably need to run like a discovery SQL map first by omitting the commands here from this point onwards. But because I already know the database, I can focus on this specific database, and I instruct it to dump the results, right? So this is how it works. And then basically, if you look over here, this is work in progress right now. So I kicked it off before the meeting. But you see how long it takes. Like, it doesn't take as long as 10 seconds per character, but it's still lengthy. So while this is running, let's take the user Carlos, for example, and log into the user Carlos account and see if this is already working. So I have the password here from Carlos, even though that's not the goal, right? The goal is the administrator account. But let's log in, and this was actually not correct. So maybe it's not supposed to do that. Or maybe let me just, oh no, it's actually, this is the administrator password, and then that's the administrator. So it already finished this, because this is the Carlos user and that's the Carlos data, that's the Carlos password. So let me take this should be the administrator password. I don't want to wait all the way until the end, until it's finished, but I do this, and that basically solves my lab, right? So you see it's a lot easier. It's important to understand, go through the exercise step by step and understand what it's actually doing and how the time delay is reflecting on a true or false condition. That's important to understand. But in reality, if you do bug bounty hunting or if you do pen testing, use SQL Map, because it saves you a ton of time. Okay, I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin, and we are in this SQL Lab section, and today we are going to take a look at blind SQL injection with out-of-band interaction. So out-of-band interaction basically means that you have a blind SQL injection, but the application response it has no effect on the application response itself. However, you are possibly able to trigger an out-of-band interaction with something like a Burp collaborator or with an external server, with an external third party, right? And in this lab here, the tracking cookie is vulnerable once again, okay? And so the SQL injection is basically based in the tracking cookie. Now, how would you find a vulnerability like this normally? Well, with Burp, right? Like, you do targeted scans with Burp Professional, for example, and it actually is pretty good on detecting those kind of vulnerabilities. You also have like a plugin called Collaborator Everywhere, like an extension in Burp, which is pretty useful to find these in reality. Now, when it comes to bug bounty or something, out-of-band interaction is typically fine. That's typically all they require you to do. But in the next lab, we will also take a look at the exfiltration, so that you can actually exfiltrate data. So first step is I will check the SQL injection cheat sheet, and then you see here, so we already know there is an Oracle database which we are testing against. And you can see here, like, it's leveraging something called XML, External Entity Injection, or XXE, which we haven't discussed yet. That's a full chapter on its own. But basically, it's like modified XML input. As you can see this here, right? So this is like XML input, and then we are going to include or embed an external entity. And then in this external entity, we are simply calling our Burp collaborator URL. That could be like another server out there, like a webhook or something like this. And then basically here from Dual, that's very important, always to have that in when it's an Oracle database. Okay, so I have prepared this statement already. The only thing which is left to do for me is basically insert my collaborator URL. So I'm copying this out here and I copy this into a new line. So this is basically my collaborator domain, which I have to include here. This is where I want to trigger the out-of-band reaction to, right? And let me just copy this real quick and put it in decoder because I have prepared it already for, so it's basically the same thing you have seen on the cheat sheet, but I've already prepared it. So sometimes you need to URL encode certain things, right? So let's decode this as URL, and then you can actually read this better. So it's like a union select, extract value, then we inject the XML entity injection here, and then basically all we do is we call we issue the system command. So the external entity is being called remote, and this is our target basically. And this is all it does. So what I'm going to do now is I go over to my web application and I go to any of those categories, and then I head over here and I send this to repeater. And in repeater, I'm replacing the tracking cookie with that specific payload, right? So something like this. And then I hit send. And you will see there's only a 200 OK, so no response, nothing. But if I go over to the collaborator and I poll now, I basically see the DNS interaction. So I see the DNS interaction, which was done. So you can see the DNS query. And so the collaborator server received the DNS lookup for the domain. And basically, this lookup was received from the IP address. So that's the IP address of the web application, which sent that through. So as a matter of fact, I've received multiple of these, but that proves the point. So there was no data exfiltration or any of that. That is simply just to trigger a DNS lookup to the Burp collaborator server. And if we go to our application, we will see the lab is being solved. I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in the SQL injection section, and today's lab, blind SQL injection with out-of-band data exfiltration. So this is a follow-up from the previous lab where we just triggered an out-of-band interaction. This time around, we are actually going to exfiltrate data. And once again, our tracking cookie is vulnerable, but it's a blind SQL injection, so the application response, or there's no effect on the application response, regardless what we put in, but we are able to trigger out-of-band interaction and exfiltration by using like a Burp collaborator or webhook or a third-party domain, right? Like an external domain. And so interesting things to know here is the database contains a table called users, and it contains two columns, username and password. And we know that there is an administrator user, and our goal is to exfiltrate that password of the administrator user. So first of all, head over to the cheat sheet, and in the SQL injection cheat sheet, you find the full working POC for that. So we know it's an Oracle database, and then basically that's the payload for it. And once again, it's an XXE, external entity injection payload, but it's slightly different. Last time we only called the Burp collaborator domain to show the point, to prove the point. But this time around, we put a query in there, which is then being prepended to the domain name of our Burp collaborator domain. Okay, and I will show you how this works. So let's head over here first of all, and we go to pets once again. Okay, let me show you the payload I prepared, and then we go through it. So the payload is already URL encoded. This is why it's a bit difficult to read, but let me actually take this payload, put it into decoder, and then we decode this. We decode it from URL, and then you can actually read this better. So once again, we are injecting here union select extract value, and then comes our XXE payload, and it's all pretty much the same like before, but then instead of just putting our URL in here, so this is the external entity which we are calling, this is the actual vulnerability that it allows us to do that, which should be blocked normally because there's no need for this. But basically what we do here is the select query. So if you look at the select query, so we say select password, so we know that there is a column password from the table users where the username equals administrator. And then this result is being prepended here as a subdomain name to our Burp collaborator domain. This is basically what this payload is doing, right? So let's take this payload and let's head over to Burp, to repeater. Let's send the pets request over to repeater. And we know the problem is in the tracking ID. So I'm going to remove the tracking ID and replace it with that payload. And I have tracking ID in here twice, so I just need it once, like this, and that should work. So now I'm going to send this, and you can see once again the application is behaving normal. There's no errors, no any indications, regardless what I put in there. But if I go to the collaborator and if I poll the information, I can see that there have been DNS lookups done. And interestingly, unlike in the previous lab, you can see something here. You can actually see it almost looks like a subdomain, but it's not a subdomain. It's actually the password, because our query was asking for the password of the administrator, if you recall. So I'm taking this, I'm copying this, and head over to the account. I log in as administrator and with the password, and that solves my lab. Okay, so this was a realistic demonstration of out-of-band data exfiltration through blind SQL injection in combination with XXE. So XXE is a whole another topic, and maybe you want to watch this section first and come back to this video so you understand the syntax a bit better. But that's all for today, and I hope you enjoyed it, and see you in the next video. Hey guys, this is Martin, and in today's lab we are looking at SQL injection with filter bypass via XML encoding. So number one, the input obviously is XML, and then number two, there's probably a WAF in place, like a web application firewall, which filters certain SQL commands for a security reason, but this can be bypassed, right? So the vulnerability is here in the stock check feature on the website. And we also know that there is a database called users, and there are usernames and password columns in there of registered users. And now to solve this, we need to find a bypass effectively. So let's head over to the web application and let's just choose a product, right? Like choose the first product here, and there's the stock check feature. And if I use this, I see 851 units available in stock. So let's take the stock request and send it to repeater to play with it. And then let's take a look at the store ID. I could take a look at the product ID first, but it doesn't really matter, like the order, but you want to test all of those. So what happens if I put in like a union select and then username, and we were given also the passwords, right? Like, so there's a passwords column as well. So password, and then we were given a table called users, right? So let's put this in and hit send, and nothing's happening, right? So there it says an attack has been detected. So this is when extensions come in handy in Burp. Like there is, for example, an extension called HackVerter, which assists you with all kind of encoding and decoding and modifying payloads and stuff like that. So if I think this is correct, like as in a SQL query, then I can simply right click here, go to extensions, say HackVerter, and then I can say, hey, I want to encode and I want to use hex entities, for example. I could try all of those, right? Like in reality, you will go through and you don't know, you have not too much information in the back end, but let's say I'm using hex entities, and then what happens here is basically, you see, this is now put into hex entities tags effectively, right? And if I hit send now, I actually get my output. So my SQL injection was successful. The administrators have only blocked the most basic union select, but they did not consider what happens if I actually encode this into hex entities, right? And this could work like with other encoding mechanisms, but HackVerter is a really spectacular free tool. It's an extension for Burp, and I highly recommend using it. And then you would simply come over here and you put in administrator and the password we retrieved, and that solves the lab. Okay, so that was an example of SQL injection via filter bypass if there's a WAF in place. And by no means this is the only way to bypass this, and it always depends on specific scenarios, but HackVerter really can help you in bypassing WAFs in the middle. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we're in the cross-site scripting section, and today's lab is DOM XSS in document write sync using the source location search, as in one of our previous labs, but this time inside a select element. Okay, so this is a DOM cross-site scripting vulnerability. Again, DOM cross-site scripting happens all locally with client-side JavaScript, so there's no server interaction involved, and we are talking about sources in sync. The source is basically a user controllable location.search, and the sync is the document write, which basically puts the content out on the website. And this makes it a cross-site scripting vulnerability because there is no sanitization or encoding configured. So I'm going to show you how to approach this. So we have our our website here, right? So we go to a product, and then we basically see that we can check the stock here for the number of available units. Now, first things first, which I would do is view the page source. So if there is any interesting script or something, so I can search for script, right? And then I see description, and I got actually 11 matches. So let's scroll down a bit. Here's something interesting. Here's basically a script, a JavaScript, which defines the variable stores. And then you can see that the location search takes in a store ID. Okay, so this is interesting. I take this out first. There's a store ID, and then that store ID is basically used in the document write without any sanitization, right? And what I can do is basically I can take a look at this in Inspector as well, like down here. So I can go in there and do a right click and inspect. So that shows me the DOM, right? The source code, it doesn't have the DOM modified information, like when there is an H script or a script running and it appends things to the DOM. You only see this in the DOM itself, right? But here we basically have our store ID. Here's our script. And effectively what's going to happen is, well, let's start playing with that store ID first and foremost. So let's take this URL out, right? And we basically have a product ID in there. And now what happens if I say and store ID equals 1, right? So for example, and store ID equals 1, because we clearly know that from the search, this is being taken in, right? Like I do this and yeah, no errors, no nothing, but it also didn't show anything. Now, if I go back down here and inspect that element again, I see that there is basically, if you are in one of those options, right? Like here, this was selected. See that was my input. That was the store ID. And now I need to break out of the store ID first because I want to introduce a cross-site scripting payload. But what I have to do first is basically I go back in here and now I say double quotes and then angle bracket and then I need to break out of the options tag as well. Options tag, and then I put in my name, Martin, right? And then see how this reflects it. So let me take a look here on Martin. And as you can see, is I was not completely able to break out, and I can also tell you why, because I need to break out of the select, not the options. So I need to break out of the select tag. So basically, let me go back up here and say select and see what happens. And now I look for Martin again. And now you can see I have successfully broken out of this. So I closed the store ID attribute. And then after that, I was able to close out the select tag. Okay, perfect. So now I'm free, and now instead of Martin, I can actually put in like an image, src image source equals x on error equals alert 0. So what that does basically is trying to load an image tag from the source X, which does not exist, which subsequently throws an error and then pops up the alert 0 box. And let's see if that works. And it does. And it has successfully executed my DOM XSS. And this solves the lab. And that's another example of a DOM cross-site scripting. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin again. We are in the cross-site scripting section, and today's lab is DOM XSS in an Angular JS expression with angle brackets and double quotes HTML encoded. So that's important to know already. So you already know that angle brackets won't work and double quotes won't work either. And so Angular JS is like a really popular JavaScript library, which is heavily in use. And it contains something called the ng-app attribute. Okay, so this basically allows you to execute JavaScript expressions within double curly braces, right? Like, so this is a special feature which is meant to be not abused, but if it's not sanitized properly, you can actually get cross-site scripting through JS or through JavaScript as well. Okay, so let's fire up the lab and see how we're going to exploit this. Once again, this is a DOM XSS, so that means it's all taking place locally, client-side JavaScript. So there's no server involvement like with the classic XSS or something. This is all happening locally in the DOM. Okay, let's go here first, and let's just start searching for Martin, for example, in our blog. And we take a look at our history, and we look at the search, and then we send this over to repeater, we send it once more, and then we start taking a look at the code, right? Like, and so basically nothing interesting here, but when the body starts up, right? Like in a minute the body starts up, it starts with the ng-app, and that is like an indication for you that Angular JS is being used here. It's not always for granted because there is obviously security mechanisms to make this secure, but this is something you would test out for. So when you now let's look for app if we see any other references here, and it's only that, right? So it just says body and g-app, but that's basically a keyword. Now what you can do is you can go over to book.hacktricks.xyz, and it has pretty good write-ups around the whole thing. Like it again explains like what Angular JS is, the ng-app attribute, what it's supposed to do, and it's supposed to allow you with running JavaScript in curly braces and things like that. And here you get the syntax. So you can just go in and try one of those syntaxes and see what actually works, or if it actually fires. So if you take this, put it into our search bar, hit enter, then we get our cross-site scripting payload, because we were on constructor, which is like an instruction here in Angular JS, was able to basically give us the pop-up box, as you can see this here. So this is again client-side JavaScript vulnerability. You can use a tool called DOM Invader, which is very, very good at those kind of things as well. And I highly recommend using it in commercial tests or in bug bounty hunting. But for the sake of these labs, I do most of them manually to explain you what's actually going on behind the scenes. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin again. We are in the cross-site scripting section, and this lab is reflected DOM XSS. So basically in DOM XSS, you have two components. Number one is something called a source, and the source is usually the user input or untrusted user input, and then you have a sink which passes it to an insecure function. Okay, so in this lab, our goal is to effectively inject JavaScript in order to get a cross-site scripting attack going and a reflected cross-site scripting attack, so it's not being stored. For that matter, we are going to go over to the lab, and we simply do a normal search function first and foremost, right? So I'm going to search for Martin. I head over to repeater. I take a look at this, and what I immediately see are two things basically. Number one is this is my search, right? So this is my actual search which I've done, and then you can also see that there is a search result.js. Let me send this over as well. So this is the get function, and then we have the search results.js, which is a JavaScript which is being loaded, and then we basically have the actual result. So let me send this to repeater as well. So we got those three here. So this is this is the actual search, right? And then I simply get a 200 response on the actual search, and it says like, nah, nothing was found for Martin. So I can see where do I actually see Martin in there. So you can see this, it's not even showing, or it's not even reflected on that page. And that's for the reason because it uses that search result.js JavaScript. And here you can see there is like a JavaScript function. And what's good practice always is like to look for certain keywords, like for example, eval, right? So it's making an Ajax call effectively, and it's taking the variable search results and it passes that in the eval function, and then it's being displayed as the result object. So this is a dangerous function because it's not sanitized. It's basically taking user input and is passing it unchecked to the eval functionality, which is a dangerous function. Okay, so let's head over to the actual search results, which is this one here. And you can see what's happening is I get a JSON, an application JSON response. And the first thing I'm going to try to do is I want to break out of this, right? Like, so if I put double quotes, Martin again, can I break out of this? And I cannot. So you see what happens here. It puts a forward slash and then the double quotes. So it's basically sanitizing this. But I wonder what happens if I would actually say forward slash, like something like this, right? Like, so if I put a forward slash in front of the double quotes, I may be able to bypass that filter and it accepts it. And actually, look, it does. So this is a first good step. And then now instead of saying Martin, I can actually say like alert 0, and then I close the curly bracket. So I break out, or basically I close that JSON function, and then afterwards I put 2 double slashes, which basically means ignore everything afterwards. So let's try this, and you see we were able to successfully actually break out. And what I'm going to do now is simply I'm loading this in the browser, show response in the browser. I'm not sure if this is going to work because there is actually the JavaScript which has to be invoked. So yeah, this doesn't work on its own. So what I need to do is I actually need to go back to my search bar and then insert this payload manually. And by doing so, I follow the 3 steps. So I have this input, and then it's being passed on to the JavaScript file, and then I get my output result. So let's see how this works, because it needs to be processed by the JavaScript in order to be passed to the eval function, right? So I do this, hit search, and here we go. So my cross-site scripting payload was successfully executed. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the cross-site scripting section, and today's lab is stored DOM XSS. So the lab has a stored DOM vulnerability in the block comment functionality, and to solve this lab, we need to call the alert function. Okay, pretty straightforward, but there is a filter which we need to bypass. So let's head over. Let's first of all look at the comment function. So I'm going here in the comment function, and I simply add a basic cross-site scripting payload, like something like this. So image source means like load an image from that source, and then if that source doesn't exist, and if it doesn't exist, then throw an error, basically. So pretty straightforward. I put in test.com. Okay, so I post this comment, and I go back to the blog. And what happened is I can see it, right? I can see it here. But if I look at the page source and I look for alert, I should be, or what was it? Image source, img source, img src. So I don't find it. Okay. The reason for that is because it's a DOM XSS. It's not a regular XSS. So this all happens in the DOM. So let's take a look at the inspect element. Let's do this. And we basically see that it has been taking this input, but it's basically displaying it as text, right? So it's in the paragraph tag. So something is preventing this from firing. Now I presume this is the angle brackets, right? So what we can do, what is a good practice is basically head over, go to the target, and take a look if there is any JavaScript files or something like this. Like, yeah, this looks interesting, and then send this to repeater. So this is effectively a JavaScript file which is being loaded. And let's take a look at this, what it actually does. So we have an AJAX call to start with, and it does a GET request and whatnot. So this is all not interesting. What immediately stands out is this. It says function escape HTML. That sounds like, hey, they're escaping HTML. And what they're doing is they're replacing the, when it's being rendered, they're basically replacing the open angle bracket with this string, and they're replacing the closed angle bracket with that string. Now this is interesting. But what I immediately read, and this is before it's being passed to the eval function, right? What I immediately read out of this is it's only checking for the occurrence of these angle brackets once. So if it's more than once in there, maybe it only checks on the first one. And by the looks of it, it's only replacing one set of these angle brackets. So there is one way to find out. We head back to our blog and we make another post, basically. But this time, let's try something like this. Let's do this. Open angle bracket, closed angle bracket, and then our payload. And if my assumption is right, it should basically fire the XSS simply for the fact because based on the JavaScript code, it's only doing this replacement function once as sanitization. So let's post this and let's go back to the blog. And you can see my XSS has now fired because it was in fact just filtering out the first set of angle brackets, but the other ones were passed unchecked. So this is like a logic vulnerability on the developer's part. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin here. We are in the cross-site scripting section, and today's lab is exploiting cross-site scripting to steal cookies. Okay, so so far all the exploits we have fired is just a pop-up window, which is a proof of concept, which is typically fine for bug bounty hunting and things like that, just to show that it's possible to execute JavaScript. But in a penetration test or something like this, or in like a red team engagement, you would want to exploit it to that level that you steal cookies and then perform an account takeover and those kind of things, right? Like to see if there's any lateral movement later on and stuff like that. So basically we have a stored XSS vulnerability, but this time, instead of just firing an alert 0, we are going in and exfiltrate the cookie of that person who is basically browsing to that website, and then the cross-site scripting payload will fire, and then the cookie is being leaked. So that's exactly what we are going to do. So there's numerous payloads for this. And one thing I remember, I can highly recommend is the book.hacktricks.xyz. And there in the cross-site scripting section, you have like a ton of ready to go payloads. And here's one which I'm going to use, which is basically one specifically for Burp Collaborator. So all I need to do here is like I need to exchange, I need to fill in my Burp Collaborator, which I can get here. So let me open a new one, copy to clipboard, and then I simply paste this in here. And this is my payload effectively. And what this does is it's basically when it's being executed, it is going to exfiltrate the cookie, right, to this domain. It does a post, no course mode, so don't worry about that. But the body document cookie is basically what I'm exfiltrating. This is what I'm interested in. And that's what I'm going to do. And then I just fill in here like my test information, and I will post the comment. And now I'm hoping that an unsuspecting user is browsing to this comment and wants to read that comment post. So I go over to Burp Collaborator and then I say poll now, right? And what I see is I got actually interaction. So I have a DNS query first and foremost, which is not that interesting. Another DNS query. Basically, so I get the IP address of the server, but what is interesting is basically the HTTP one, because this was the post which has been sent. And you can see there is like the secret and the session which has been sent over. So this is from the victim effectively, right? And what I can do now is I copy this out, and this is called secret. And I use a cookie editor over here and go into session, and I basically add the secret and put that in, and then I refresh the page and see if this is enough already, which it's not. Okay, that's fair enough. So let's copy the session out as well. So let's copy the session out here and go to the cookie editor, and let's go into the session cookie and modify this, save it, and then reload the page. And now the lab is solved. So basically what I've done now, I've impersonated that user, whoever that was. I don't see this in the lab, but whoever that user was, I was able to successfully exfiltrate the secret and the session cookie, both of them. And then I simply used the tool, like an add-on here in Firefox or in Chrome called Cookie Editor, where I then can manipulate my cookies in the current browser, and that gave me access. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and today's lab in the cross-site scripting section is exploiting cross-site scripting to capture passwords. So this is an interesting lab because typically what you do is, you pop up the alert box or you exfiltrate a cookie like in the previous lab, but there is numerous other ways. In the minute you can execute JavaScript, you basically can do a lot of nasty things, right? And so in this example here, I'm going to show you like how to put like a username and password box, and then unsuspecting users might go there and may enter their credentials, which are then exfiltrated to Burp Collaborator. Okay, so let's go in here. And basically what I'm going to do is I go to my favorite page here. Again, it's called book.hacktricks.xyz, and you have a lot of useful payloads here, like this one, for example. So I can copy the whole thing out, basically, and then put it into a text editor, and then I can start modifying it. So it's effectively, this is HTML, right? And it's like an input field, username with an ID of username, then the password, and then on change, which means like, hey, when this is being submitted, then what's going to happen is it shall simply send this on to the Burp Collaborator. So I need to obviously fill in my correct Burp Collaborator. Let's open a new one here and copy this over, put it in here, and then it's the post method, no course, and basically the username and the password are being exfiltrated here. So let's put this in. Let's put this in our blog comment instead. That's obviously assuming that there's no defenses in place like filtering angle brackets and things like that, right? But so let's put in our details and see what happens next. So I do a post comment, and then I actually go back to the blog, and then if I want to see it, I can see something like this. See that? So I have this username and password, and if someone would enter this, I would be able to exfiltrate this. And maybe someone already did, so let me do a poll here. And what I see immediately after the two DNS interactions, there's an HTTP interaction. And let's take a closer look what happened there. And basically what I was able to gather is the administrator. So the administrator filled in their details into that box, and then it was exfiltrated. So I have the username of the administrator, which is administrator, and I also have the password. So let's head over to our account and log in as administrator with that exfiltrated password, and that solves the lab basically. So this is another example how you can exploit cross-site scripting to do various things. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the cross-site scripting section, and today we are going to take a look at exploiting cross-site scripting in order to perform CSRF. So basically chaining attacks together if you want. So there is a stored vulnerability cross-site scripting in the block section once again, but this time around we want to exploit that vulnerability in order to launch a CSRF attack and change the email of someone who views the blog comment. So we want to perform an account takeover. So this is basically chaining it together. So let's log in first, right? And take a look on how the functionality actually works. So how do I change my email address? So I have vina@normaluser.net, and then I say 1@1.com, for example. And then I hit update email, and I go over to Burp, and I take a look in the proxy history, like how this actually looks like. So I'm sending a post request to my account change email, right? And what you immediately spot is there's a CSRF token in there. So that means if I load, right, and this is probably going to change at each request. So what I need to check here is if I go to get my account, like my main page, and I look for CSRF over here, and I should find that token, right, somewhere. There should be a token. There it is. This is basically the token. When I loaded the page, this CSRF token was presented to the user. Now, I don't know this, but because the cross-site scripting exploit will be executed under the user itself, it will effectively, it doesn't really matter what that CSRF token is. It does matter, but what you need to consider is you need to simply read this out from the get page, and then you use it in your exploit, and you can dynamically do that. So it sounds all super complicated, but it's actually straightforward. One resource I recommend always is like book at hacktricks.xyz, and you simply go over there and you find payloads for pretty much everything. And all you have to do then is like to modify them so that you can make them work for your specific scenario. So let's take a look at this script, at the skeleton, and see if this is fine. So it's initiating like a new AJAX request, right? And then we need to handle the response. And first of all, we need to open my account, right? Like you remember, we need to open my account, which is basically this page here. So this is the first thing which needs to happen when the cross-site scripting executes the script. And then in the next steps, basically we are defining a token, and we are taking the response from above, from the my account, and we match on a name called CSRF, because we know here that this is the name, the CSRF for the token, right? So we basically need to exfiltrate that value. We need to take that value. And then we are basically doing another AJAX request, but this time it's a post request to my account change email. That's what I shown you earlier in Burp. But it's very important that the token which we have exfiltrated from the get request is being sent along, because otherwise it will fail. Otherwise there will be a CSRF protection, but because the script runs under that user, which basically gets CSRFed, I have access to that token. I just need to dynamically build it into it, right? If that makes sense. So let me copy the script and put it into the blog functionality. Let's go here first, right? And we go into a blog post, and then we simply paste it in here, and we say test and test and test again, and then we simply post that comment. And now the lab is solved because it obviously worked. But if we can see it in action, let's see if we can see this in action as well. So I visited this as well right now. Nothing happened, so there was no pop-up box, but in the background, if I go back to my account, the email now should say attacker at attacker.com, which it didn't, right? So this is probably a Portswigger lab kind of thing, because it wasn't intended. I was just trying to see if this worked. And so I load the page, and then JavaScript is being executed. And what I should see is actually that my email is changing to attacker@attacker.com. And it obviously worked. The lab was solved. It worked for the actual victim, but I couldn't show you this on my own account. But this is probably a limitation in the lab. But that's an example how to exploit cross-site scripting in order to perform CSRF. Okay, I hope this makes sense, and see you in the next lab. Hey guys, this is Martin, and in today's cross-site scripting lab, we are taking a look at the reflected cross-site scripting into HTML context, so a pretty straightforward reflected XSS. However, most tags and attributes are blocked. So you will often find this, that there is WAFs in place, or there's filters in place and things like that. And then it just doesn't work with like the standard attributes, right? However, you can often still get cross-site scripting going, and we will take a look on how to deal with that. So if we come over here, like this is our blog, and if I enter like a standard script tag, right, like something like this, and I hit search, I get immediately a script or the tag is not allowed, right? So this is obviously not good. That means there's some filter in place. So if I head over here and I'm sending this request to the repeater, and then basically this was my script tag. So what I'm going to do is I'm just using like the brackets at the moment without any tag in there, and then I send this over to intruder. Okay, so in intruder now, first of all, my first task is I want to find out what kind of tags are allowed, right? So this is why I put my blank payload position in there. Then I head over to the cross-site scripting cheat sheet from Portswigger, and I copy the tags into a clipboard. Okay, so now I want to see which tag is actually allowed, right? So I go over to payloads, I paste it in here. That's 152, and I run the attack. And in most cases, I should get a 400. So a 400 is basically the response we have just seen, tag not allowed. So the address tag is not allowed, animate tag is not allowed, and so forth, right? So if I now search with 200, I see the body tag is actually allowed, right? So this is kind of interesting, because I did not get an error, right? So I take the body tag again, and I again send it to intruder, into another intruder session. And then in there, I put a %20, which is a blank, and then equals 1, right? So let's do this. So I will now insert here another payload. And so what I'm saying now is open bracket, body, blank, and then I need to put an event handler in there basically. And then it says 1, like for example, print 1, or alert equals 1, or something like this, right? So once again, I'm going over to the cheat sheet, but this time I'm copying the events, and those are basically the events. And I head over here, I put them in my payloads, paste them, it's 109 events, and then I start the attack once more. Okay, so once this is done, I will search again for 200s. And there is like on before input, on rate change, on resize, and on scroll end. All had a 200, so they are being accepted. So if I take the on resize, for example, so what that effectively means is, so let me show you this. So I'm copying this out. This is effectively, that means body, and let me remove the URL encoding, on resize equals 1. Okay, so this is something which works. So now I know I can use the body tag, and I can use the event handler on resize. So what I'm going to do is basically I can create an iframe. I can create an iframe which looks similar to this, and let me copy the whole iframe and show you this in Decoder step by step, like what is happening here. I'm putting this into the decoder because then you can read it nicer because there's URL encoding in there already. So it says iframe source, so load the source, which is basically my search function. So that's the search function on that URL. And then body on resize. So remember, body and on resize were the two which were allowed, and then the print function. And then basically here on load. So when it's being loaded, then this is being that function is being executed effectively, right? So what I'm going to do is I put this payload on my exploit server here, and you can see it here. So this is exactly the same thing, but the difference is it's a reflected XSS, and the user would need to type the payload into the search box. And what you do with an iframe is basically you take that search into an iframe, and then when the user loads it, it fires automatically, right? Because otherwise the user would need to type it in, and it's very unlikely. So let's do a few exploits, see if this works. So this is what the victim is going to see, and you see it works. So it's basically calling the print function. And then in order to solve the lab, you simply have to send this to the victim. And then once the victim clicks the link, then this is being executed in the context of the victim. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin again, cross-site scripting section, and today's lab is reflected cross-site scripting into HTML context, but this time around with all tags blocked except for custom ones. So if you remember from the previous lab, we were using the Portswigger cheat sheet, and then we used Burp Intruder to go through all these different tags and see which tags were allowed. So this time around, none of these common tags are allowed, but there is still the possibility to bypass this, okay? And we are going to take a look in the lab. So before we do that, I would like to show you again one of my favorite pages, book.hacktricks.xyz. And if you go to the cross-site scripting section, you will find there is something called custom tags. So if you don't find a valid tag, or all the valid tags are basically blocked, then you can create a custom tag, okay? And the custom tag will then use the onFocus attribute within. So custom tag, what I mean by this is, for example, I just call this here XSS or something. Okay, I could call it Martin, or I could give it any name, like something which is definitely not blocked, right? And then in there, so let's take this payload out and analyze this in Burp Decoder. So I'm going over to Decoder, and I'm decoding this because it has URL encoding in, so you can read it better. But basically, I'm assigning it like a custom tag XSS ID equals X, and then onFocus, which basically happens when this thing is loaded, will fire the document cookie, right? So this is like a classic bypass method. And what I do with this is the same what I've done in the previous lab. If I go over to my exploit server, I will simply put this search query, as you can see it here, into an iframe. And the reason I'm doing this is because it's a reflected XSS, and the customer or the victim effectively would need to type this payload into the search bar. And it's very unlikely to happen, right? So what happens is this script gets fired, attacker visits that website, and then it tries to load the iframe with that search query attached. And if you take a look how this looks like, is basically here's your iframe, or you don't even see the iframe, but the alert fires right away, right? So, and then you get 0 search results for that. And if we go back to the exploit server and we deliver this over to the victim, it should solve the lab because it will then be executed, the JavaScript will be executed within the context of the victim. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the cross-site scripting section, reflected XSS with some SVG markup allowed. So SVG is a graphic format which often is allowed for picture uploads, and developers often don't realize that it can introduce security risks. In that respect, that within SVG you can embed JavaScript code, and then this is being executed at the ingestion point, basically, right? So this lab here is similar to one of the ones we have done before, where we need to brute force our tags first, and then we need to brute force our events to see what is actually allowed. So if you come over here, you have your cross-site scripting cheat sheet from Portsquigger, and in the interest of time, I have already done some testings. So basically, this one here, I was making a request, and the request basically was for all different tags, right? So what I got back is that there's 4 tags which were allowed, where I got the response a successful 200, which was title, SVG, image, and animate transform, right? So I simply run the burp intruder through this effectively, right? And so I know I can start off with the SVG tag, and then as a second one to actually initiate our payload, I use the animate transform, right? And then I reran the whole thing again, basically. And what I got back is for the events, like you can see here, like I hard coded SVG and animate transform, then I put a blank in between, and then I was basically brute forcing for the event which is being allowed. So the on begin equals 1 was the only one allowed, basically. But that should be enough to actually give me my payload for this exercise. And if this is unclear, go back to one of the previous videos where we have exactly done that, where we brute force the tags first and then the events second. Okay, so let me copy my lab ID here and replace it in our URL. So all this is doing now, it's calling the search functionality, and then you will see that there's a lot of URL encoding in there. So what I'm going to do is I show you this in the decoder so it's easier to read. So I go in here and say, like, decode me this as URL, and then this is how it looks like undecoded, right, or decoded. So basically my URL and then the search. What I'm doing in the search is, first of all, I'm closing any existing tag out with the double quotes and the closing bracket. Then I introduce my SVG tag first and foremost, and then within that, I basically say animate transform on begin equals alert 1. So fire me an alert effectively, right? So I'm taking this URL and I am going to copy it out and come over here, put it in there, and I got a timeout, which, let's just check something real quick. Yeah, it's the server seems to have timeout. Let's fire it up again real quick. Access the lab. So, I mean, these Portsquigger labs are all free, right? So sometimes things go wrong. Yeah, it's basically, there seems to be a server problem on their end at the moment. But yeah, nonetheless, so this would give you the pop-up effectively. So this is your payload, and the methodology, I think, is clear. If it's unclear, just go back to one of the previous labs and study that again, like how you brute force the different tags and the different events. Hope that makes sense, and I see you in one of the next videos. Hey guys, this is Martin, and we are in the cross-site scripting section, and today's lab is a reflected cross-site scripting attack in a canonical link tag. So basically what's happening is that the lab reflects user input in a canonical link tab, but it escapes angle brackets. So your standard cross-site scripting attack will not be possible. However, there is certain bypasses you can use, and we will take a look at one of them today. So if I go in here and I append a question mark at the end and I say Martin, for example, this is like my first test, right? And then I'm going over to Burp and I'm going to check what actually happened here, right? So I'm sending this to repeater. And if I go to repeater, I send it and I see that Martin is being reflected here. So the first thing I can try here is basically I need to keep, so that there's an href attribute, but I need to actually close my current one. I need to close my current one out, something like this, right? And then I put Martin again, and then I see how it reflects this. And this looks good. So I'm actually able to introduce the tick value here. So it's not being filtered or sanitized or anything. And instead of Martin, I can use something called access key. So access key is like a functionality which when there is a keyboard combination clicked or a certain value is being clicked, then this is being a code is run or something. Like this is like to initiate a JavaScript initiation or something. Okay, so I say access key equals, and then I want to do this when the button or when the X is being clicked. So this could be anything. I could use this A, B, C, number one, like whatever it is, right? And then let me send this and see how this is being reflected. So this looks good. So access key X. So I introduced this as a new like event handler in here. Access key X, and you see there is a tick at the end, which is automatically being added, which is great. So the next thing I want to do is I say on click. So this is basically my action point. So when this X is clicked, right, then something shall happen. And what do I want to happen is simply an alert function, right? So I put a tick again because the alert has to be within the tick, like an alert one, but I do not need to introduce like another tick because it's already closing it here. You can see that. So if I send this, this should be basically my payload now. So what's happening is, sorry, I forgot completely something, I think. On click equals. So this looks good now. So I have my access key X. When it's being clicked, an alert is fired, right? So how can I test this? Well, I can basically go over, and this doesn't work in all browsers alike, right? Like, so for example, this works only in Chrome in this specific instance. So let's take this URL and let me explain this in more detail in the decoder. So if I put it into the decoder here, you can see like we start off with the access key click X. So I choose the access key X, and then when this X is clicked, the alert one is being fired. Okay, simple as that. So this is tricky to actually execute in the real world, and the reason why it's tricky because it needs some social engineering, and effectively in order to initiate this, you need to click on the Mac keyboard. You need to click the Control option and then X key. And then that initiates the cross-site scripting, as you can see on the screen. But to get a user to do this, it would require some social engineering, like an email to, hey, please follow this for security updates. You need to do something in your browser, or la 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 la. And then it may work, but it requires user interaction. That's why it's not easily to pull off. Okay, I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin, and today's lab is a reflected cross-site scripting into a JavaScript string with the single quote character and the backslash being escaped. So you cannot use either of them in order to pull off the functionality. So this lab has a query tracking functionality, and the reflection is basically in a JavaScript string. So let's head over to the lab and let's start with some basic payload. So I enter my name in here and then see what the output is. So I head over to the proxy and send this over to repeater and send it on, and then I look for Martin and I want to see where this is being reflected. So I get two matches. One is in the H1 tag, which you would also test in a real engagement, but what I'm interested in today is there's a variable search term, so it's a JavaScript string. So first thing I try to do always is like to break out of it, right? Like, so I see it finishes like with a tick, and then if I say tick Martin, what happens? So let's take a look, and you'll see that the problem here is that it's basically escaped, right? Like, so it's putting this backslash in front of it, so it's escaping that character. So not good for me because obviously this doesn't work. Then what can I do next? Well, I can try something else. So I see there's a script tag here, right? So there's a script tag. So what happens if I actually say Martin and then I close that script tag and then I put hello? And let's see what happens. Let's go down. And this looks good, right? Like, because what I see here, the closing script tag, there was no sanitization done at all. So basically, I was allowed to introduce this here. So this is pretty good. And then now up here, you see like in the search results, like in the H1 tag, it actually successfully encoded this. So it's not vulnerable in here, but it's vulnerable in the JavaScript string basically. So I've closed the script tag. The script tag starts here. Now I closed it. And now what happens if I then put in, instead of hello, I put another script tag, and an opening one, an alert 0, and I close that script tag out. See what happens. And let's move down here. And you can see this looks quite good actually, right? Like it's opening a new script tag. It has my JavaScript in there, and then it closes the script tag. So let me run this. Let me show the response in the browser. I actually, you know what? Let me take this payload from here and then simply put it into the search box like this. Hit search, and you see my cross-site scripting was successfully executed. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and in today's lab we are going to take a look at the reflected XSS into a JavaScript string like in the previous lab, but this time with angle brackets and double quotes HTML encoded. So there's protection mechanisms on the angle brackets and on the double quotes. So they are HTML encoded, and the single quotes are being escaped. Okay, so multiple defense mechanisms which we have to overcome, but it may still be possible in certain scenarios. So let's head over and put in a normal search term like my name once again. So I'm searching for Martin, and I want to see in Burp what actually happened, right? So I'm sending this to Repeater to play with it, resend it one more time, and I'm looking for Martin, and you see it's being reflected here in the H1 tag, which we're not interested in today, but we are actually interested in the search term, right? Like in the variable, this is the JavaScript string basically. So first test first is I will say Martin, and then I say payload, right? So I'm putting a tick in there and see if I can break out of this JavaScript string. And the result is basically no. I cannot do this, and reason I cannot do this is because it's being escaped. As you can see here, it's basically escaping that character, which is no good. Okay, so then my next test will be, hey, what happens if I actually put the backslash in there myself, like the escape sign, and see what happens here. And so basically I can see, hey, this has not been escaped. So maybe I can now try to introduce like a tick. So maybe I can instruct it to not escape the tick. And this looks good now, right? Like you see that? So basically right now it looks more like, hey, I was able to actually introduce this because it's only escaping it once. But the second one, well, this is server introduced, and that's my input basically. So this is what you see here reflected. And what if I now say alert 1, something like this, and see what the result would be. And this looks good, right? Like this looks like it has taken it, but it will probably mess up the code. So what I'm going to do is I instruct it to ignore everything afterwards with the 2 forward slashes. So in order not to create an error or something like this. So let's check this. And if this is not being escaped, no, this looks good. So basically I have now a working payload, or it should be a working payload. So let me just verify this. Let me copy it and head over and search for this. And if all goes well, I should get my pop-up. And yes, so I was able to bypass all the filters they had in place and get my reflective cross-site scripting vulnerability executed. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and today's lab is a stored cross-site scripting vulnerability where the input is being reflected into the on-click event. However, angle brackets and double quotes are HTML encoded, and single quotes backslash escaped. Okay, so effectively, as you read through this, there is a lot of filtering going on. but let's see if we still find a way to exploit that. So let's head over to the lab, and we see there's a blog functionality, and we simply go in here and we start blogging something, and we call this Martin at martin.com, and then HTTP. Let's call this Martin as well for consistency, right? So we send this post, and we go back to the blog post, and we head over to Repeater. So first of all, I want to find these two. So this was my post. I send it to Repeater, and then the retrieval, I send it to Repeater as well. So the first one is the post I actually made, as you see, and the second one is retrieving it. Now, I'm more interested in the second one because obviously I want to see where this was all reflected. And I can see various things here. So first of all, I see there's an href, which could be potentially vulnerable to like a JavaScript execution or something, but in this case it's not. We are focused here on the on-click event. So what's happening in the on-click event is when this is being clicked, so when this href is being clicked, there is some magic going on here, and effectively it will be like this tracker will track. So I don't know the backend code for this, but basically it will do a redirect most likely to martin.com. Okay, so now my question is, from a security researcher perspective, can I introduce like a JavaScript kind of payload or something like this? So what would happen if I go back here, and if I make another post and I say, this time I call it test.com, and in the website I actually put something like Martin and then question mark, and then I try to get an alert 0 going here, right? Like something like this, like a basic payload should be working fine, right? Like maybe this works. So let's post it. And let's go back to the blog, and here you see the problem, right? So you see in the left-hand corner that it basically escaped my ticks, right? My single ticks. And in the lab description, it actually said that, right? Like single quotes are being escaped. And so this is no good. But then I'm wondering, hey, what if I use another encoding method for this, right? Like, so for example, let me show you this here in the decoder. This is what I just tried, right? So this is what I just tried and it didn't work. So what if I replace the ticks with HTML encoding, which would then look like this, and apos semicolon, and then to finish it, like the finishing tick would be single quote, would be and apos semicolon as well. So maybe this works, right? Like, so it's all about trial and error. And let's take this payload, and this time around we know that it didn't work with single quotes on its own. So let's try this again. And this time we put in this payload we have just taken here. So let me copy this. Excuse me. And we put this in here. We post a comment. And I have a mistake in there. So let's post it. And it takes a bit, and we go back. And you see it already solved the lab. But basically, if I now click this here, I have my alert function, and you can see clearly that the ticks are visible, and it should fire it when I click it, and it does. Yeah. And so I was able to bypass this filter. If I used single quotes on their own, it didn't work basically because they were escaped. But if I HTML encoded them, the server was tricked, and the correct payload was triggered. So I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and today's lab is a reflected cross-site scripting vulnerability, this time into a template literal in JavaScript, and with angle brackets, single quotes, double quotes, backslash, and backticks are all Unicode escaped. So a lot of filtering taking place here, but there is still ways to overcome this. So first and foremost, like whenever I hear template literal or something like this, or into a JavaScript literal, you basically want to check out this website here, which is called book.hacktricks.xyz. And so there's a nice section in the cross-site scripting vulnerability section where it says basically inside JavaScript code. So that gives you like the options where it's basically being reflected and what kind of payloads you could introduce. But before we look at this, we actually head over to the lab and we simply add our name here again and see where this is being reflected. So this is always my standard testing methodology. So I send this over to repeater, and then I want to see where Martin is being reflected. And you can see it's in a template literal because you see the backticks here, right? So you see the backticks. So as the lab already told us, so first and foremost, it's in a script tag, right? And it takes the search message and it's basically using the inner text message. So it's basically outputting it on the website. So this is where the danger comes from, because it simply takes unsanitized input, or kind of sanitized input, because it does some filtering, but the developers forgot to introduce certain things or certain filters. So let's head over to this website again, and we see it is reflected, right? So as you can see, it's being reflected here in something like this, like the template literal, so inside the backticks. So what if I use a payload like this and see if I can introduce this successfully? So instead of Martin, I'm now actually replacing Martin with that payload and see where my alert is being reflected. And my alert is being reflected in there, and you can see that even though they have a lot of filtering in place, they did not filter on any of these characters which I introduced. So this should be good now, because this is the search result basically, and then it's being taken and it's being displayed on the website. So the script is effectively executing that code. So let me head back here and try this in the browser. I put this in, and you can see I have my alert box in the lab has been solved. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin here. Today we are in the CSRF section, cross-site request forgery, and our lab is the CSRF lab, where the token validation depends on the request method. Okay, so let's head over, let's get started. Let's take a look at the CSRF implementation first. We log in with the credentials we have been given, and you can see I'm here in my account. And now I want to change my email address to one@one.com. Right? And I hit update email, and I head over to Burp to basically take a look at this request. So let's send it to repeater, and you see instantly that there's a CSRF token, right? So if I send this with the correct CSRF token, I get a 302 found, and that works. However, if I, like, for example, delete the M here, so I make the CSRF token invalid, then basically it says invalid CSRF token, right? So what can I do in order to bypass this? So sometimes there's a vulnerability that if you simply change the request method from post to get or vice versa, it's usually from post to get. So you can come here and say change request method, and now it's a get request. And because it's a get request, the CSRF token is no longer validated, so I can delete it altogether. And then I can say here attacker at one.com, right? So I hit send, and this works, right? So this is great. So now I have my POC. If I refresh the page here, I should see attacker at one.com. Okay, so the CSRF token is no longer validated when it's done via a GET request. And then to solve this lab, basically, you take this out here and you go to engagement tools, you generate a CSRF POC. That's only available, by the way, on Burp Pro, but you copy the HTML text and then you can host this on your website, for example, or wherever you like. So in our lab, we have a dedicated exploit server, and we put it basically here in the exploit server. We change the email address to attacker10 just to see how this works. We store it, and then we view the exploit ourselves to simulate this. And now you can see it has been changed to attacker10. So All which is left to do now is deliver that exploit to the victim. So that means we're sending them a link. They come here to our exploit server. The code is executed in their browser context, and that solves basically the lab. Okay, that should solve the lab. There is a problem at the moment with the port trigger labs. You have seen it's working. Like I can just demonstrate this once again. I can set it to attacker 100. I store it. I view it myself if I was the victim, right? And you can then see that it has been changed to 100. So why it doesn't solve the lab, I don't know. It's probably, my guess is port trigger changed from HTTP 1.1 to HTTP 2 recently, and there may be some flaws in there. Who knows? But this is basically solving the lab, and I look forward to see you in the next one. Hey guys, this is Martin. We are in the CSRF section, cross-site request forgery, and today's lab is CSRF, where the token validation depends on the token being present. So that's another vulnerability I came across numerous times in the wild, that as long as a CSRF token is being supplied or the parameter is being supplied, it checks for it. But if you delete the parameter altogether, then it's no longer checking, and it's basically allowing CSRF attacks to happen. So let's head over to the lab and log in with our own credentials first with Wiener and Peter to take a look at the functionality. And I'm now changing the email to 1@1.com, okay, and hit update email. And I go over to Burp and take a look what actually happened. So this is the change email request, and you can see there's a CSRF token, right? If I change the CSRF token, like I delete something, then it's complaining it's no longer valid, right? So, but what happens if I delete the whole CSRF token, including the parameter altogether, and I send it, then it's all of a sudden accepted. And I can change the email to 2@1.com just to see that this is going to work. And you can see it's now changed to 2@1.com without any CSRF token. So all that's left to do is right-click, go to engagement tools, generate the CSRF POC. It's probably not going to work in the port trigger lab at the moment because they have changed from HTTP 1.1 to HTTP 2 on most requests, as you can see here, and that has messed up the solve the lab functionality, I think. But let's try it regardless. Let's put it here into the body in order to make, well, basically, let me change the value to 111 so that we see the difference. So I store it. The email address was changed to 111@1.com. And then I simply do view the exploit. This is how the victim would experience this. And you can see the email has been successfully changed. And let's try it if it works, if I can deliver this to the victim. So the victim clicks on it, but it doesn't solve the lab because there's a flaw at the moment. But regardless, this is the correct way to solve it. Simply remove the whole token, including the parameter, not just the token itself, but also the parameter on the request, and then you can bypass the CSRF protection. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the CSRF section, cross-site request forgery. And in this lab, we are looking at a CSRF vulnerability where the token is not tied to a user session. So basically, we have been given two accounts. One is Wiener Peter and one is Carlos Montoya in order to stage our attack. Okay, so first and foremost, I have two different browsers here. So those are like virtualized browsers with PawnFox. So to simulate two different user sessions, clearly two different sessions. So I go to the first one and I log in as Wiener Peter, and I go into the second one and I log in as Carlos Montoya. Carlos Montoya. All right, so we're logged in now, and you can see both of these account or email update features have a CSRF token, which is a different CSRF token in both respects, right? So first things first, let's head over. By the way, you can see this is nicely done in Burp, so you get the color coding. So I know exactly yellow is Carlos's account and blue is Vina account, right? So if I head over and I'm doing a change, right? Like, so I'm changing the email first of, sorry, I'm going to change the email of the Vina user. So I'm saying 1@1.com like this. And the email has been changed. Okay, so first, a couple of things to check. I sent this to repeater first of all. And then I see that this is the CSRF token here, right? So if I run this again, I should get a bad request, right? So because the CSRF token was only valid once. So let me refresh this and I get another CSRF token. So I take this CSRF token this time around and see if this works, and then that should go through without a problem. But if I want to replay it again, it doesn't work, right? Because it's invalidated, so it's only one-time use, basically. So I would need to refresh it again and so forth. The vulnerability really here is that I can take a token from someone else's account. Like, let's say I'm the attacker and I'm Carlos, and I only have access to my own CSRF token, but I want to launch the attack against Vina, against the blue guy here, right? And so if I copy that CSRF token, right, and I replace it in the update email of the Vina user, let's see what happens. It works. Okay, so this is the vulnerability here. So basically you can use your own CSRF token, which you can generate yourself, and you can use it as a CSRF token to launch a CSRF attack against another user. So that's the vulnerability. But because they are one-time use, we basically are going to refresh those tokens once again before we build our POC. So we have a new token from Carlos, which we are going to place here, but this time I'm not going to hit send. This time I'm actually going to generate the POC, right? And I copy that POC and I go over to the exploit server, right? So I'm heading over here, go to the exploit server, and I'm putting that into the exploit server. And let me change the email to 111 or something. So we have a differentiator. I store it, and now I launch it as I would launch it from a victim's perspective. If I'm a victim, I click a link, and then I should be getting this. So I launch it, see if it works, and it worked. It changed my email to 111@1.com. Okay, let's go over to the exploit server one more time. Let's put 222 instead, and I need a new CSRF token for the attack. So let me refresh this here. I need a new CSRF token, which I can generate from my own user account. I head over to the exploit server, I replace that CSRF token, and I hit store, and then I'm going to deliver it out to the victim. It's not going to work, probably, and the reason for that is because Burp has done, or Portswigger has done some changes recently, and they migrated from HTTP 1.1 to HTTP 2, and it seems, even though I showed you the proof of concept already that it worked, it is not giving you the lab finished message for some reason. And, oh yeah, on this one it does, perfect. So this basically solves the lab, and I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the CSRF section. So today's lab is a cross-site request forgery, where the token is tied to a non-session cookie. Okay, so this is another vulnerability type we have, and we haven't seen that before. And again, we have been given two accounts to log in. So I'm logged in here with the Vina Peter account. Okay, so I can click on my account, and on the other one, I'm logged in as the Carlos Montoya account. And basically what's going to happen is you can see, like if you head over to Burp, and in Burp, we basically have, this is my account here in the Vina account, and you see that there's a CSRF key and actually a session cookie as well. Okay, so if I hit send, and let me render this. Okay, so if I make a change to the session cookie, I get a redirect, which means I'm being locked out, right? So I need to replay this again with the session cookie. So if I change the session cookie, I get redirected. If I change the CSRF key, I remove the C at the end. And no, I need to show you this on a post request actually, because the CSRF key has no meaning on the GET request. So if I go in here and I change my email address to 1@1.com, and then I hit, let's say I change the CSRF token, I remove the 4, and then I should get an error message, which is called invalid CSRF token, right? So basically what this means is this proves that the token is tied to a non-session cookie effectively. Now, what I can do here is basically, let's take a look at my request, let me redo this one more time so it becomes more obvious. So let's change the email to 2@2.com. Update, and now it's still invalid. So let me do this again. So now we go back in here to @2.com. And now the email was changed successfully. Okay, so let me take this request, that post request, send it to repeater. And you can see that there is these 2 values, right? So if I replay this, it worked. So this time around, we have a CSRF key, we have the session, and down here, we also have a CSRF parameter. Okay, so the problem is, so this is, first of all, this is the session cookie. We leave this untouched for now, but we have a CSRF key and we have a CSRF token. So let's head over and actually refresh this one here, because I want to see my own. So say like I'm Carlos, right? And then I have a certain CSRF key, which is this one here. I'm copying this and I'm putting this in here instead. Okay, and I'm also going over to Burp once more, and I'm copying the actual CSRF token where I need to launch a request first. So c@1.com or something, update email, and this is actually the token here. So this is the CSRF token. Let me copy that, and I copy that over as well here into the CSRF token field. Okay, and then now let me hit send. That's the Vina account, and you see it works. So this is interesting. This is interesting because it works. So I can use the CSRF token and the key from another account, and then it works. So, however, the problem is the CSRF key is being set as a cookie, right? So, and I normally cannot control the cookie of the client, right? So basically what I need to do now is I need to find a way to somehow inject that CSRF key into the victim browser. So what I can do here is I can generate the POC, right? So I can generate the POC request, and you can see this in here. Basically, so let me copy this out. So this is the POC request. But what I'm going to do now is I'm going to delete that script, this auto submit script, and I replace it with something like this. And we will go through this line by line, what's actually happening here. So first and foremost, email is fine. Like I want to change it to anything. So I need to set the CSRF token to the CSRF token from my own account, right? Which is Carlos in this scenario, which is already in there. This is fine. But what I also need to do is I need to inject into the browser. I need to inject into the browser of the victim. I need to inject that CSRF key itself, right? Like this is what we have done in our proof of concept here. So I'm taking this out here. I'm taking this out, and I am actually going to put this in here, right? So this is my CSRF key. This is the attacker CSRF key, not the CSRF key of the victim, right? But I want to inject this in as a cookie value into his or her browser. So I will simply do like an image source, and then I load this, and I load the search functionality, which is on the blog page, and then let me copy this and show you this URL encoded in the decoder because it makes it easier to read. what's actually happening here. So basically what's happening is I'm loading this image source, right? And then I'm doing a search test. So this is basically when the victim visits the website, the image source is loaded, but there's not an image loaded as such, but actually a function is performed which does a test search, and then it sets the cookie, and the cookie will then be set in the victim's browser to that CSRF key of mine. And basically there will be an error thrown because this is not a valid image, and then it will be submitted. On error, I submit this. Okay, so this is just important to understand. And then I can take this over now. I can completely take this, put this into the exploit server, and put this in here into the body, hit store, and now I deliver this over to the victim. And normally this would work, simply for the fact it does not work at this point in time because Portsrigger has changed from HTTP version 1.1 to version 2, and it basically does not work. If I do view the exploit, the email is not available. Okay, I tried. Excuse me, let me run this one more time, because what I've done is I ran the exploit server in the context of my own browser. So I'm doing this now from the victim browser. It didn't accept the email because the email was already taken in the victim account. So let me change the email real quick. Let's say 333 or something, store it again, and then let's try to deliver it over. Maybe it works. And it does, yeah. So it was successfully doing this. It was injecting the cookie and was injecting the CSRF key. And so the key point here to remember is that the victim browser accepts, or the CSRF is possible because both values can be interchanged from the other account. I hope this makes sense. If it's not quite clear, rewatch the video again, step by step, and I see you in the next video. Hey guys, this is Martin. We are in the CSRF section. Today's lab is a CSRF vulnerability where the token is duplicated in the cookie. Okay, so we have our own account where we can log in with Vina and Peter, and then we can see how to exploit this. So first things first, let's head over and enter our username and password. And then we see we have a functionality here where we can update the email address. So I set this to test@test.com, update the email, and I head over to Burp to analyze this in more detail in Burp. Okay, so this was my request, and you see there's a CSRF token, but if you look closely, there is also a CSRF cookie, and they are duplicated. They're exactly the same value. Okay, so if I send this again, it works. Okay, so it's not a one-time token check or any of that in place, so I can reuse the token. But now the interesting part is, like, let's say I have a CSRF token and I set that CSRF cookie to fake, and then I replicate it down here and say fake as well. So let's see if that works, and that works as well. So just to confirm, I say test 1, 2, 3, and then I use a CSRF parameter here called fake, and I also have a CSRF token, basically a cookie, which has the same name, and that worked as well. So let me refresh this, and now it's called test123@test.com. So with that in mind, I can easily control that parameter, right, for in a CSRF attack. Where I will struggle is to actually inject a cookie into the victim's browser. But luckily, we basically have a functionality, and let me show this real quick. We have a functionality here in the lab whereby we can do a search. Like I could do a search here, and then you will see that there is the search parameter. And what I'm going to do now is basically I'm introducing a payload whereby I search for test, and then ignore those URL encoded characters in there. I will show you this in a bit what this actually is. But what this does is basically when I search now, I set the cookie to CSRF equals fake, right? So if I check this, what just happened is you can see that based on my search here, I was basically able, and that's another vulnerability on its own, I was basically enabled to set a cookie which is called fake, right? And this is exactly what I wanted. Now, for this to work in the attack scenario, I basically need to do a bit more. I need to craft an exploit effectively whereby I embed a picture or an image source basically where I set the cookie. So the cookie is automatically being set. Let me explain this real quick, how this works. So first and foremost, I go over to the decoder, I put this in, and then what this basically does, it's loading an image from that source, but instead of loading that image, it's performing the search functionality, which I just demonstrated live in the browser. And it sets the cookie in the victim's browser to CSRF fake. And because there will be an error, right? Because it's not a real image, so there will be an error. And when the error is happening, my POC will be submitted. So in order to make more sense out of this, let's head over here first. Let's head back to our request. Like this is the update, and the update request we have done earlier for the email. So I'll now say hacker@test.com or hacker@hacker.com or something, right? So something like this. And then I generate the POC script with the engagement tools, and I copy this out, and then I put this here into my text editor. But instead of having that script tag down here, I will insert this cookie injecting image source, right? And that's my final payload basically. And I use this, take it to the exploit server, and in the exploit server, I will now basically now store it, and then I deliver it over to the victim. And when the victim visits that exploit server, basically the lab is solved because the email address has been updated. Firstly, the cookie is injected, and then the POC of the CSRF vulnerability is being invoked. I hope this makes sense, and I see you in the next video. Hello, this is Martin, and we are in the cross-site request forgery section. And today's lab is same-site Lex bypass via method override. So you may have come across a scenario where the application sets so-called same-site cookies, which is a prevention mechanism, or it's a mechanism to control what kind of cross-origin requests can be made. And there's three types: none, lax, and strict. And sometimes it's being misconfigured so that you basically can bypass the restrictions. You will see in this lab, so we are going to head over to the lab now. There is these same site cookies are being used. So you will probably spot this immediately because you don't see a CSRF token on the login, and you will also not see a CSRF token on the actual account, right? So basically, we need to understand, first of all, what these same site tokens are. The same site cookies. So if you go to the post request, you see that there is a session cookie set, but because I don't see anything explicitly mentioned like strict or none, it is by default Lex. So we need to understand what this same site Lex option means. So Lex means that the browsers will still send the cookie information in cross requests, which is mandatory for a CSRF attack to work, but only if the following conditions are met. So it has to be a get method, and it has to be initiated by the user from top-level navigation, like clicking a link, for example. So that's important to understand. So my worry here is that if I change this to 1@1.com, that this might be a post request. Okay, so let's take a look, and it actually is a post request, unfortunately. So even though you don't see any obvious CSRF tokens in here, it's still protected as it is right now. It's still protected against, or it's protecting against CSRF attacks, right? So first intuitional thought would be change the request method from post to get. Okay, let me do this. And then I send it, and then it will say like, method not allowed. So, okay, so get method would be, I need the get method in order to pull this attack off, because otherwise I cannot bypass the lax restriction. But maybe there's another option, and actually there is. So sometimes you can say like method, so you can override the method and say post, right? So I'm simply adding another parameter underscore method, and then I set it to post. And now what I'm going to do is I say attack here as my email address, and I send this, and I get a 302. Let's see if this worked. So this worked. So I was able to successfully bypass the same site lex restriction and launch a CSRF attack. Now this is great. What I'm going to do now is, obviously I need to deliver this to the victim, right? And let's scroll down here. I prepared like a simple document location script, which effectively is your lab, and then it's making a get call. It's not a post call, it's making a get call to my account, change email, and then to pond@websecurityacademy.net. But I obviously need to change the request method, because remember, it doesn't work on a post per se, because this same site lex restriction bypass only works on get methods. And basically this is then my script, but I override the post method at the end. And let me take this, put it into the exploit server, and then effectively deliver that, store it, and deliver it over to the victim and see what happens. And it solves the lab. So that basically shows you how to bypass same site lex restrictions via something called the method override. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the cross-site request forgery section, and today's lab is same site strict bypass via client-side redirect. So you will see that in this lab there is the same site cookie, or these are in use, but this time they have the attribute strict set. So before going any further, let's check what this actually means. So if a cookie is set with the same site strict attribute, browsers will not send the cookie along in any cross-site requests. Okay, so this is pretty much like, well, it's a more secure option. But in simple terms, that means if the JavaScript or whatever you're trying to execute, or the code you're trying to execute does not originate on the very same site the user is currently in the browser address bar, it will just not include the cookie. So a standard cross-site scripting attack not cross-site scripting attack. A standard CSRF attack is not possible. It is not possible simply for the reason because it would be, you would need to host the stuff on your exploit server, and that's another domain. Okay, but if misconfigured, or if you find another vulnerability, then you may be able to exploit this nonetheless. So let's log in first, Wiener Peter, and let's take a look. So this is our account feature here. So basically, let's take a look at the login. So you will see once I provide the username and password, you basically get a session cookie set, and it has the secure attribute, which is good. So secure attribute means it can only be passed over HTTPS encrypted connections. HTTP only attribute means that it cannot be read from JavaScript, so that prevents cross-site scripting attacks where you exfiltrate the cookie, and it has the same site to be set to strict. Okay, so this is just for you to notice at the moment. And then I change the email address to 1@1.com. And I take a look at this request. So here's my post, and pretty straightforward, right? So there's no CSRF token because it doesn't need one, because the same site strict shall prevent from cross-site request forgery attacks, from CSRF attacks. But sometimes if you browse the website, you will find interesting things, right? So maybe we can chain this with another bug. And so we have a block functionality, and I'm just entering some stuff here, right? To see what the functionality is like. So I'm going to post a comment, and then I see that, oh, there's a redirection coming up. Okay, so there's a redirect. So this is interesting to me, right? Because first and foremost, I posted the comment, I got my 302 found, and then there is basically a redirection happening. And if we take a look at the target, right? So there may be a script somewhere. not in the post, maybe in the resources, JavaScript here. So there's basically our redirect function. And so this effectively means that it is going to redirect you back out to the post ID, right? So, and there's a time delay to it. So this is like 3 seconds, okay? So what I'm thinking as an attacker is, let me start playing with this, right? Like, so for example, maybe I can initiate, well, before I do this, let me go back to my post when I changed my email address, send this to repeater as well. And what I'm doing here is I'm simply changing this to a GET request, right? So to see if it works, change the request method to a GET request. You see this is a GET request, and it's say 2@1.com, and then a parameter submit equals 1. So I'm sending this and it looks good. So let's quickly check my account, and it's changed, right? So this confirms now I can actually use a GET request, which is fantastic, because all I need now, all what is left to do, is to see if there's another vulnerability in this common functionality. So for example, what happens if I introduce a path traversal sequence? So maybe I'm able to get to my account on the redirect. When the redirect is initiated, then it's not redirecting me to the post 7, it's redirecting me to my account. Let's see if this works. So let me show this response in browser, right? Like, let me send it first and then show response in browser. So let's take this, put it in here, see what happens. And it redirects to my account. So I have a redirect vulnerability through path traversal in there as well. And now I have all the tools needed actually to craft my exploit, which I've done down here. So let me just quickly get the domain, the lab ID. And then what I'm doing is I'm simply using a simple JavaScript document location, which basically loads like this post comment confirmation URL, which I just shown you in repeater. For post ID 1, I can change this to post ID 7 because we were using post ID 7. Then make the traversal sequence to my account, but then also through the GET request. And this is important because we have done it via GET request before, remember? So I changed it from post to GET, and then I can say here attack@hack.com or something and submit 1. So I take this now, and this should work. And you know why this should work? Because basically the request is initiated from the own application. It's not, I found a vulnerability, so even though I'm hosting this on the exploit server, but all the magic takes place on the server itself because it's exploiting this redirect functionality in order to change the email address of the victim. So I store this and I deliver this over to the victim, and that should solve the lab. If it doesn't solve the lab, oh yeah, it has solved the lab. I was just saying if it doesn't solve the lab, it may have to do with HTTP version 2, but that seems to be fixed now. And this was an example how you can actually bypass same site cookie restrictions if they're set to strict when there's another vulnerability you can exploit on the very same application. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the CSRF cross-site request forgery attack section. Today's lab, same site strict bypass via a sibling domain. Okay, so for this to work, you need to exploit, first of all, a cross-site WebSocket hijacking. And we haven't done this yet, so this is another chapter. So I recommend going to this section first, and if you have any doubts, check through that first. But there's a live chat feature basically here, which is vulnerable to that specific kind of attack, to the cross-site WebSocket hijacking attack. Okay, so what I'm going to do first, I have prepared the exploit already, which is covered more in depth in another section. But basically, I simply take this out here. That's the script. And what's going to happen is basically it will initiate like a WebSocket request to that chat functionality with the WebSocket protocol. And then it's going to make an out-of-band interaction with my Burp collaborator. And it's basically supposed to get like the body event data. So let's see what happens. I store this and then I view my exploit, right? So this is basically what the user would see. Like once the script is executed, let's head over to Burp Collaborator. And we can see here there was an HTTP request message, and it gave me basically the chat history, right? So chat history, it's good and nice, but it's my own chat history, which is not really like appealing, right? Like, this is not interesting. What you also can see that there is no mention of any of the cookie values, basically. So they have not been passed along because the same site cookie has been set to strict. And because I was running the script on my server, I was basically running this script from my personal server. It did not include this. This was to be expected. Now, how can I bypass this? So something which I noticed here in the target tab, there is another, there is a login functionality, right? Like, so there is a sibling domain effectively, which is called CMS and cms.yourlab.id or something like this. So let's copy this and check it out, right? So I already have it here. So this is another sibling domain effectively. So I'm going to just check it out, what it does. And you see there's a username and a password field. So what happens if I go to a username and password field and just enter like a script payload or something, a JavaScript payload, and it executes. So this is now something very interesting because now I can bypass these same site strict restrictions because where I intend to launch it from is from the CMS, which is a sibling domain, which is basically not an external domain, and cookies should be passed along. Okay, so what I'm going to do now is I have a simple JavaScript here with that CMS. So I'm abusing the login functionality. And then instead of my pop-up window, I basically need to have a URL encoded version of the script from above, because what my intention to do here is basically to exfiltrate information from the victim. And I'm copying this. I go over to the decoder, and in the decoder I'm basically URL encoding this, right? So encode this URL, and this is my payload, and I take the payload, I put it over here, and then I simply need to put it into the username field, right? And then password is anything. So I'm going to put this in, and let's see what happens. Let's go to my exploit server. So once again, the script is not being executed from, well, it's running on the exploit server, but the actual document location is on the CMS. So the vulnerability, which allows me to bypass the strict restriction, is on the CMS, on the sibling domain. Okay, so I store this and then I deliver it over to the victim. And let's see what happened in my Burp Collaborator. So let's go back to the Burp Collaborator and poll it again. And I see HTTP interactions, right? And this is very interesting. So there was someone talking, I forgot my password, and then, hello, how can I help you? So let's just go through those chat messages. And Carlos was the user, and the Carlos password is visible in the chat history. So now all I have to do is I copy this out. I go back here. I go to my account and I log in as the user Carlos with the exfiltrated password, and that should solve my lab. Okay, so this was another bypass for the same site cookie strict attribute. And if it was too fast, please refer back to the WebSocket section first to understand how the WebSocket attacks work in depth. Okay, thank you very much and see you in the next lab. Hey guys, this is Martin and we are in the CSRF section. Today's lab is same site lags bypass via cookie refresh. So in this lab, this is slightly different because we have an OAuth flow, basically where we log into the account via OAuth, and there is a problem with the same site cookie with the lex option when it comes to auth, basically. So you remember from one of the previous sections that the same site lex attribute is the default being set when nothing else is specified, and then by default only GET requests and direct user interaction will pass the cookies when the lex attribute is set. However, this regulation is lifted when it comes to OAuth flows for the first 120 seconds with the OAuth flow. So if you're quick enough, you can actually pull a CSRF attack against a victim within the first 120 seconds. So you don't know how long the victim has been logged in, right? So this is why you can do something called cookie refresh. So you enforce with the OAuth flow that the user is being, or the cookie is being refreshed, and then the counter starts from 0 again. And I'm going to show you this in the lab right now, how this works. So basically, let's head over to our own account and we log in, and you see we are redirected to social media, quite common these days. And then we log in with our social media credentials. We authorize to continue, and then we are logged in, right? So we are logged in, we are in our account. There is no CSRF token or anything, so the developers rely simply on the lex attribute of the same site cookie. So let's take this here as an example. So this is a standard cross-site scripting, CSRF attack vector, but it's the post method. But because I'm logged in less than 120 seconds ago, this should work, right? So this should change my email address. So I want to do the view exploit, see how this works. And it worked. So it changed the email address as expected. Now, in order to deliver this to the victim, as I said earlier, we don't know how long this victim has been logged in already. So what we are going to do is we have the same form here to change the email address of the victim to hack@hack.com, but it may fail if I just send it like this, because it would only work if the person is logged in for less than 120 seconds. And in order to force the cookie refresh, what I'm simply doing, and let me show you this here real quick here. If I go here to log out, and now I'm going to my account again, you see what's happening. It's making this call to social login up here, and then it's directly logging you in. So there's no user interaction required. And I'm exploiting exactly that condition. And what I'm doing here is I'm basically making sure that the victim gets sent to the social login first, so it refreshes the cookie, and then with a time delay of 5 seconds, it's going to submit and change the email address as above. Okay, let's do this. Let's put this into our exploit server here. Let's go over to the exploit server, change this, and we hit store, and then we deliver this over to the victim. And then let's see what's happening. And I may have to change the email address. No, yeah, I actually did already. So it's hack@hack.com, but this basically solves the lab. And that's how you bypass same-site lex restrictions by simply using a small time window within the first 120 seconds upon login. If you cannot control this, you can force them to go back through the OAuth flow here. And then the cookie is being refreshed and the counter starts from 0 once again. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the cross-site request forgery section, and today's lab is CSRF attack, where the referrer validation depends on the header being present. So this is a problem. A lot of developers still these days do not use CSRF tokens, but they rely on referrer validation in order to distinguish whether a call can be made or whether something is accepted or not. This can backfire big time because the referrer, although not visible in most cases, is user controllable. So effectively, number one, like in this particular lab here, if I am going to put a wrong referrer, then it will check for it and it will say like, hey, this is a wrong referrer, you're coming from martin.com, but you're not supposed to do this, right? So because my CSRF protection basically says you can only come from mydomain.com. However, if you remove that referrer header altogether, then you come with a blank referrer header, and then you effectively have bypassed the the protection mechanism. So let me show you this in the lab, how this works. So basically I'm logging in first with my credentials, and I change my email to one@one.com, and that's worked, no problem. So basically let me send this post request. And what I'm going to do first is I'm changing this to 2@one.com. Okay, then I create my POC, my proof of concept, and I copy the HTML, I put it on the exploit server, and I put it in here, I store it, and then I want to view it and see if it works. And it does not, because I get an error, invalid referrer header. That's exactly what I expected, because I'm coming from exploitserver.net. It makes that check. The referrer header is basically incorrect. So there's a very easy bypass to this. So basically, let's change the email for the victim to 3@one.com. And all you need to do is you need to introduce additional HTML code. Basically, meta name referrer, content equals no referrer. And you simply add this to your POC script in the HTML section here. You store it. And what that does is basically it's suppressing the referrer header. And if I now deliver this to the victim, it should change the email address successfully because there's no referrer header present. And that's exactly what happened, and that solves the lab. Thank you very much, and see you in the next one. Hey guys, this is Martin again, and today we look at the CSRF vulnerability with a broken referrer validation. So if you recall from the last lab, I said that referrer validation, if not done correctly, can open a lot of pathways for insecurity. But this lab has another vulnerability. Like in the previous lab, we were able to simply remove the header, and then it was not checked anymore, right? But this would not work in this lab this time. So there's another vulnerability which we're going to exploit. So first of all, let's log in as our user, Wiener Peter, and let's change our email address to test@test.com or something, right? So we do that. That worked. We head over to Burp. We take a look at this request, and we now see that there's a referrer. And basically, if I would say now referrer https www.evil.com, it says invalid referrer header, right? So this is it's checking it. If I remove it altogether, it will not work either. But something I can try is, for example, evil.com, and then I say question mark. So I put like a parameter in there, and then I take the host. Something like this, like does it accept that? And that looks good. And that basically proves the vulnerability. So it's not checking for an exact match of that domain. It only is checking whether that domain name is part of the referrer. So that's a serious flaw, because now the referrer is actually coming from evil.com, and it simply has the original URL appended, like as you can see here. Okay, so now what we're going to do, let's go back to the original request and send that original request over to repeater. Again, just test it again and call it test 1, for example. And then test 2, but don't send it. Let's create our POC, right? Like the Burp POC, which is this one here. You see something, this is called like push state. And this is basically, you can instruct that this is being sent along with the header. So what we're going to do here is we simply append that portion here, right? Because we know it's looking for this and it needs that. So let's just see where they put this. It's here. So let's just add it, right? Like something like this. And then the email is test2, or let's put test 333. Let's copy this. And I go to the exploit server and I put it in here. However, this might not work in modern browsers, simply for the reason that modern browsers actually strip, for security reasons, they strip that part, right? So they strip that part off. If you still want to have this to work, then you need to add something called the referrer policy in the header, which is basically referrer policy unsafe URL. Okay, so that's basically all. And then you store this, and we deliver this exploit to the victim, and it now should work. And it does. And that solves the lab. And that's another example of how referrer validation can be bypassed. I hope this makes all sense, and I see you in the next lab. Hey guys, this is Martin. We are in the click checking section, and today we are going to take a look at the lab exploiting click checking in order to trigger a DOM-based XSS. So the lab has, first and foremost, so there's two vulnerabilities really. The first one is there is an XSS vulnerability in the submit feedback form. That's number one. And then the second one basically is a vulnerability that click checking is allowed. So the X-frame header options are not being set correctly. So let's take a look on how to exploit this. So first, let's run over. Here's a submit feedback form, and I simply put in some values, Martin, and subject Martin, message Martin. Okay, so I submit the feedback, and the feedback has been submitted, Martin. And what I immediately see is Martin is being reflected here, right? Like so. So obviously my name, most likely my name, has been reflected. So what I can do is I can try to put in a cross-site scripting attack vector here, and then redo the whole thing with more messages, hit submit feedback, and I get a cross-site scripting vulnerability. Now I want the user basically to click on this, right? Like, so this is difficult because the user would need to enter, like this would require a lot of social engineering. The user would need to enter the payload here and then hit the submit button and stuff like that. But basically, this is where click checking comes into play. So this is my skeleton script. Let's go through this real quick. I'm not going into all details because we have discussed this in the apprentice section already. But basically, first of all, you set the iframe, right? Like the underlying iframe for the victim to click on, and then we set the width and the height, and then the opacity is, I typically use 0.0001, which means that the victim doesn't really see. So it's very transparent that the victim doesn't really see what's going on where they actually click. When you do the testing, you set it to 0.1 that you can actually align the graphics on the screen and things like that. The position here, so in the div element, you have the position where this actual text will appear, like the click me text. So again, this is a lot of trial and error because that depends on the resolution of the browser, the kind of browser you use, and all these kind of things. We discussed all this. But the really interesting part is once it's being clicked, this iframe is being loaded. And the iframe is basically going to my lab URL, uses the feedback function, and then automatically passes in the cross-site scripting vulnerability into the name field, an email, which is called hacker@hacker.com, and a subject message, which is test basically, or the subject is test, and then the message is test as well, right? So this is basically what is being executed. And you can see this if we go back to Burp. Effectively, these are all the details which are being passed in here. Right, like this is the name and the email, and you've seen this, like how we have done this here, and we simply load this in an iframe. So interesting portion, and actually I would say this is another vulnerability in itself because you have seen that request was a post request, but it also accepts a get request, and then the get request is simply by loading this, right, like and loading the feedback and then putting the adding like various parameters to it. And then basically, so you have three vulnerabilities if you want to see it that way. You have the cross-site scripting, you have the no protection against click checking, and you have the fact that the form can be submitted in a get request as well. So let's take this exploit here, move over to our exploit server, put it in the body and store it. And then once that's done, we are going to deliver this out to the victim. And if all goes well, the lab should be solved. And yes, it is solved. So this was an example on how to exploit multiple vulnerabilities, click checking, DOM XSS, and the fact that you can submit the contact form in a GET request, not just in a POST request, and then you chain it together, and that provides you this attack scenario. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the click checking section, and today's lab is multi-step click checking. So sometimes you need multi-step click checking when, for example, you want a user to delete their own account, but there is a confirmation page after the initial click, right? So for example, it says like, do you want to delete your account? And then you will click yes, and then you get a confirmation page. Are you sure, or something, right? And then a single click checking attack would not work. So you need a multiple click checking attack vector here. So I'm going to show you how this is gonna play out. So first and foremost, I would like to direct you again to this page, book.hacktricks.xyz, which is fantastic. It has a lot of information, and each section also contains, like, for example, basic skeleton exploits, like basic payload, multi-step payload. This is what we need. And I highly recommend to familiarize yourself with that page. Okay, let's head over to our application. So first of all, we are going to log in to see how this functionality, which we want to exploit, actually looks like. So we want to click check a victim to delete their own account, right? And you see we have a delete account where the button is down here. So the click checking attack will then, for example, say like, hey, win a cruise to the Caribbean. And then the victim clicks on it. And then the second step is like, are you sure, basically? And then they need to click here again. So this would then play out in a real world scenario, like, are you really sure you want to win a vacation travel to the Caribbean or something like this, right? And so basically with that in mind, we construct a click checking attack, a multi-step click checking attack. And I will explain to you how this is going to look like. So this is my skeleton X exploit, basically. And initially I have my iframe here. So this is where we are basically framing that page, and then we overlay other content on it. So basically the user doesn't see what's going on, and the user thinks they are going to win a vacation travel or whatnot. The opacity needs to be set at least like to this value 0.0001, so that the user doesn't really see. When you arrange this, you put it to 0.1, so that you actually see where on the screen the clicks end up and things like that. But when you actually deliver it to the victim, you cannot do this, because otherwise they would know something fishy is going on, right? And then all we have here is like, basically now we have 2 clicks, and the positions need to be arranged. So if you take a look back here, like on the first page, the delete button is down here, right? But on the second page, the delete button, the confirmation button is up here. So we need to take all this into account, and this is why the top and left references here are different. And they are, again, different for different browsers. Like if you test this in Chrome, it doesn't necessarily mean it works if the victim is using Edge, or if the victim is using Firefox or another browser. So there's a lot of trial and error. And then basically what happens is, like, the first click is initiated on the page. So there's just one iframe. It's basically just one iframe which is being loaded, which is the My Account page, which is basically this one here, right? Like this is being loaded, and then the actions basically take place on that specific URL. Okay, and then there's the first click. First click will be like this, will be aligned with those parameters, and the second click here will be aligned with those parameters, and that's it. And then we simply take this, and now let's go over to the exploit server, put it in, and then we deliver this over to the victim. And if all goes well, the victim account should be deleted. And that was the case. So this solves the lab, and this is an example of a multi-step click checking attack. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the DOM-based vulnerability section, and today's lab is DOM XSS using something called web messages. So before we kick this off, I would like to point you to the developer documentation of Mozilla, which basically explains what post-message functionality is. And it's effectively a method which enables you to safely do cross-origin communication between the window objects and, for example, between an iframe. right? Like between a page and iframe, any two components. And it is basically loosening the same origin policy, right? So the same origin policy normally is very restrictive. And in some scenarios, developers may need this interaction. Where things can go wrong horribly is when the origin is not validated, or the origin is basically wildcarded, and when the input is not being sanitized, right? And this is a problem, and this can be exploited. So let's head over here to the shop first, and let's reload the homepage. Let's take a look at the homepage itself. Let's send it to repeater, and let's look for something called script, right? Like script text, JavaScript. Is there anything in there? And here we can see this. There is actually a script, and it's actually defining like a window at event listener, which basically takes in a message, and then a function is being performed, which is the document get element by ID adds, and then this is being passed on to the inner HTML, which is a sync effectively. So that means it's going to be displayed on the page. The problem with this function is there is no sanitization. So it's the message is user controllable, and there is no sanitization taking place whatsoever. So with that in mind, I can craft like an iframe, and then when the iframe is loaded, it basically communicates via web message with that main page, with the home page here, right? So I have prepared this, and let's go through this step by step. So I'm loading an iframe. I'm basically loading the main page, right? And then unload what needs to happen. A post message is being sent, right? Like you can see this here. And this is my actual message, which is a payload, right? So there's actually two problems here. Like number one is that it's not sanitized, so I can put in a cross-site scripting payload, as you can see this here. So I'm loading an image source from one, which doesn't exist, and then obviously it throws an error, called the print function, right? And what's also bad here is like this asterisk. This is basically the origin, and that's not being validated. So this can basically come from anywhere, right? So from anyone can basically send this web message. And if I take this and I put it on my exploit server, so let's head over to go to the exploit server. Let's put it in here in the body section, and we store it. And now, before I deliver it to the victim, I want to see how this looks like myself. So I do view exploit. You see the iframe here. And what's happening is the print function is being called. So definitely this is working. I can abuse this web message in order to trigger a DOM XSS. And now all I have to do is deliver it over to the victim. And that should solve the lab. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the DOM-based vulnerability section, and today's lab is DOM XSS using web messages and a JavaScript URL. So the issue in this particular scenario is similar to the previous one, but there is an additional step needed in order to exploit it. And let's head over to our lab. So first things first, we have loaded the homepage. I'm going to send the homepage to repeater in order to analyze it in a bit more depth. And like in the previous lab, I'm going to look for JavaScript code specifically. And what I stumble across immediately is this one here. So there's a function, and basically it defines the add event listener. So it's taking in web messages. Okay, and once again, I don't see any sanitization here. What I see, what is different, is it is checking for the presence in the web message of either the HTTP or HTTPS. So what it basically says is, if the HTTP is present, so greater than -1, or, so that's a logical or operator, or HTTPS is present, then basically feed it to the sync location.href, right? And so from an attacker's perspective, this means there's no other sanitization taking place effectively. So I can now go ahead and craft my exploit. And the exploit, once again, will be run out of an iframe, because an iframe can then send the web message over to the homepage. So same thing, up here, same thing like before, we are loading the home page, and then on load, like when it's being loaded, a post message is being sent, and in there, basically, I define the JavaScript, right? JavaScript, and then action is print, because the lab asks me to print. I could also do an alert or like another different function. But what I then need to do is I need to specify in this message. So this is all the message block here, right? I need to specify in the message either HTTP or HTTPS. And how I do this is basically I put this into a comment function. So the 2 forward slashes mean content, mean comment, and then it says HTTP in this case. I also could use HTTPS, and then basically the origin is asterisk. And so as I've seen from the source code review, there is nothing preventing this from being loaded from another location. So let's head over to the exploit server, put our exploit in, and store it and view it first before we send it to the victim. So the iframe is being loaded, web message is being sent, and the print function is being called, and no other errors have been encountered. So with that in mind, I deliver this to the victim, and that should solve my lab. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the DOM-based vulnerability section, and today's lab is DOM XSS using web messages and JSON parse. Okay, so this time the web message is treated differently. It's JSON parsed, and I will show you how to exploit this and what the problems are with that specific code. So if you head over, we reload the page, right? And then we send this simply over to repeater to analyze. Okay, so let's scroll down once again. First things first, let's look for JavaScript code. And actually here is my JavaScript code. So here's my add event listener. So it takes in the message. And then, but you can immediately see that this is different than what we have seen before, because it's basically JSON parsed, right? So if we logically go through this, so first of all, there is a type. There's a type being set, and then we have different cases. So, or we can basically set the type to page load, to load channel, or to player height changed, right? So in the next step, I would say I would look like what is actually being done. So basically a URL property is being set here. That's interesting. So, and there is no sanitization in place whatsoever. So what I want to do is basically I want to choose the type. I want to choose the type, and I want to select the type as load channel, and then I want to set the URL, and then I do not want to set a regular URL. I want to set a JavaScript payload in the URL, basically. So this is how you read this, right? And once again, you are sending this through an iframe. So let's head over here and let's go through this step by step. So we are loading the main page here in the iframe, and then on load we send a Windows post message. Once again, so this is not any different than before, but basically the post message itself is all this portion. This is basically the portion. And because it's JSON parsed, which I know from the code, I need to also put this into JSON format, right? So forget those 2 double quotes here. This is actually the message. So it starts off with a curly bracket, and then I need to specify the type as load channel. So this is basically a key value pair, type and load channel. So I need to specify this based on the code so that I can set my URL. If I set this to another type, it will not work, right? So you need to understand the code, at least the basics of the coding, like what it's actually doing. And then the URL key value pair, I set the URL to JavaScript print, basically, right? And then it finishes here. So this is basically my JSON message. This is more complicated than in the previous examples, but this is because it's JSON parsed. And then the origin we send to an asterisk to a wildcard. So basically, we already know that there is no origin check in the code taking place. So this basically can run from anywhere, right? So let's take it and see if this works, if our assumptions were correct. Let's head over to the exploit server. Let's put it into our exploit server, view the exploit, iframe loaded, post message sent, JSON parsed, and then you can see the print option has been called. So my exploit seems to be working fine, and all I have to do now is deliver it to the victim, and that should solve the lab. Okay, I hope this makes sense, and I'll see you in the next lab. Hey guys, this is Martin here. We are in the DOM-based vulnerability section, and today's lab is the DOM-based open redirection. So an open redirect typically is a vulnerability where you can control some sort of parameter and then you can redirect users to a page of your choosing, basically. Okay, so we are going to take a look at this. So let's head over to our website. If we go to homepage, it's a blog basically, right? So let's go on view post. Let's take a look at a post or something. So yeah, I can leave a comment and things like that. One thing I notice is down here that there is basically, if I click there, I get back to the main blog page. You seen this? Like I go into my blog and then I have back to blog. Okay, so let's head over to Burp and take a look at the actual post page. And let's take a look what's happening and how is this being constructed, basically. So let's move down, and you can see here there is basically an on-click event. So the on-click event basically means return URL, and it's effectively setting the location to the home page, right, to the main blog page. So it's taking, like, once this is being clicked, it's basically taking the users back. But what I immediately see here is there's a parameter called URL, and me thinking like, hey, can I control this parameter actually? So let's check out, right? Like, let's see if I can control this parameter. So what if I go in here and say I add this as a parameter, URL equals, and then I say HTTP and then evil.com or something like this, right? Then I refresh it because it's a DOM-based vulnerability, and now it basically I gave user input, and the user input from the source is now being put into the sink. So this is what this function is doing in DOM. And now I can see this. I see my evil.com in the URL in the left-hand corner. So if I click on it, oh, wow, I get redirected out. So I have confirmed that I have an open redirect vulnerability here. Now, the goal of the lab, I believe, is that you need to send the victim to the exploit server, which is an easy thing to do now, right? Because we know this works. So let's simply copy that URL, and then let's redo our attack. Here, instead of evil.com, we send it to the exploit server. Okay, we refresh this, and then it already solved, but basically let's verify this. So if I click here, I should be redirected to the exploit server, which works. Yeah, so this is an example of a DOM-based open redirection. Thank you very much, and see you in the next lab. Hey guys, this is Martin, and we are in the DOM-based vulnerability section, and this lab is DOM-based cookie manipulation. So sometimes you will come across the fact that cookies are being set based on your browsing behavior. Like, for example, if you go to one page, then it may track this as a cookie that your recently visited product or something is like that page, right? So, like, for example, if I go here to the home page and I go to any, like the alternative Christmas tree, for example, and then I return to the home page. So let's take a look how this looks like. So I visited this product here, right? I visited that product, and what you can see is I had my last viewed product where I was before. It's basically product ID 7, right? And if I go back to the homepage, so then I visited product ID 5, and then I went to the homepage. So then my last viewed product is product ID 5. So if I can trigger a cross-site scripting vulnerability in that cookie, then I could deliver this potentially to a client and then invoke it or set their cookie with a malicious payload, basically. And that's what I'm going to do. So let's start out first. So, what happens, like, this is very simple. This is the URL you have just seen. And what if I just add an end, close any existing script tags, and add a print statement? Like, see how this works, like what's happening if I actually put this in. And nothing happens at this point, right? So nothing happens right now because the cookie will only come in effect if I browse to another page. So if I browse to the home page, now the exploit fires, right? Because my recently visited product was the exploit. Okay, so this is a very important concept. So I just need to click around a bit in order to clear this again. So that should be fine now. Okay. So with that in mind, I can basically exploit this, but there is 2 steps to it. So number one, as you have seen, if I just put the exploit in and load the exploit on its own, then it doesn't really work, right? Because what the victim needs to do, the victim needs to browse away, and then the payload fires, because in the recent visited product is the payload, right? So I hope this makes sense, right? Like this, so it wouldn't work like this. This is why you need to construct your payload like this. So basically what I'm going to do, the iframe loads, and this is the cookie poisoning effectively, or the cookie manipulation. The iframe loads and injects as the most recently visited product, the payload. But this is only part of the rent, so this would not fire itself. But then basically the onload here, as I pointed this out, the onload over here is then actually calling the homepage. And that really triggers that the maliciously set cookie will fire. Okay, so let me copy this out, and I go over to my exploit server. I put it in the exploit server in the body here. I store it, and I want to see if this works for myself first. So what I'm doing is I do view exploit, and you seen it was like refreshing. So basically it effectively what it done is it injected the malicious cookie first with the payload, and then it loaded the homepage afterwards. And that seemed to work fine. So I got this exploited. So now with that in mind, I can actually go back and deliver it to the victim, and that should solve my lab. And it did. Okay, so this is an example of how you can modify cookies, DOM-based cookie manipulation effectively. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the course vulnerability section, and today's lab is course vulnerability exploitation with trusted insecure protocols. So once again, in this lab, we can see from our own account that we make a call to an API key, so to retrieve an API key, and the goal is basically to exfiltrate that API key of the administrator or of the victim. This vulnerability or this lab is more advanced simply for the fact because there is multiple vulnerabilities you need to chain together in order to get this executed. So we will start taking a look at each of them. So if we head over here to our application, let's first check out like what it's all about. So you have a product and you have a stock check feature. And now, oh, there's a pop-up, right? So stock level 80, interesting. I'm interested in Burp, like how this looks like first and foremost. Okay, so I see this, and what immediately springs to mind, let me send it to repeater, but what immediately springs to mind is that it's making a call to a subdomain called stock. That's interesting, right? So let me load this in the browser let's send it and then request the response in browser, and let's see how this looks like. Okay, that's that. And then I see there's 2 IDs, right? A product ID and a store ID. So what happens if I put into my product ID JavaScript payload, like trying to trigger an XSS here? And if I do this, I have a successful XSS. So this is already the first vulnerability. And this might come in handy at a later stage. Okay, so let's move back to the actual page. Now let's log in and take a look at this API key functionality. So we're logging in and we see there's an API key being loaded. Okay, let's check this. This is the GET request to account details, and it contains the API key. Let's send this to the repeater. Now we actually start our investigation around course. So what happens if I put an origin header of https www.evil.com? Can I launch an AJAX request from evil.com basically? And it says no. So I only get the allow credentials to be set to true, but actually it doesn't like my domain. Now I'm thinking, hey, we already found a cross-site scripting vulnerability on the stock subdomain. So maybe they have misconfigured course as well or something like this, right? So I'm going in here and I send this, and all of a sudden I get, hey, access control allow origin, and it accepts that. So that confirms that I can make an AJAX call from that domain to the application, right? So interestingly enough, remember when we looked at the page earlier, there was a problem that it was an HTTP call. So what if I do just an HTTP call? And this is another vulnerability on its own, right? Like, so I can also, it's accepting an insecure protocol, basically. Now, with all that in mind, I have all the tools necessary to craft my payload. And I've done this prior to the lab, but I'm going to explain you step by step what's going to happen. So I host this on my exploit server, but basically the exploit server couldn't make the course or couldn't exploit the course vulnerability because the domain will not be accepted, right? But basically I'm calling here the stock functionality, the product ID, remember that? And then instead of doing an alert pop-up, I simply put a script in. And the script is very similar to what we've used in the previous course labs, but it's effectively opening the HTTPS request to the account details. Like the information is located here, which I'm after, right? And then it's basically sending this information. So there's like how I deal with the response, and the response shall be logged on my exploit server, which I control, right? And then basically it's being logged as a key parameter effectively. And then I can say here store ID 1 because it was 1 before as well. So it doesn't really matter. But this is my exploit. So let me take this exploit and let me put it on the exploit server. So let's head over to the exploit server. Let's put it in the body and then let's store it. Okay, so now we deliver this to the victim. The victim is then clicking that link, code gets executed and nothing obvious happened right now, right? But if you go to the access log, I basically see, hey, there has been a request from the victim, which is this one here, and there seems to be some juicy information attached with it. So let me take this out and put it over in decoder. And in the decoder, I want to make this more readable. So there's a lot of URL encoding happening, but basically here you can see that it was the administrator who clicked on the link and the API key was successfully stolen via course. And if I take this and submit this as the solution, this will solve my lab. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the XXE XML external entity injection section, and today's lab is blind XXE with out-of-band interaction. So if you recall from our previous videos in the apprentice section, we did not have blind XXE because we were able to actually get the results directly in the response. Okay, but this is often not possible. So it's similar to SQL injection. Blind is basically you can exfiltrate information, but like to a third party, like a Burp collaborator or something, and triggering out-of-band interaction to an external domain. Okay, let's take a look how this looks like and how to pull these off. But before that, I want to show you like a page which is called book.hacktricks.xyz. And if you go to the XXE session, you get all the explanation, the basics first and foremost, how it is, how it works, where the vulnerabilities are basically, and then also a lot of proof of concepts like skeleton exploits and things like that. And if you scroll down here to the blind SSRF, for example, you get a lot of information and a lot of useful payloads which you can use in your testing. How you find these usually? Well, always look for XML input whenever there is user controllable XML input. I would look for XXE. Also, the Burp scanner in the Pro version, like in the Burp professional version, helps you finding those. But you still need to exploit them yourself, right? Like this is the case. So let's head over here to the application and let's go to a product and let's run the stock check feature. And basically, let's take a look at this here in our repeater. Let's send it over to repeater, and you can see here clearly that there is an XML being done. So I could now, or how I would go on about this, I would make the basic tests first, which I've already done in the apprentice lab, so I'm not going to redo those, but they would not turn out to be successful. So if you're looking for blind, basically you will inject something like this. So doc type, stock check, and then you define an entity basically called Martin, and then you insert your Burp collaborator domain, right? So you go over to the collaborator, copy to clipboard. So you copy that first, and then you put it in here, right? So this is where we want, at this point in time, we don't want to trigger any or exfiltrate any data. It's just a proof of concept to, can we actually inflict an external interaction first and foremost. So we do this, we head back to a repeater, and then we simply put this in here into the XML code. And also what I need to do is, before this can launch, I need to then call this from within the product ID. And I call it Martin, so I call it like this, right? So let's hit send, and nothing happens. I get an invalid product ID. So obviously, because it's blind, you don't get any response. But if I go to the collaborator over here and hit poll, I see that I had an interaction. I had two DNS queries, basically. I see the IP address, where they came from, which is the application. And then I can see the GET request here as well, an HTTP GET request. If I head over to my lab, the lab has been solved successfully, because this lab was only to prove the point that out-of-band interaction works, but not to exfiltrate. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin again, and we are in the XXE section, and today's lab is blind XXE with out-of-band interaction, similar to the previous lab, but this time via XML parameter entities. Okay, so basically, if you don't know what this is, you can read it up on the documentation, but what I recommend is heading over to a page called book.hacktricks.xyz. It has a lot of explanation. And so what are these parameter identities basically? Well, it's sometimes regular XXE attacks are simply being blocked by the application or by filters and things like that. And then you can use those parameter entities instead, right? So they are a special kind of XML entity, which can only be referenced elsewhere within the same DTD. So that's the difference to regular entities, right? And you really need to know two things. First of all, it's like when you do the declaration, it includes the percentage sign, like as you can see this here, and then you give it a name. So when you do the declaration, and the second is the parameter entities are referenced using the percentage character instead of the ampersand sign, like we have done in the previous lab. So you don't need this, what you don't need to do is you don't need to go to the product ID or stock ID or any of these XML variables in order to call it. You can declare this all in one line, basically. And let's head over to the lab and do this in practice. So we go to a product, and then we use the stock check feature. We analyze the stock check feature in repeater. We send it over to repeater, and then you can clearly see here that there's the XML input. And then simply how I declare this, and you would test for both, right? Like whenever you're testing for the previous one first with regular entities, and then you also test for this scenario. And all you need to do is very similar than before, but you use the percentage sign for the declaration and the percentage sign to basically call it. I have a mistake here. I need to call it Martin because that needs to match, right? And my Burp collaborator URL effectively, which I grabbed from here. And I simply copy to clipboard and then insert that. So let's head over to repeater. Let's put this in and let's see what happens. And again, because it's a blind vulnerability, I get an XML parsing error this time. Different error message, but I don't get any meaningful output. And I come over here, do the poll now, and then I see, hey, I have my 2 DNS and 1 HTTP interaction. So it obviously worked. I see the IP address of the application and things like that. And again, we haven't exfiltrated anything. This is more like a proof of concept that XXE is possible. And for bug bounty purposes, this is usually fine. If you have a penetration testing engagement, you want to show some more impact. And then you'll start exfiltrating information and things like that. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and in today's lab, we are still in the XXE section. Today we are going to exploit blind XXE to exfiltrate data using a malicious external DTD. Okay, so document type definition, that means, and I will come back to this in just a bit, like what this actually means and how this works. But the attack path is different to what we have done previously, and so let's explore this. But basically, the check stock feature has a vulnerability which allows XML input, and our goal is to exfiltrate the etc hostname file. So it's a Linux server, basically. Let's head over, let's play with it a bit, and let's check the stock and then send this check stock to repeater, right? Like this is the one. We put this over to repeater, and if we run it without any modification, we get our standard output. Now, I want to show you like how to exploit this. Like first and foremost, what is an external DTD? It's basically XML elements declared outside the local XML file, basically. So they are accessed by specifying system attributes, which may either be legal or not legal. And basically, it's typically like a DTD file or a valid URL. Either works. And basically, if you take a look at this, this is the code. So I can basically define or like declare here the system file, etc hostname, and then the eval functionality is, this is like two commands basically. So first of all, read out this content of the file name, and then basically exfil it over to the Burp collaborator with a parameter called x at the end, right? And then you call these two functions with the percentage eval and percentage exfil. So I take this. No, first of all, I need to put in my Burp collaborator URL, the correct one, which is this one here. So I'm replacing this with the current Burp collaborator URL. And then I'm going to take the whole payload and put it on my exploit server, basically, right? So I have an exploit server here, and I simply put this in there. I store it, and that's it. Okay, but that's only half the rent, because now what needs to happen basically is now you actually need to go over and then actually start exfiltrating it, right? So you need to call that server. So it's like a bit of a tedious process. So you need to then inject XML input, but instead of declaring everything locally, what we have done before, you need to call that external entity. You need to call that external entity, and then that external entity, basically that functionality will be invoked when it's called. And if all goes well, we should get a ping back on our Burp collaborator with the required information. So let's check quickly our exploit server. So we basically need the correct URL for the exploit server, and also the path. Let's copy this here, right? Because the path is /exploit, which I could change here if I wanted to, but let's just leave it like it is for now. So we just put this in here. So now what I'm going to do, and again, is I'm injecting this into my XML payload. I inject this here on Burp, right? And this is basically calling an external entity located at this location. And then once it hits the exploit server, the code will be executed, as you can see here. And then it should give me a ping back to my Burp collaborator. Let's try this out. Let's send it. Once again, this whole thing is blind, so I get an XML parsing error. But if all went well, this code should have been executed now. And if I go to my Burp collaborator and I hit poll now, I should see interaction. And I do see interaction. And I see two DNS lookups, which are not really interesting, but I'm more interested in the HTTP one. So I basically see that this was being exfiltrated. So remember, I declared my parameter X, and this is basically the output. And if I take this and submit it as the solution, so that's the host name, that should solve my lab, and that basically solves my lab. Many thanks. Hey guys, this is Martin. We are in the XXE section, and today's lab is exploiting blind XXE to retrieve data via error messages. So logic behind this is basically we are hosting our own external DTD again, but this time around we are inflicting error messages, like making a call to something which doesn't exist, and then return the error message basically alongside with something which does exist. Okay, so to make this more clear, we are taking a look at the lab. Let's head over to the lab. We have our stock check functionality once again, same like in all the other labs, whereby XML input is being produced, right? So once again, you don't know which vulnerability you are up against. So those are all the different kind of vulnerabilities. You would test all of these sequentially, right, in order to find out what's actually going to happen and if it's vulnerable or if it's exploitable, basically. So let me show you how we do this. So basically, we go over to our exploit server and we declare like the first instruction, which is to read out the file etc passwd. This is similar to what we have done in the second one. And then we basically evaluate that entity, and we also basically instruct here to exfiltrate an invalid file. So this one here is invalid, but we also want to append the valid file from above, which we declared here, right? So does that make sense? And so basically we then call both of these functions in order to trigger that error message basically and append the information we want to see. So let's see how this works in practice. Let's first of all go over to the exploit server, and we declare this here on the exploit server. We put it on, store it, and that's basically it. And then secondly, obviously, we now need to call this external exploit server. So we have our external entity here, and which I called Martin, and where the instruction comes to basically load the external DTT as a URL and then execute it, basically, right? So let's take this and let's put it over in our Burp repeater. And now we hit send. You see, we're not using a Burp collaborator at this point, but we are still using an external entity, the DTD. Let's hit send and let's see what happens. And there comes an error message back, which basically says exploit. Ah, yes, this is the reason I have the exploit in there twice. So I need to just delete the exploit once because the path was duplicated. And if I resend it, I basically get this. So what happened here is, you see the error message like file not found, and for file not found is basically related to this one here because I was asking for an invalid file path. So this is the error message, but then it actually appended the content of the etc passwd file, as you can see this here, right? So this is basically after the error message, I was successfully to exfiltrate that information. Okay, I hope this makes sense, and I see you in one of the next videos. Hey guys, this is Martin here, and we are in the XXE section, and today's lab is exploiting X-include to retrieve files. Okay, so the problem is sometimes you do not control the entire XML document, and that means you cannot define a DTD to launch a classic attack. So this is often the case, especially when it comes to like old APIs, like with SOAP backend services and things like that. However, there is something called X-include, and X-include can be used in order to bypass certain restrictions, because what X-include actually does. So let's take a look here at book.hacktricks.xyz. X-include itself is part of the XML specification, and it allows an XML document to be built from sub-documents. Okay, so this is how you bypass if you cannot control the entire XML. And basically, this is a common attack vector, actually. So if we take a look at our stock functionality, I actually found this in the wild like 3 times. I do my stock check as usual, and you will see that this is slightly different this time around, because what's happening is you have a product ID and a store ID, right? So there's no obvious XML input. Now, tip here, especially when you're going for the Burp exam or something like this, you can use the Burp scanner, so you can scan this specific request, for example, like do active scan. This is always useful, like if you find a functionality where you suspect something going on or any of that nature, you basically do a scan on this specific endpoint, and that gives you results a lot quicker. And typically, Burp Scanner in the Pro version will find you vulnerabilities like this, and then you still need to exploit them manually, but in order to find the attack surface or the hidden attack surface, so to speak, you can do this. But basically, if we head over to our Hackbook website again, so let's copy the payload out. This is like a sample payload. This can obviously be modified as you please, right? So it defines the X-include, and then we're parsing the text, and we are basically going after the etc passwd file. So let's copy this out, all right, and go over to Burp, and we put this into the product ID, right? Let's put this into the product ID field, and also store ID equals 1. So let's send this, and here we go, right? So I was successfully able to read this file etc passwd through my x include attack vector. I hope this makes sense, and I look forward to see you in the next video. Hey guys, this is Martin. We are in the XXE section, and today's lab is exploiting XXE via image file upload. So we will have a whole section later on around image file uploads and the vulnerabilities associated with it. But basically, the lab allows you to attach avatars to comments, and it uses Apache Batik, the Apache Batik library, to process the avatar file images. And basically, this is a problem generally with SVG uploads. SVG is a graphic format, but you can actually run code within. So, like for example, you can run JavaScript, or you can run HTML code, or you can run XML code, right? Like an XML code is obviously what we want for our lab to succeed, because it's an XXE attack. So if we go here, check around a bit, so you can see we have the upload functionality, right? We have an upload functionality, file upload. You would test this for all kinds of things. You would also test this for cross-site scripting and other types of vulnerabilities. But for this lab, it's around XXE via image file upload. So once again, I suggest to head over to the book.hacktricks.xyz, which gives you a brief explanation what I've just done actually. And they have multiple payloads here. Like for example, this is an SVG payload, and we can simply copy this out, and then we can move it over, and it would look something like this. So you see, I have my XML declaration here first and foremost. Then I have the declaration of my malicious activity, like my external entity basically, where I call it XXE, and I instructed to read the file etc hostname. And then I have my SVG, so that's the image portion, like the height and the width and stuff like that. And this is all standard stuff, but the important part is here, where I actually call my external entity, which I've defined earlier. And then it's important not to save this as XML, because the text editor will normally say like this is an XML file because of the declaration. But what you would actually do is you save it as SVG, which is a graphic file, because then it's more likely to be taken by the upload, if there's an upload filter at all. So let's try this. Let's just put in test or whatever. Test M, and then we put in the avatar. So that's the upload.svg, which I've just shown you, test.com and test.com. Okay, so we post a comment and see if we get any error messages. No, it was apparently working fine. We go back here, and now we should see something here. This is my avatar, right? But I didn't upload a real picture. I uploaded an XXE exploit, so I opened this in a new tab. And basically, there is the output of the file I requested. So what I'm going to do here is I simply need to type this, because this is it's a graphic image, so I cannot copy paste it. And I will simply take this value out and then submit this as my solution, which then should solve the lab. That's it. And that's an example on how XXE can be achieved via file upload. Hope that makes sense, and I'll see you in the next lesson. Hey guys, this is Martin. We are in the SSRF section, server-side request forgery, and today's lab is SSRF with a blacklist-based input filter. So once again, real quick, what is SSRF? SSRF is server-side request forgery, whereby you trick an application to make a call either to itself or to another internal system where you would normally not get to. So in our lab, we need to access something called localhost admin, which I cannot reach locally, obviously, because that's the 127.0.0.1 address, and then delete the username Carlos. So let's see how we can do this. Let's head over to our application, And we see there's a check stock functionality. Let's invoke this and let's send this to the repeater to analyze, right? Like, so let's take this, send it over to repeater. And then you can see here, hey, it takes a URL as an input. And if I highlight this, I get it the URL decoded version. So first thing I'm going to try, right, is like, I'm going to say, hey, is there a local host, like a 127.0.0.1? And I send this, and I get a security block message, basically. So this doesn't work. So now I need to obfuscate this in one way or another. So for example, what if I try this 127.1? And hey, all of a sudden I get something back. So basically I was successfully able to reach the loopback interface, the local host. And if I render this, you won't see a difference as yet, but you see that there's the admin panel up there. This is very interesting, right? So now I want to go to the admin panel, and it's /admin, because admin panel, and here's the href, right? So I hammer in admin and send it, and I again get a block message. So something else is not right. So what happens if I take admin and then I basically go over to the decoder and I start to URL encode this, right? So I URL encode admin, and let me take this over and put it in as URL encoded value, and it doesn't work, right? Okay, so hey, what about if I encode this again? So I double encode it with URL encoding, like something like this, right? Does this work? So it's a lot of trial and error, right? And hit send, and hey, all of a sudden this worked. And if I render it, here's my admin panel. And now my job is to delete the user Carlos, which should be pretty simple from that point on. So I look at the command. I need to put in / delete username equals Carlos. And I do that. And I hit send. Maybe I have to URL encode this, but probably not. So this looks good. Just to verify, let's go to the admin panel once more and see if Carlos has been deleted. And yes, and the lab has been solved. Okay, so this is a very good example of server-side request forgery where you face a filter. One thing I want to show you real quick is there's something called payload all the things on GitHub, and then you find a lot of bypasses and payloads here, like what you can try. So it's pretty much a trial and error, right? Like this is not, there's no one size fits all or any of that. So you need to simply try different payloads and things like that. But this is a page which is pretty useful. Okay, I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in the server-side request forgery section, SSRF, and today's lab is SSRF with filter bypass via open redirect vulnerability. So as I mentioned in the previous lab, SSRF is basically tricking the application to make a call on your behalf to a location which you normally could not get to. So for example, it says here there's an admin panel on this IP address. Now, as you can see, this is an RFC 1918 private IP address, and you cannot get to this from the internet. But you may be able to trick the application to make that call on your behalf and then modify certain things on it. Okay, so let's get started. Let's head over to the application, and I have my product feature. I can do my check stock as usual, but something which stands out, which wasn't there in the previous lab, is there's something called a next product. And let me click on this, and then it jumps to a next product, basically, right? So interesting. So let me, first of all, move the post request to the stock API into the repeater, but let me also check this current product, because that's kind of interesting, right? Like the current product, and then there's a path parameter, and then maybe I can control this path parameter here. So this is my thinking. So first and foremost, if I would now modify here the stock API, and I'm not going to do this, the previous attempts like HTTP 127.0.0.1 and so forth, or a local IP address would fail, because there are certain mechanisms in place which prevent that. But what I can try basically is, like, let's take a look at this. So it says product stock check, right? So what if I say, hey, go to product next product, and then current product I'm not really interested in. Like, let's do something like this. And then I say path, right? Path equals, and then I'm typing in the IP address from the panel, which I've been given earlier in the lab description. 012 it was on port 8080/admin. So let's see if I can actually introduce an SSRF attack via this path parameter. And hey, this looks good. Like, if I render this now, I'm at the admin panel. And now my job is to delete the user Carlos. So I'm simply looking here what is being needed. So it's a delete and then followed by the username Carlos, right? Something like this. So if I put this in, a slash is missing here, I should be able to successfully delete the user Carlos. Hopefully. Let's see, render. And Carlos has been successfully deleted. Okay, user successfully deleted. If I go back to my page, the lab has been solved. So this is another example where you can leverage SSRF when you find an open redirect vulnerability. And this holds true for all bug bounty hunting and pen testing as well. Whenever you find an open redirect vulnerability, hold on to it, right? Like, you might be able to use it for cross-site scripting, you might be able to use it for SSRF attacks and so forth. So it's open redirect on its own is a low vulnerability, but very often you can combine this with other vulnerabilities and then you have a high impact. Okay, that's all for today, and I see you in the next video. Hey guys, this is Martin. Today's lab is blind SSRF, server-side request forgery with out-of-band detection. So as you have seen this in previous chapters, like in SQL and in the XXE section, out-of-band detection basically is, or blind vulnerability is, when you don't see the output directly reflected to you, but when you can exfiltrate or trigger an interaction with a third party, right? And in this case, there is a referrer header which is being used by the application, and this triggers some kind of analytic software, right, with a third party. So our goal is to modify that referrer header in order to get a DNS interaction, out of band interaction with the Burp collaboration server. Okay, let's get started. Let's head over. Let's go to a product, fur babies. Okay, so let's go to this one and let's simply send this to repeater, basically, right? So this is, I'm going to send this to repeater, and you can see there's a referrer header. And now I can go in here and actually like delete this portion, and then I do a right click and say like insert collaborator payload. So that's automatically inserting my collaborator payload from the Burp collaborator here. And I simply hit send and see what happens. So now I have modified just the referrer, nothing else. And if I go to the collaboration server and if I hit poll now, I have my out-of-band interaction. So I see two DNS requests with the IP address from the server, basically. And then what I also get is an HTTP GET request. And this was triggered by simply modifying the referrer header and introducing the Burp collaborator URL in the referrer. And this is a very simple example of modifying the referrer header in order to trigger SSRF out-of-band detection or interaction. I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in the request smuggling section, and today's lab is HTTP request smuggling basic CLTE vulnerability. So what does CLTE stand for? CL stands for content length, and TE stands for transfer encoding. So basically, these kind of problems always arise when you have like a front end and a back end server, and they're in disagreement on what kind of encoding should be used or is supported. So in this case, for example, front end server doesn't support chunked encoding. It uses the length, the content length instead, but the backend server uses chunked encoding. And if there's a discrepancy, you might be able to get a smuggled request through because of the disagreement between front end and back end. Let's head over to our lab. So this is basically our lab, and we have our homepage. And if I send this over to repeater, right, then first thing I'm going to do is I change the protocol to HTTP1 because it's only working in HTTP1. So that's the first thing. And then I basically can delete quite a few of these headers because I don't need them for this specific lab, like this. Okay, it still sees a body here, so that should be fine. Okay, cool. Then I basically also put in the following two commands: content length 4 and transfer encoding chunk. So I want to throw the server off track because the front-end server only supports content length, and the backend supports chunked, so I use chunked here. Then I say 0, and then I say G. So why I'm saying this? So first and foremost, the content length is 0 because the front end server will process it, and it is 1. We can see this 1, 2, 3, 4 up until the end of the G, right? So this is the content length. Now the backend server will produce it chunked, so it will basically see this an empty string which is terminated with the 0, and then it will throw it in the logic, and then it will think that G is part of the next request already. And this is where the discrepancy occurs, right? And now all I have to do is basically I need to change this here into a post request, change the request method into post. And of course, it deleted quite a few of my things, so I need to put this back in. And now let's see what happens. If I send this once, twice, on my second one, I get an error message. And this is because now it's responding, the backend server is responding, there is nothing called gpost. Because the next request would have been a post, but it prepends basically the G on it. So I was able to successfully smuggle the G to the backend server, even though if I would have tried this on the front end, it would have not worked. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. Welcome to the request smuggling section, and today's lab is HTTP request smuggling basic TE-CL vulnerability. So once again, TE stands for transfer encoding and CL stands for content length. So this lab is basically the reverse of the previous one. So the backend server this time around doesn't support chunked encoding and supports basically transfer encoding only, and the front server rejects certain requests and only allows get and post methods. So our job once again is to smuggle a gpost over to the backend server. Let's take a look at the vulnerability first. So TE-CL vulnerabilities. So here the front end server uses the transfer encoding, and the backend server uses the CL, the content length, right? And so if you take a look at this request here, so we set the content length to 3, the transfer encoding to chunked, and then what happens is the front-end server will process the transfer encoding header first, and so it treats the message by using chunked encoding effectively. So nothing special. It processes the first chunk, which is stated to be 8 bytes long, right? And this is basically this section here. So that's the chunk, and it's 8 bytes long, 1, 2, 3, 4, 5, 6, 7, 8, right? And then up the start of the following line, this basically terminates that request, so it's 0 length, and it will then be forwarded to the backend server. The backend server takes then a look at it at the content length, which is 3 bytes long, because we say here 1, so this 1, 2 blanks, and the 8, it's basically 3 bytes long, and then it starts like up until here, basically, right? Like up until the 8. And the following bytes are then smuggled, okay? Because we are only instructing it that the content length would be 3 long, but actually what is coming afterwards is smuggled, and they're basically left unprocessed, and the back end server will treat these as the start of the new sequence. And that's where I can start ingesting, like a gpost or something like this. So let's head over to the application, and then we first of all send the GET request to repeater. We change the version to version 1, and then we basically change this to a post request. And if we come over here, so I've already prepared part of the exploit basically, or part of our POC in this specific scenario. But before I fire this, I want to show you something else. Basically, this is very tedious to do this manually, right? So there's two extensions which I highly recommend to install. One is called the HTTP Request Smuggler, and you can find them in the web store, and the other one is called the Flow extension. And so basically what you then can do is you can take your GET request, and then you simply, we already know it's vulnerable in this case, so we don't have to do it, but we will go HTTP request smuggler, and then we would simply say smuggling probe. At a certain time, it will come back and say like, hey, the smuggling probe was successful. And then you take it to the next level. Is basically, you will then send that specific output, which I have prepared here in the interest of time, but that specific output would then be sent to the request smuggler, and then you say which kind of attack you want to launch. So for example, a TECL attack that opens a new window, and then all you have to verify here, or all you have to change is basically, we want not a GET, we want a GPost, basically. A GPost, and we also do not want to have any out-of-band interaction with the collaborator, just something like this, right? And then we hit attack. And then what you see is basically it's starting off, and here in the second request, this was the request which was brute force, basically. So you have to have the correct content length and that kind of stuff. And then it says unrecognized method equals GPost. So this is basically solving that lab. And so I think it's always important to have a mixture between manual testing and automated testing, because it speeds up time significantly. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. Welcome to the request smuggling section, and in today's lab we will take a look at HTTP request smuggling by obfuscating the TE, the transfer encoding header. So in certain scenarios you can have success and smuggle requests through when the two servers, the front end and the back end servers, handle duplicate HTTP request headers in different ways. So if we go over to the description, is basically if you, for example, add another transfer encoding, and one is maybe ignoring it and the other one maybe processing it, right? And so you can basically throw errors that way and disrupt the processing channel effectively, right? So there's multiple ways of doing this, right? Like, so you can try this, but the best solution here is an automated solution once again. So for example, let me show you this. Like you have your request, right? Like, so this is basically your request to the homepage, and you would right click on it and then simply say HTTP request smuggler and then smuggle probe. So this is how it all starts out. And for that, you need to have the extension installed, basically, right? Like you can see this here. And I was already running this, by the way, in the interest of time, once again. So you get something like this. You get an advisory that there's a possible HTTP request smuggling, TECL dual chunk delayed. And if you start analyzing this, like the requests which have been sent, you will see that there is different transfer encoding headers being set. So you have in the first request, you have this, in the second request, you have this, and this led to the fact that you are able to smuggle requests through. So once you have identified this, you then take this request, you can basically say extension, HTTP smuggler, right? Like here once again, and then you are going to smuggle, you launch another smuggle attack, which is TECL. And we do this here. Once again, we fill in what we want to do. So we want to launch a GPost, and we don't want our Burp collaborator interaction here, just like this. And then we hit start the attack. And you can see here instantly that this basically facilitated for us to get a 403 once again, which means that it doesn't recognize the GPost, so the G was successfully smuggled through. And if you go over to the lab has been solved. This is a lot easier, and it's also getting you, like, the content length feels right, and otherwise it's a lot of trial and error like we have done in the first lab, but So it's highly recommended to use automated tools for this process. I hope it makes sense, and I'll see you in the next lab. Hey guys, this is Martin. We are in the request smuggling section, and today's lab is HTTP request smuggling, confirming a CLTE vulnerability via differential responses. So in a nutshell, it's not any different to the first lab we have done already with the content length and the transfer encoding, but normally, like so far, we have just done a G post, which really just confirms the vulnerability but doesn't do anything. And normally you have post and get requests and stuff like that in the CRUD methods, and you usually get a 200, and you always get a 200 whether it's for the smuggled request or for the real request. So what we want to do here in this specific lab is we want to have the smuggled request call a path which doesn't exist to return a 404 error, right? So let's head over here and let's simply refresh the page. Let's grab the get request to the main page to send to repeater. We send this to repeater. Once again, I need to change this in the inspector first to HTTP1. Let's do that. And this looks good. Now let's change it to a post request, right? Like change the request method, and let's delete everything here which we do not need. Something like this, right? And so we have the content length set to 35. I will explain in a second why we set it to 35. This may differ from application to application, of course. This is based on the actual content I will put forward. But the transfer encoding is chunked, so backend server only supports chunked as before, and then we do a get 404, which doesn't exist, to HTTP 1.1, and then xignore X. So what this means effectively, it's quite straightforward, right? Like the content length is basically all this stuff from here all the way up until here. So that's the content length because the front-end server only supports content length. And this will then basically send the request, and the backend will receive it, and the backend will actually not understand the content length. The backend will make chunked. Then it will see the 0 here and will say like, hey, hang on a minute. This is the end of the request. The new request is this one. So this will be the smuggled request effectively. So if I hit enter twice, I should see on the second request a 404 not found, exactly because the first one was the legitimate request and the second one was then the get request to the 404, which is obviously not found because it doesn't exist. And that's basically solves the lab, and it's just a quick way to confirming a vulnerability if you have already a suspicion that this vulnerability exists. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the request smuggling section. Today's lab is HTTP request smuggling, confirming a TECL vulnerability via differential responses. So in a nutshell, it's the same what we have done in the last lab, but this time it's a TECL vulnerability, so that the front end and back end servers, so back end server doesn't support chunked encoding, versus in the previous lab it did. And it's basically the same lab as lab number 2, which we have already done, but this time around we want to call in the smuggled request a non-existing path, and therefore we can actually really determine, so we don't get a 200 response, which we try to trigger a 404, and then based on that we basically know that our request smuggling is actually working. So you see from lab to lab, it's getting a bit more practical in order to actually do something, not just sending a G post or triggering an error message, but actually launching a real request. So first and foremost, we come over here to our HTTP history. We send the request over to repeater, and then we change the request method to a post request, and then we pretty much delete most of the information in here because we don't need it, and we replace it by the skeleton exploit, which I already prepared here, and I will go through this step by step. Once again, like what this actually is doing. So effectively, we are saying content length 4, and then afterwards, like in the smuggled request, we effectively want to do our smuggling. And what's going to happen is basically, so I have set the content length to 15, which is basically this here. All right. I may need to tweak this moving forward. So you can go back to the second leg and look at the manual analysis we have done there. But basically what I'm now doing, I'm going to send this request twice. And if it doesn't work, then I probably have my content length incorrect. So what you can do here is you can use the extension, and you go to HTTP request smuggler first. Actually, let's do this step by step. Let's take the GET request, and then we first of all launch a smuggle probe, right? So a simple smuggle probe like this, hit enter, and this will probably take a bit in order to find our the actual vulnerability. And so for that reason here, I have an extension. The extension is called HTTP request smuggler. I have my output field in here. So the check is running at this point in time. And if it finds something, it will actually populate this here in the target tab. And so I will get an issue notification, and then I can use this specific request to actually feed it into my my attack, my HTTP smuggling attack, and based on this, I will be able to exploit this vulnerability. Okay, this is just taking a bit. So in the meanwhile, while this is running, let's try to do this manually again once more. If I send this twice, I get gateway timeout now. It's the reason I'm getting gateway timeouts is because of the actual smuggling probe. So it can be quite intrusive. So be aware of this. Whenever you do this in the real world, it can actually bring the application to a standstill. And so you want to be very careful with smuggling attacks in general and automated tooling. And yeah, so it seems like that my smuggling request is basically causing trouble. But now actually look at this here. So I see that there is a potential a possible HTTP request smuggling, and I can now take basically this request, and then I right click it, and now I actually say, so the first step was just to detect it with a probe, and the second step is basically to actually run the smuggle attack. And then the smuggle attack, I need to put in here what I want to do. So in my case, I believe I want to send a post right to a 404. So I put in here a post to a 404. I delete my collaborator host. I don't need that for this lab. And let's just make sure that this is all aligned here. And if I'm happy, then I hit attack. And the attack should be starting momentarily. And you can see here, I already get my 404 not found. So this is proof now that my smuggling attack basically was working. And if I go over to the lab, it solved my lab. Okay, I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the request smuggling section, and today's lab is exploiting HTTP request smuggling to bypass front-end security controls. And it's a CL, a content length TE, transfer encoding vulnerability. So it's very similar to the very first one we have done, where we just inflicted a G post. This time around, we try to access an admin panel, which I cannot access directly via the front end because it's blocking this. But due to the request smuggling vulnerability, I'm able to smuggle a request through and then get to the admin panel because I can smuggle a request. Okay, so let's head over to our lab. This is our main page. Once again, if you are unsure in a real world scenario how to do this, you would simply come over here, go to the GET request, and go to extension and launch the smuggle probe. Once the smuggle probe has been successfully done and the vulnerability was identified, you will come basically to something like this. This is a different one from a previous lab, but I'm just showing you. You go to the first request, and then you basically right-click it. You go to Extensions, Request Smuggler, and then you choose whether it's a CLTE or TECL issue. So in this case, it's a CLTE issue. And so what I've done is I already prepared the request and the content length, and in both requests is already matching. This is something where you usually go wrong with the content length, and this is where the automated tooling really helps you, like the HTTP request smuggler, to do this. But basically, the what's happening here, once again, the same like in the first lab, the front-end server does not support the chunked encoding, so we need the content length for the front-end server. Content length is 139. Basically, all these things here, and then it's being sent over to the backend. The backend will take a look at it, and the backend will immediately see, oh, here, like blank termination of message, and then this one goes smuggled across, right? And if all goes well, I should be able, like if I send this twice, first request, second request is the smuggled one, and then I hit the render, I can get to my actual admin interface. So I see the admin panel, as you can see this here. And all that's left to do now is basically I need to put in delete and then username equals Carlos, and then I need to resend it twice again. So first request and then smuggled request, and I get a 302 found on the smuggled request. Perfect. So let's do this one more time to just verify that it actually has been deleted, to call the admin regularly, admin smuggled, and the lab has been solved. Okay, so I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the request smuggling section, and today's lab is exploiting HTTP request smuggling to bypass front-end security controls, but this time it's a TECL vulnerability. So it's basically the same vulnerability as we already had in another lab, but this time around, instead of just initiating a G post or something like this, we are actually going to reach out to the admin panel and then delete the user Carlos, and we could not do this from the front end. So basically the backend server in this scenario does not support chunked encoding, and chunked encoding is only supported like on the front end. The back end is using the content length. And so let's head over first and refresh the page. So first thing I'm going to kick off here is I'm going to send this request, like the homepage request, to the request smuggler, and I say like smuggle probe, right? Like this is always like the first step you should do. You should start smuggling the probes, and then you will eventually see something like this, similar to this one. And in the meantime, we basically, so I have already graphed an exploit, like how it should look like. And let me just take this out here, and then we go through it step by step. Basically, so I'm sending this to repeater first of all, and I need to make sure that we are using version 1. Okay, HTTP version 1. So sending this over, and it's hanging at the moment, so this is completely normal because you are doing the smuggle probe. So I keep saying it, but be careful with the smuggle probes because you can really inflict a denial of service situation here and some web applications. So be very, very careful how you do this. So let's change this request to a post request first and foremost. So change the request method. So this is becoming a post request, and then I put in a bit of information. And so basically the content length is 4. It's up until here, up until the GET request. This is basically what is being read by the backend server, right? So by the backend server, and then the backend server only takes content length 4, so it only processes 1, 2, 3, 4 manually, and then everything else which is coming on the back of it is basically a new request, and this is then the smuggled request. On the flip side, the front end is using chunked encoding, so it will read all this up until the 0, which basically means, hey, here, this is the end of this message, and then it sends it over to the backend. What I'm going to do now is, because, so this 87 here, should be 87 characters, like the message. This is typically always wrong, right? So the content length might be wrong as well. It probably might only be 1, 2, 3 instead of 4. And so what I can easily do is I can use the extension and I say like, hey, smuggle this attack, do a TECL attack for me. And what I want to do here is, well, first of all, let's get rid of the collaborator because we don't need that in this lab. So I want to issue a get to the admin, and I want to delete the username equals Carlos, right? And then I basically hit fire, I hit start here, and it should then arrange the correct content length values for me. So I'm going to do this, and you can see immediately, like in step 2, I get a 302 found. So it was 87, and the content length, well, it was 4 and 87, so it was fine. And it successfully solved my lab, basically. So I was able to delete the user Carlos. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and in today's request smuggling lab, we are looking at exploiting HTTP request smuggling to reveal front-end request rewriting. So once again, there's an admin panel, /admin, but it's only accessible to the IP address 127.0.0.1. And basically what the front-end server does, it adds an additional header to incoming requests containing their IP address. So this is kind of similar to the x-forwarded4 header, but it simply has a different name. So our first task is to find out what this header looks like so we can use it in our smuggled request in order to get to the admin interface through a smuggled request and delete the username Carlos, right? So again, how you would start this off is, and I'm not going through this again because we have done this in the previous lab, is basically you would use the HTTP request smuggler, first of all, to find the vulnerability and then to see what kind of vulnerability we are dealing with. So in this particular case, the backend server supports chunk and the front-end server supports only content length. And so what happens when the backend server receives this, it says, oh yeah, here the message is ending, and then this one is the next request, basically, right? And this is what I've just done. And if you click the render button, you will actually see there is this header becomes visible, right? Like in my output, and I need to take a note of this. So it's -IP. So let me search for this. So if I put in -IP, something like this, and then I see this header. This is basically the header I need, and I copy simply this out. So this is similar to the x-forwarded4, right? And I will put it in here. So now I need to say I'm coming from 127.0.0.1, right? And then instead of putting a post and doing a simple search, I actually will introduce like a get request to delete Carlos. So let me just copy this out here all together and replace it in my request. So everything underneath the host will go, simple as that, right? And I'm going to send this over. 1, 2, and the second one is the smuggled request, and that basically redirects me to the location admin. So this looks good, and my lab has been solved, and I have successfully deleted the user Carlos. I hope this makes sense. And if anything is unclear, go back to the previous videos, like how to do this step by step with the HTTP request smuggler. Okay, thank you very much. Hey guys, this is Martin, and we are in the request smuggling section, and today's lab is exploiting HTTP request smuggling to capture other users' requests. And so basically, this is one of the advanced labs, but it's basically the same concept as before. So we are trying to smuggling a request to the backend server that causes the next user request to be stored in the application. So that retrieves the next user request, and what I'm trying to achieve is to get the cookies of the victim user and then access their account. So first of all, how would you go on about it? Well, number one, it's a blog post functionality. So you would send a regular blog post, right? And simply analyze what's going on here. So first of all, I can see there's a there's a post to the comment when I make a blog post. It's nothing special. There's a CSRF token, a post ID, a comment field, an email address, and a website, right? And this triggers a 302 found. So this is number one, and this is basically what I'm trying to exploit, and I will show you this in a second. And to retrieve that blog post, this is the command, get post, and then followed by the parameter post ID, and then you retrieve the blog post basically, right? So there is a request smuggling vulnerability once again in the application, and I'm not demonstrating this right now how to find it. You will basically set the post, the get to it from the main website. You would send this over to repeater, and then you change the request method to post, and then you right click it, you go to the extensions, HTTP request smuggler, you launch the smuggle probe, and then once the smuggle probe has identified the vulnerability, you basically take this and you will then launch the attack, which you can't do right now because you haven't found the vulnerable post yet. But I've explained this in many videos before, so we are not going to do this right now. So basically, this is how my request will look like. So first and foremost, there's two things to it again, like the backend server supports chunked, the front end server supports content length. So it's the same vulnerability we have exploited a couple of times already. Basically, once the backend server receives it, it says like, hey, the request finishes here at the 0, and then this is basically the next request. And by issuing the next request, basically what I can trigger is something like this. So I send 2 requests, and this is where it gets really, really time consuming. So the second one is probably going to time out. So if it doesn't work right away, we have to do it again and again and again. Yes, it has timed out. So 1, 2, and again, it timed out. So the request smuggling is a very, very tedious process, right? So, but basically, let's do this again. 1, 2, and now it worked. Basically, so now I go over to the page. The page may not refresh right away because now it's dealing with smuggled requests, and I may have to refresh it once again, but then I can show you the outcome. So basically do it once more. And then what you can see here is basically, this is the next request from this Carlos Montoya guy, right? And what you can see here, you get to see his request and it's stored in the application. So what I need to do now is manually arrange the length of that message because I want to read the cookies. So I go to 840 now because it's clearly not long enough right now. It's cutting off here. So I only see like the victim fingerprint, but I actually want to see the cookies. So I send it with 840 twice, and it may or may not work. And it doesn't work in this scenario, so I have to do it again, right? So this is where it gets really tedious and really tricky. So let's do it again. 1, 2, and the second one didn't work either. And we wait until we get our 500 server error, and we do it again. 1, 2. And this time it worked, so I got the 2 200s in response. So now I need to refresh this, and this is actually my third Carlos Montoya fetch, if you want to call it like this. So this one will time out again, and we refresh it. And on the third one, we now say, okay, we have more victim fingerprint here, right? More victim fingerprint than here. So obviously we still need to keep extending our length. So let's try with 860 this time around. So we put 20 more bytes on, and it failed once again. So it's not as straightforward as Portsrigger shows you in the lab. You are dealing with a lot of, like you need to get the timing right for the next request when the user is basically the real user is accessing the page and all these kind of things. So 1, 2, failed again. And we keep going, or we keep doing this until we get 2 successive responses with a 200. 1, 2. Yes, this worked. So now this will time out, obviously, but this should get us to 1, 2, 3 to our 4th application entry from Carlos. And let's refresh it. And now it starts with a secret, right? This is already good. So secret is probably a cookie. So there was the fingerprint. Well, this is all cookie values, victim fingerprint, secret, but it's still not good enough. So I need to extend this further to say 890, 890, not 8,000. And I hit send twice and it timed out on the second request. So I always need to get this right on the cache poisoning, on the request smuggling, basically. 1, 2, and it didn't work once again. So we have to keep trying this, and this is very real world, right? Like this is basically how request smuggling works. But now it worked, and we have to refresh this and see what our output is this time around, whether we were able to capture more requests than in the previous one. So we will see this in a second. This will time out once again. I have to refresh it. And now I have the secret, but there's a semicolon at the end. So this means there's another cookie coming. So probably the session cookie, right? So let's put this to 910 and see what happens here. 1, 2. Again, 500 server error. Once we have the response, we try it again. And this is basically how you deal with those scenarios, right? So this one worked fine on the second attempt this time around. This one will probably give us a 500 server error, and then we go to the next one and see what happened. So once again, refresh this, and now we see the secret, and nothing else was basically shown to us. So I believe the secret alone will not be enough to access the account, but let's just try this. So we go in and put in a cookie called secret, put it in and refresh the page. And no, it's not enough basically. So let's extend this. Let's keep extending this. Let's go on to 930. Send. That looks good. Let's refresh it. This will give us a timeout, a 500 server error once more, and then we refresh it again. And now this looks a lot better. So now we have the secret and the session. And let me check real quick, like how long our session cookie actually is. Let's put this here, and let's copy that session here. Okay, this is perfect. So we were able to capture the session cookie. So now I take the session cookie, the secret cookie is already in there, and I replace the session cookie with the victim session cookie, refresh the page. And basically I have solved the lab because now I have accessed the account as Carlos. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the request smuggling sections. Today's lab is exploiting HTTP request smuggling to deliver reflected XSS. So this time around, we have an additional vulnerability, which is located in the user agent header, whereby we basically can trigger an XSS message. And what we actually want to do is we want to smuggle a request to the backend server that causes the next user request to receive a response containing the XSS exploit, right? So this is slightly different than the previous ones, but from a methodology perspective, it's the same thing. So first and foremost, let's find this XSS vulnerability. So if you browse to any post here, right, you will see that there is a hidden field called user agent, basically. And what we're going to do is we are simply taking like this GET request to that post ID, put it over to repeater, and then we start messing with the user agent. So first I put in Martin, right? And then let's see if this is reflected somewhere, and you can see it's basically reflected here, right? So what I need to do first is I need to break out of this angle bracket, and then I simply put in a complete new script tag, alert 0, and I close this out, right? So let's try it like this, boom, and then let's see if alert is, or if this is reflected, and basically here it is. So it's reflected without any encoding, without any sanitization. When I show the response in browser, so that's the first thing to do, right? Like to verify that XSS vulnerability, which we just have done. Now we want to smuggle this request so that the next user basically gets the response. And so how you will go on about it is the same way as we have done it in previous labs. You send the GET request, first of all, over to repeater, then you transfer this into HTTP1, then you change the request method, and then you would simply right-click, go to extension smuggler, and smuggle the probe. Once the probe has been positively identified, you can then basically launch the actual attack. Now, for that purpose, I have already prepared like our skeleton exploit, which I'm going to put in here, basically. So what's happening here is effectively that the front-end server supports content length, the back-end server supports chunked. So when the back-end server receives the message, it will basically come until here and says like, okay, this is the finish of the message, and then this one will be effectively smuggled as the next request, right? And in order to do that, like, let me try this right away if this works. It probably doesn't, because the content length and so forth is probably incorrect. So what I can do now is I right click this, I go to extension smuggler, and then I use the CLTE attack. And then basically in there, I need to replicate my payload. So the payload is basically, I need to get the user agent over, and let's just see. I need to get the user agent over, and I don't need to ignore X down here. So let's just delete this, something like this, right? Like, and then the user agent will have the malicious script. So if we launch this attack and we fire this, we get 200 responses, and this is basically finishing my lab. So this was successful. We were able to successfully smuggle the request over, and another victim user of the next request basically got the XSS payload. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the request smuggling section, and today's lab is response queue poisoning via H2TE request smuggling. So basically, modern web technologies often use HTTP2, but the vulnerability here in this particular lab is that the front-end server basically downgrades HTTP2 requests, even if they have an ambiguous length. And so basically that allows you to introduce poisoning into the queue and to access the admin panel, while first of all capture a cookie of someone else and of the administrator, and then basically delete user Carlos. Now, these labs moving forward, like the next 5 labs or something, are extremely difficult to replicate, because sometimes it takes you like half an hour to get the timing right and things like that. So I have pre-done this for you to understand, but I still will walk you through the steps. So you have your main page first and foremost. So what you always do, like, you will come here, and then you will basically change that request to a post method, right? Like, let me just show you this real quick. So you send it over to repeater, and then you change the request method to post. And this time around, you use once again the extension smuggler, HTTP request smuggler, but this time you launch an HTTP probe. So that's just like to find the vulnerability itself. And then once you found this, basically, if you go to the dashboard, you will see something like this. Like, there is this HTTP vulnerability, and then I have manually crafted my request, and I will go through this one by one. So this is basically my request. So what I'm doing is I'm sending an incorrect post, which should trigger a 404, right, with the transfer encoding chunked. The server then basically sees this message and says like, okay, that's the end of message, and then this is basically your smuggled request seen from the back end, right? And what should happen is that I then can be able to capture a 302, which is basically the cookie from the administrator. So this requires a lot of user interaction, right? And if you keep sending this, you normally get a 404. You always get a 404, and then you need to come back to the home page, refresh it like 10 times in order to clear the queue, and then you try it again. You send it once, you give it a couple of seconds, you send it again, and okay, and once every 10 minutes or 15 minutes, you will actually be able to capture this 302 found. And that effectively means you are able to successfully poison the smuggle request, or smuggle this specific request to the back end, and then capture the request of the next user. That's effectively what you're doing. And then you take this cookie, which you then facilitated here, you come over here and you run this against admin, and then you can see that the admin panel becomes visible, right? And because now I have the correct session cookie, so I don't need to do poisoning here anymore or anything, because I have the cookie already. So once you have the cookie, it's easy game. And then you say simply delete username equals Carlos. But keep that in mind. I mean, it's already difficult to find or to facilitate such an attack in the labs. So you can imagine this will be even more tough in the real world, like when you're doing this against a live system or something like this. You always have to get the timing right, and it obviously always requires user interaction. So it doesn't really work if there's no user clicking around or visiting the page and things like that, because if there's no activity, you cannot pull this attack off. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the OS command injection section. And today's lab is blind OS command injection with time delays. So once again, blind means I do not see the output. I don't directly know whether my payload worked or not, but I can often introduce like something called a time delay. And then if the application takes longer to respond, then this might be a problem, or this will then indicate that the command injection was successful. So here we have a submit feedback form, and I'm just filling this in with like various messages, and I hit submit feedback, and see feedback was submitted. Okay, great. So let's head over to Burp and let's take a look at this actual request. And so you would now test every single parameter here for command injection. The lab already told us that the email parameter is vulnerable. So I say email equals X, anything, right? And then I introduce the double pipes, which is like a command separator in Linux. And now I issue a ping command. Ping plus means basically a blank sign, minus C, so that's the count command, and then plus, and then I'm going to put in 10, so plus minus C, the count is 10, and then the actual IP address I want to ping, which is 127.0.0.1. Okay, so I want to ping the local loopback and another command separator. So if I now send this command, what should happen is that it should take 10 seconds until I get my okay. And let's see, it looks good. There is, I still didn't see the response. So that indicates that the command injection is working and it's issuing a ping command. And now I have the response, which was approximately 10 seconds later, and the lab has been solved. So this was an example of how to introduce time delays to verify that command injection is possible. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the OS command injection section, and today's lab is blind OS command injection with output redirection. So very often you will come across blind OS command injections where basically the output is not visible or is not being returned to you. And then you can use functionality like the Burp collaborator or an external server to try to exfiltrate to that. We will come to this in a later lab, but another option is sometimes you have writable folders, right? And if you do have writable folders, you may be able to write into a text file in that writable folder and then retrieve it from there. So we are going to take a look on how we can basically achieve this. So we have, once again, in the application, we have a submit feedback functionality, and I'm just putting like a couple of test parameters in there to show you this in Burp, how this looks like. So feedback has been sent, fine. So let's take this and move it over and basically look at our parameters here, right? Like we have the email, and we know that the email one is vulnerable. In reality, you would have to test all of them. But what happens now if I say, for example, email X and then double pipe, which is the command separator. Now I say, who am I? Who am I? And before I do this, actually, let me go back here and show you something else. Like if you go to the home page and it's loading those images, I want to see like the path of those images. For that reason, I need to actually enable images here because it's not enabled by default in Burp. So I see like, hey, here's like this image called. Okay, so let's just send this over real quick. And this is loading an image, right? Okay, here you go. So we know from the lab that there is a writable folder which is var ww images. So let's take this out, go to repeater, and then put the who am I command and then redirect this over, right? So redirect it here and then call it martin.txt, for example, right? So I want to redirect the output of who am I, which is a Linux command, into a file. And that's what I'm doing here. And then I simply put two command separators in here. So now I'm sending this, and it took it, okay, fine. And now I can actually check, so it's probably being written here into the same directory as my images. So let's check. And here we go. So this is the solution effectively. You see that we have the who am I is Peter and -af la la la. Okay, so this solves the lab, and this is an example how to do OS command injection with output redirection. Thank you very much. Hi guys, this is Martin. We are in the OS command injection section, and today we are taking a look at blind OS command injection with out-of-band interaction. So very often you will come across scenarios where your command injection may work, but you don't see the output. And then you can try to trigger out-of-band interactions with, for example, Burp Collaborator, right? And in this lab, this is exactly what we're going to do. So let's head back. The vulnerable function is in the email field over here. So I'm just populating this with test values for now and submit the message. Then I head over to Burp and then send this to repeater so I can play with it. So first things first, we know that the email parameter is vulnerable. This is something whereby you would test all of them to start with. But I put XX and then a double pipe. And then in there, I'm now issuing an NS lookup, which should trigger a DNS lookup basically, plus, and then to X, like an unknown or a subdomain of the Burp Collaborator. So let me create a new Burp Collaborator here, copy that to clipboard, head over and put it in here, right? So what I'm doing now is basically I'm only instructing that do an NS lookup to x.burp collaborator domain, right? And I hit send. And as expected, I don't get any visible output, but if I go to my Burp Collaborator, hit poll now, and I should actually be seeing a response, which I currently do not because maybe I have forgotten something. Yes, I need to finish the request here with the double pipes, the command separator, do it again, go over to Burp Collaborator, and here you see I have my DNS lookup. So all this, there's no data exploitation or anything, it was just a DNS lookup to that X, which like the fictitious subdomain of the Burp Collaborator, and I got the IP address and the port from where this was launched. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the OS command injection section, and today's lab is blind OS command injection with out-of-band data exfiltration. Now, this is a follow-up from the previous lab. This time around, we don't just want to trigger a DNS interaction with the Burp collaborator, but this time we actually want to exfiltrate information of a command. Okay, and it's relatively straightforward to do. Let's head over to our application. Once again, the vulnerability is in the email field, which I know already, but you would test all of them, all input fields for that in a real world engagement. And let's just take this post request, send it over to repeater, and basically let's get started here, right? So we have our email, we know this is vulnerable, so we put it to X, command separator, and then we say this time around ns lookup, okay, ns lookup plus, so which is a space sign, and then in backticks my command, who am I, and backtick closed, dot, and then my Burp collaborator domain. So basically what this is doing is it is appending the output of my who am I command as a subdomain in the request. Okay, so this is my actual domain, this is my Burp collaborator up until here. But what I'm saying is like use the who am I command, launch the who am I command, and then append that, well, do an ns lookup basically, and then issue the who am I command and append that here as a subdomain to the Burp collaborator domain. Let's send it. Okay, it's blind, you don't see any output, but if you head back to the collaborator and if you do a poll now, you see, hey, there was an interaction. And the interaction now shows me here, this is basically my who am I output. It has been put as a subdomain of my Burp collaborator domain. If I take this, I head over and I submit this as a solution, this basically solves the lab. I hope this makes sense, and I'll see you in the next video. Hey guys, this is Martin. We are in the server-side template injection section, and today's lab is basic server-side template injection. So if you don't know what is template injection, I recommend reading up the theoretical part here on Portswigger. But in a nutshell, what it is, you see modern web applications, content management systems, where, for example, you can manage your articles, your stock, and things like that. And very often markup is being allowed, so you can make the graphics look nicer, or use some formulas to calculate certain things around your stock. And the problem arises if a malicious user is able to issue system commands and it's actually being taken by the application as system commands rather than just being displayed on the page. And that is really server-side template injection. So in the first one, we are dealing with ERB, which is also Ruby. So a Ruby template. And with that information, let's get started. Our goal is to delete the home carlosmorali.txt file through server-side template injection. So let's head over to the application. We can see there's the application. If I click on a product, I basically get a message, this product is out of stock, right? So let me actually send this over to repeater, and then we can see this on the repeater side as well. So unfortunately, product is out of stock, right? So you can see there's a parameter called message, and the message takes some sort of input, right? So if I do a mouse over, you see there's like a lot of %20s, which is simply like the URL encoded equivalent of a blank space, and there's nothing else than this message. So I recommend to head over to something called the book.hacktricks.xyz, and in there's a server-side template injection section, right? And it explains it very detailed, in my opinion, more detailed than Portswigger. And what we do is we are searching for Ruby here, right? Because it already said in the lab description that it's Ruby. And so we now trying like different injection or template specific injection commands, right? So let's take the first one, this one here, and simply append this to the message and see what happens, right? So I probably need to URL encode this as well. and I say here, convert section URL, encode all key characters. And then I hit send, and then I do render. And now I see something interesting, basically. I see, unfortunately, the product is out of stock, 49. Why 49? Because I instructed it here. Like what I put in is basically a command which does a mathematical operation 7 times 7, and that's 49, right? So this is basically how template injection works. And for bug bounty programs, that's usually sufficient, right? Like you prove the point, you say, hey, here is a template injection vulnerability. In our case, we obviously have received a task to take this to the next level, which effectively would mean we need something like this, right? Like we want to issue a system command, and in this system command, we want to put in rm, remove, and then home Carlos Morali dot text. So instead of doing an ID or an ls or another Linux command or something, we are instructed to do this, right? So again, I could put like 7 times 7 in there, which I've just done. But this is a system command, so you need the prefix system here, right? Like, and that's you can go through, you can go on Google and look for ERB Ruby template documentation, and then you find all that, right? Or on this website which I've just shown you. So let's head back, and now let's try this to put this directly into the browser here, right? Like, so instead of this, unfortunately, product is out of stock, I put this one in and hit enter, and if all goes well, my thing should be deleted. It has not taken it yet. Okay, let's try this again. Otherwise, we do it in Burp, right? And yes, so this worked. So basically, I was able to use template injection to issue a command. It's kind of a command injection vulnerability as well. And I was able to delete that file. I hope this makes sense, and I'll see you in the next lab. Hey guys, this is Martin. We are in the server-side template injection lab, and today's lab is basic server-side template injection in a code context. So this time around, we are using a different templating engine. There's a vulnerability in the Python Tornado template. So you would head over to Google and look for Python Tornado specification, right? So if you do this in a real world environment, you use a ton of payloads like you can find here on the book.hacktricks.xyz. And then first of all, you have to identify what kind of templating engine is being used. In this lab, we already know it's Tornado. And then our job is to delete the home Carlos Morali.text out of that application, right? So let's head over and let's go to our account first, and you will see something interesting. You have like a preferred name field, right? Like, so if I say, like, how do I want my blog posts to be displayed? Like with name, first name, or nickname? So let's do name first. Let's come over. Let's go to a simple blog post and wedding bells and make a comment and say Martin, right? Post comment. Let's go back and let's take a look, and it says like Peter Wiener. Okay, so this is the name apparently. So if I now come over to my account again, and now I say nickname, so I want my display name to be my nickname, come back over here, go to wedding bells once more, and then basically see, okay, it's changed now to hot dog, right? Because that's my nickname. So this functionality may be interesting for us to facilitate a template injection. And let's take a look here. So I sent this over to Repeater, and you can see it says like blog post author display username, right? So if I send this, boom, and then I refresh the page, and now it goes back to username. See that? Okay, cool. So let's take a look at the Python Tornado description here, and you can see to test for this, I can use something like that, right? Like curly bracket, 7 times 7, curly bracket, close, basically. And I take this over, but what I want to do first is I want to close any other functions out first. So this is the same like you breaking out of context in cross-site scripting basically, and then put our actual command in there, right? Like something like this. And now if I refresh the page, I should basically see if this works, and it does, because it now says Peter Wiener 49. Why it says 49? Because my 7 times 7 was evaluated and a mathematical operations has taken place on that input. Okay, so this is great. So our job is not to display a 49 or 7 times 7. Our job is actually to delete Carlos Morali. And what you need to do is basically you need 2 commands here. Number 1 is first of all, you need to import the OS. So you instruct the template to use OS system commands, and then you actually need the command, something like this, right? But we don't want who am I, we want to remove home Carlos Morali .txt, something like that, right? And let's see if that works, right? Like let's head over to Burp and replace the 7 times 7 with that and see if this works. And if we head over here and refresh it, basically our lab gets solved. So our command injection was successful, and we were able via command injection to actually delete the file we've been tasked to. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the server-side template injection section, and today's lab is server-side template injection using documentation. So in this scenario, this is more real world, right? Because we haven't been given the actual templating engine. So we need to find out first to generate an error message or something to see what kind of templating engine it's using, and then we can exploit this, right? So for that purpose, we have been given like a login to something called Content Manager. This is what I said earlier, you know, like, so this one shows you a real world example, like how templating engines are typically used. So let's head over to our application and let's log in as the Content Manager. And then we head over to one of our products, basically. So let's take the first one here. And this is the product, and then we have an edit template. And this is how it typically looks like, you know. So there's like some HTML in there, and then you can see that it's basically, so if you look at if you save this and go back, you see that there is like dynamic information drawn into that template. Like, for example, there's only XYZ left at a certain price, right? And how this is done is basically it's putting like a $ and then the product price, right? So what happens if I introduce an error here? Like I copy this, and instead of product price, I say Martin, right? And then just to inflict an error, and then say save, and wow, here is my error. And it immediately throws me what kind of template engine it is. It's a free marker, which is Java, right? So by simply doing this, I was now able to enumerate what kind of templating engine we are using. So let me remove this, but I know now that it's a free marker, right? So with that in mind, we go over to the book.hacktricks.xyz. Take a look. Here's free marker, right? So we can now basically craft our exploit. And what we want to do basically is we want to do something like this here, right? Like, so this is the code, and you can find this in other places, right? Like now that you know that it's free marker Java, you will go to Google and search for the documentation, and then you find how you can invoke system commands and executable commands and whatnot. But basically, we don't want to just output the ID. We could do this. Let's do this to start with, right? Like let's just output the ID. Let's put this in here, scroll down and come in here, save it. And if all goes well, I am outputting the ID. So I'm logged in as user Carlos, and then you can see this is basically the ID command on Linux, right? But this is not our intention. Our intention is actually to say rm remove home Carlos home/Carlos/Morali.txt. So we want to delete this text file. Now we hit save again. And when it's displayed, it's basically solving our lab because we injected successfully a command through the templating engine, and we were able to delete that file. I hope this makes sense, and I'll see you in the next lab. Hey guys, this is Martin. We are in the server-side template injection section, and today's lab is server-side template injection in an unknown language with a documented exploit. So documented exploit basically means someone else already exploited that and it can be found somewhere on the internet. But we need to identify the template engine first, and then we basically look for this specific exploit, right? So let's get started. Let's head over and we click on a product, and yeah, all normal on the product here. Let's click on the first product and we get the same error message like in another lab, right? Unfortunately, this product is out of stock. Okay, so and you see the messages just appended here. Basically, one trick which is like really useful when hunting for those kind of things is to simply send something like this, right? Like, so this is a ton of dollar sign, curly brackets, angle brackets, percentage signs, ticks, basically double quotes, and all these kind of things. This is mainly, well, first of all, to see if anything is filtered, but also to see if I can inflict like an error message or something. And an error message often reveal what's the framework and what's the template engine behind it. So if I put this in, it doesn't take it on the first go. Let's try it again. And there you go. So basically, you now get an error message, which is it's a verbose error message, and it gives you quite a lot of information. So one thing I instantly see, it's called handlebars. So there is a templating engine called handlebars. And now that I know that, I can go to Google and look for exploit for handlebars and, command structure and so forth, right? So what I'm going to do basically is I head over here once again to my hacktricks, book.hacktricks.xyz, because a lot of the information is already there. And here is, for example, an exploit, how you can basically exploit this and inject a command, right? And you can see that here, this is the who am I command. I'm not interested in this. I want to do an rm home Carlos Morali .txt instead, right? Now, the problem you may ask, hey, how do I get this into my message parameter, right? Like, and that's a good question actually. So you cannot put it in like this, basically. So what you need to do is you head over to Burp, and then you basically go to the decoder, you put this in the decoder, and then you say like encode it as URL, because now you have all this exploit basically URL encoded over here. So I just take this out, and then I move back here, and instead of putting my scrambled message here from earlier, I put the URL encoded value in there, and that solves my lab basically. So that deletes my my file which I was tasked to, and that solves the lab. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the server-side template injection labs, and today's lab is server-side template injection with information disclosure via user-supplied objects. So once again, we have a vulnerability, an SSTI vulnerability here, and this is due to an object being passed into the file template. So the same thing as before, really, but basically we need to steal a secret key effectively, right? And we have been given credentials once more to log into the content manager account. And let's do this. Let's head over and let's log in as content manager, and we then head over and choose a product, right? So we go to product, we have the edit template option. So first thing you would do once again is basically inflict an error, right? So you can put like an error code in there, something like this, right? Like this is the same one I've shown you before. This is simply to inflict an error and see if there's any filtering in place and whatnot. And you put that in, and then you get an error message. This is great. And the error message reveals immediately what kind of templating engine it is. And it is actually Django, right? So now that we know that, we can basically go to the Django documentation and start looking for commands to exfiltrate things. You can also head over to the SSTI, the server-side template injection section on Hacktricks, book.hacktricks.xyz, and you simply put in, like the debug command. So this is like the Django section. So you put the debug command in there, and let's see what happens if we save this. And then it basically gives you a lot of information around debugging. And you would then go through these and read through the Django documentation and then see how you can actually exfiltrate important things or scan for important things. So one command or one setting which exists in Django is like the settings.secret_key, right? So you would simply take this command and replace the debug one with that command effectively, and then hit save, and it's able to extract that secret key for us. Okay, so this is just like one example. There's a million things you can do with it, and normally in bug bounty you don't really have to do this, right? Like you only prove the point that there is template injection. However, in a penetration test engagement, customers often want to see, hey, how far can you actually get, and how is there any possibility for lateral movement and things like that. So then you would exploit this to the next level. But in this simple lab here, we are just extracting that information, and that solves the lab for us. I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the directory traversal lab, and today's lab is file path traversal. Traversal sequences blocked with absolute path bypass. So we will take a look how this looks like. Directory traversal basically means that you can jump from one location on the file system to another location and then basically access information you're not supposed to access. So let's head over to the lab and let's refresh the page. And one thing we're noticing is there's a lot of pictures, right? So let's head over to Burp, to the proxy history, and we don't see those pictures loaded, and that is because they're by default not shown in Burp. So if I enable this here, I see that those are all the pictures being loaded. So let me take one of them and send it over. And then, so you see it's making a call to image, and then with the parameter file name, and then simply the JPEG name of that specific file. So in this case, 21. So as you remember from one of the previous labs, we tried something like this, a path traversal sequence in order to get to the etc passwd password, right? And let's try this again, and this time this doesn't work, right? So there's some filters in place, some mechanisms in place. Now, one bypass, and there's numerous bypasses, and we will look at the most common cases in all these labs, but one bypass is that you basically do not attempt a traverse or path traverse sequence, but you actually try to get to etc passwd directly. So you're attempting to do this from within the root directory, is as if you were already in the root directory. And sometimes this works. So let's do this. And in this case, it worked, right? So I was not able to do this with the // and so forth, but I was able to do it when I simply supplied the etc passwd path directly to the file name. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the directory traversal section. Today's lab is file path traversal sequences stripped non-recursively. So this is yet again another filtering problem, and we will see how we can bypass this in certain situations. So let's head over to the application. If you load the application, basically you can see that there are calls being made for these pictures, right? So whenever you see something like this where you have a parameter, the alarm bells should ring, like in general, like, for cross-site scripting testing or for any, is the input sanitized? Can I attempt a path traversal, directory traversal attack and things like that? So if you take a look here, we have done a couple of labs already. So our first lab, basically we tried this, right? So we tried to jump back in the directory to the root directory effectively. And then we tried etc passwd. Let's see if this works. And it probably doesn't, right? So yeah, this is being filtered. So the second lab was like, hey, what if you supply like a path like this, right, without the traversal sequence? It also doesn't work in this scenario. Okay, so another thing developers sometimes do, they filter those path traversal sequences out, right? Like, for example, if you do something like this, right? So they filter those out. But if the filter is not configured correctly, or the regex, the regular expression is not configured correctly, they may only filter this out once, right? So a common bypass is, for example, that you add another path traversal sequence in there. So you add another 2 dots and another slash, and another 2 dots and another slash. And reasoning for this is because maybe they filter only one occurrence of this, and then they leave the second one basically untouched. So what if they filter the first 2 dots and that slash, then you still end up with a dot dot slash, right? So this is the reasoning behind it. Let's see if this works, and it does. Right, so in this case, there is the filter is configured, or the regex is configured incorrectly, that it's only looking for one occurrence. But if you put multiple occurrences in there, then the subsequent ones go unfiltered effectively, right? So, and that solves the lab. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We're in the directory traversal section, and today's lab is file path traversal, whereby there is traversal sequences which are stripped with a flawed URL decode. So what's happening here is the developers thought about file path traversals, and it basically, the server is, or the application is URL decoding the input before using it, right? So it takes the input and then it analyzes it, and if it contains a malicious sequence, it will strip it out, right? But maybe we can bypass this, and this is the purpose of this lab. So first and foremost, if you take a look at the previous ones, like these are the previous labs we have performed, and none of these sequences would work in this specific scenario, right? So let's once again head over and let's take one of those files to play with it, send it to repeater. Let's take a look. Okay, looks good. So what happens if I attempt a normal file path traversal, like something like this, like in the very first lab, and it will most likely fail. Yes. So what can we do, right? Like, so basically you can start taking this and move it into something called the decoder, and then you can, for example, URL encode this. So if I say encode URL, so you get a URL encoded value. Let's do this. Let's copy this and head over to the repeater and replace it with the URL decoded value. And it doesn't work. Okay, so fair enough, because maybe what I presume what's happening is the application is then URL decoding it, and then it sees the malicious payload, and then it says like, hey, this is an attack, and I'm going to block this. But what happens if I double URL encode this? So I have, here is my first URL encoding, and then I say encode URL again. So now it's double URL encoded, right? So I take this value, and then now I replace my payload with the double URL encoded value, something like this, right? And what's happening is that works. So we have solved the lab by simply double URL encoding our payload. Logic behind this is that the server will only URL decode it once, but then it doesn't see the vulnerability, or then it checks for the dot dot slash and it doesn't find it. But it's still, if it would decode it twice, it would find it. But because it's only decoding it once, it will not find it, basically. So this is another bypass you may want to attempt when looking for directory traversal. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin here, and we are in the directory traversal section, and today's lab is file path traversal, validation of start of path. So sometimes application implement various different filters, what they expect in terms of user input. So sometimes they validate the start of the path. Now let's head over to the lab, and if you can see here in Burp, basically there is images loaded, and what you can clearly see is different than in the labs before, right? So this time the file name says var www images, right? So if I send this, I get to my image, right? So if I would attempt a normal path traversal sequence, like something like this, like we have done in one of the earlier labs, or any of the other payloads, as a matter of fact, it does not work effectively, right? Because it complains, it gives me an error message. So if we head back maybe we have to start at var www images. So maybe it's verifying this portion of the path, and then I can attempt a path traversal sequence from here, right? So not initiating it from the start, but actually going into that images folder first, and then change the directory outwards. And then once you're back in the root directory, you basically call the etc path.wd file. Let's see if that works. And it does. Right, so effectively the server is validating that the path starts with this, but then they fail to sanitize input, and they then allow basically the path traversal sequence to occur. So this was not going to work if you put it at the very start of the file name, but if you first of all follow into the images folder, so it's only checking like, hey, is this correct? Yes or no? And if that's correct, then you can initiate your path traversal sequence. I hope this makes sense, and I'll see you in the next lab. Hey guys, this is Martin here. We are in the directory traversal section, and today's lab is file path traversal, validation of file extension with null byte bypass. So effectively, developers have tried to mitigate against directory traversal by looking at the file extension effectively. So, right, like when you issue a command, it has to have a correct file extension. So, for example, it's expecting a JPEG or .png or anything else, like a graphic format, but the etc path.wd does not have an extension, right? So, this is the logic behind that protection mechanisms. But this can also be bypassed. So let's take a look. First of all, let's load one of those images. And I send it over to repeater. And I attempt a normal path traversal sequence and see if that works. And I say path.wd, no, etc path.wd, something like this. And it doesn't work. Now, I know here that it's expecting JPEGs, right? Like it's expecting JPEG values because the file name equals 48.jpg, or so it's expecting JPEG. So what I can do is I can put in something called the nil byte, something like this, and then finish it with .jpg. So what's happening with this payload is effectively that the nil byte terminates the query. Okay, so I need the .jpg so that initially the conditions are satisfied, right? So because it expects a JPEG, but when it actually reads it out, it will stop here. So the null byte breaks like the query effectively, and the null byte simply makes sure that, well, it only reads until here. It only reads until the path.wd, but I can put the extension in so the server is satisfied that my call is actually made to a JPEG extension. Like, let's send this, and you see this perfectly worked fine. So we were able to trick the server that it returns content type image JPEG, right? As you can see this here, as requested. But then, as a matter of fact, it outputs a text file, right? It outputs a text file because we have tricked the application on stop or on stopping reading after the path.wd. Okay, this solves the lab, and I will see you in the next one. Hey guys, this is Martin. We are in the access control section, and today we are looking at URL-based access control can be circumvented. Okay, so the website has an unauthenticated admin panel located at /admin, and the front-end system basically has been configured to block external access to that path, right? However, the backend application is built on a framework that supports the original URL header. Okay, and now if this is implemented incorrectly with missing access control, we might be able to access that admin panel and delete the user Carlos. So let's move over to the application first. And you see there's this admin panel here. So if I click on this, I get like access denied, right? I simply get access denied because it's a front-end protection and I'm not supposed to do this. So let's head over and let's basically send this request to repeater. So what happens if I change the path to a standard GET request to the main page. That works, right? Because I'm not trying to access the admin panel. But now I can introduce that x-original URL header, right? And I simply say go to admin, right? And see if that works. Like if the backend is processing things differently than the front end, I may have a success message here and I am able to get to it by simply using the x-original URL header. So because the backend system is analyzing this, if this is set to a certain path, it will take me to that path. Simple as that. The main GET request is still to the main page, as you can see this, but this basically overrides it. Now, you might be asking like, hey, how you find this x-original URL header? Well, basically, the lab has given me this, right? But in reality, if you do a pen test or if you do bug bounty hunting and things, you can use a tool called Paraminer. It's a Burp extension, and then you let that run. And once it's finished doing its magic, it will show you a lot of the headers and get parameters and whatnot. And so you can basically get to this information that way. So let's continue. Like, what happens if I go to admin/delete, right? Like, what does that give me? It's giving me an error message and it says missing parameter username. So I now basically, and this is where it gets a bit funny. So let's go to admin again. Let's look for Carlos here. And you can see there is the path admin/delete, and then I need to also put the username equals Carlos, like the user I actually want to delete. But if I try this here, username equals Carlos, right, then I get an error message. It says still missing username. So what I need to do is I need to actually append that username parameter up here in the actual GET request, something like this, right? So this is now where I specify my username Carlos, the one which is going to be deleted, and the path I want to get to is the admin delete. Let's hit send. And let's verify this if this worked. So if all has gone well, basically Carlos should be deleted, and Carlos indeed has been deleted. And that solves my lab. And I hope this makes sense, and I see you in the next section. Hey guys, this is Martin. We are in the access control section, and today's lab is method-based access control can be circumvented. Okay, so basically we have been given two accounts. One is an administrator account, which I'm going to open up here in the yellow PornFox virtualization browser. So it's basically to simulate a different browser, right, where cookies are not being shared, like completely isolated. And then we also have been given a Wiener Peter user, which is a regular user. So the idea is that we log into the administrator panel first and familiarize ourselves with all the methods and what's being done and whatnot. And then we try to perform an administrative action with the Wiener user, right? And we are basically bypassing a security control, which should only be accessible to administrators, but it can be bypassed. That's the idea. So first and foremost, let's log in here with the username Wiener and Peter. So that brings me into my account. That's a standard account, as you can see, right? Like there's nothing special, no administrative function whatsoever. And if I come over here and I log in with administrator and admin, that's the admin account. And you can see there's an admin panel, right? And in the admin panel, I basically have the possibility to upgrade or downgrade users. So this is effectively, Carlos is a normal user right now, but I can upgrade that user or I can downgrade that user. So upgrading means from normal to admin, and downgrading means from admin to normal. Right? So let's upgrade this user first and foremost. And now Carlos has become an admin, right? So this is cool. This is we just wanted to see the functionality. Now let's head over to Burp, and you can see this here. This is nice with PornFox that you can actually separate them with colors. So everything you see in yellow is basically the admin or all the calls I made with the admin, and everything in blue is the calls and the respective cookies of Wiener user, right? So let's take this one. Let's take the admin role change, which we have done on behalf of the administrator. So where we upgraded Carlos, right? So this obviously has the session cookie of the administrator. So if I would put in Wiener here, then nothing is really going to happen. Or, well, it's going to work, but the problem is that, well, the administrator can do this, right? Our goal is to actually mimic this on behalf of the Wiener user. So first of all, we want to set the username to Wiener. We want to upgrade ourselves, right? But we don't have the admin session cookie. So what I have to do is I have to replace that cookie with the cookie from Wiener, right? Because I don't have admin privileges. I hope you're following. So I'm going to replace the cookie. So now this is a request launched from Wiener without administrative control. So I'm trying to upgrade the Wiener now. Okay, can I do this? And it says unauthorized. Okay, so I get an error message. So what if I change this to post X, for example, just for testing purposes? And now it says missing parameter username. Interesting. Okay, let's try a post again, unauthorized. Okay, so the developers have certainly put some access control restriction on this post request, whereby they verify that this session, this cookie, is not an administrative cookie, and therefore I'm not allowed to perform this action of upgrading a user, right? So you're following? I hope so. What I can do now, or what I can try, is I change the request method. So I'm changing the request method to a get instead of a post, right? And sometimes this works. And now you have simply the command appended here as parameters. And if I now hit send, I get a 302 OK. And that means I was able to bypass that access control by simply changing the method from post to get. And I'm still using my session cookie, which is the user cookie, not the administrative cookie. And if we head over to the lab has been solved. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the access control section, and today's lab is multi-step process with no access control on one step. So this is a common problem in the industry that sometimes developers implement access control on one step, but fail to do this on another step because they assume that access control on one step is already fine. Like this is if you have like a multipath process or something with a confirmation message, and then they implement access control on the first one, but not on the second one. And this is exactly what's happening here. And for that purpose, we have been given two different accounts again. So first, we are going to log in as an administrator and walk through the process, how it works from an admin perspective. And then we also been given a Wiener Peter login as a regular user. And the goal is that the regular user is making an administrative call or an administrative change, which the regular user should not be able to. So let's log in first as the regular user, Wiener Peter. I do this here in PornFox, and that's so I can separate my browsers and like have virtual instances of my browsers. As you can see, if I log in as Wiener, nothing special. I simply have my account and no administrative function. If I go over and log in as an administrator, sorry, I need to say administrator here and password admin, and you can see there's an admin panel. So let's check this admin panel out. And it's the same like in the previous lab, basically. So what I have is I can promote users. So I want to upgrade user Carlos. So I hit upgrade, but this time around I get a confirmation message which says like, hey, are you sure you want to do this, right? And yeah, I want to do this. I'm administrator, right? So now Carlos has become an admin. Let's head over to Burp and look at what happened there. So effectively, you can see here's the post request. This is the first post request, which said Carlos and upgrade, right? But then there is another post request to the admin roles, and which says like action upgrade confirmed equals true, username equals Carlos. So if I would do the same testing what I've done before, I would find that the first request here to admin roles is not vulnerable. So I cannot tamper with this. If I change the cookie for my own, I would not be able to actually promote myself as Wiener, right? But the flaw is in the second request here. So let me send this over to Repeater. And now I'm changing the username to Wiener. If I would now send this, it would work. right? Because I'm admin, I have the admin cookie, but I'm going to exchange the admin cookie for my own cookie, for the non-privileged cookie of the Vina user, basically, right? So now I'm not an administrator anymore. I have the session cookie of the Vina, and now I'm attempting to upgrade myself, username Vina, to an administrator. And if I hit send, this is working. So the developers have forgotten to put access control on the second step of the upgrade process. And if you head over here, you see the lab has been solved. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are taking a look at the access control lab, referrer-based access control. So the problem is that sometimes developers assume certain things in the flow, right? Like, for example, that you can only perform an action if the referrer is set to a previous page, which in a normal user flow should have been visited. But this can often be bypassed, and I'm going to show you how this is being done in practice. So once again, we have two accounts. We have a Vina Peter account, which is a regular user, and our goal is to perform an administrative action from the Vina account by upgrading the Vina itself to administrative levels, right? And then we have an administrator account, which we are going to use to look at the flow first and foremost, like how it actually looks like. So I go to the admin panel, and now I'm going to upgrade the user Carlos. And now the Carlos is an admin. Let's head over to Burp and take a look what happened here. So first thing I see is let me send this to repeater first. So this is basically a GET request, which is not ideal for numerous reasons. Like if you do a change, state changing action, you should normally always do this in a post request, but that's something different. But basically, so this was the action I performed, and the access control basically is done based on this referrer header. So first and foremost, let me remove this referrer header, or let me copy this referrer header to a text editor, right? And now I'm going to exchange the cookie from the blue account, which is the Vina account, basically. I thought I logged in there. No, I probably haven't. Let me do this again. So let me refresh this real quick. I logged in already. And yes, so this is basically my account of the Vina, and I'm taking this cookie, and now I'm going to replace the cookie with the admin cookie with the Vina cookie. So now I'm unauthenticated, or I'm authenticated as Vina, but I don't have admin privileges at that point. Okay, so that's the important part. Now let me remove the referrer header altogether, and let's change the username to Vina. And I hit send, and what's happening, it says I'm unauthorized. So I would expect that I'm unauthorized. I have my session cookie. I'm not an administrator. But now the problem is that if I set the referrer header, right, like let's put it in here, and the referrer header says that I'm coming from the Web Security Academy main domain /admin. So I have visited the admin panel before. So the developers made this flawed assumption that if I'm coming from /admin, then I'm authorized. So it's not even checking the cookie, right? So I'm authorized to do this action, which is a logical flaw. It's an access control vulnerability, but it's a logical flaw because the referrer header can be controlled by the attacker. And if I now send this request, I basically get a 302 found, which is most likely an okay, and that solves the lab. So basically, by just merely having the correct referrer header in there, I can replay this request to upgrade myself with my own cookie. So I don't have an administrative cookie here. Okay, so all checks were done on the referrer header, and by simply having the right referrer header, I was able to bypass this access control. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the authentication vulnerability section, and today's lab is username enumeration via subtle different responses. So that simply means that brute forcing is permitted. So there's no rate limiting or brute force protection. And we have also been given a username list and a password list from Portsrigger. So in the real world, you would come up with your own likely usernames with your own likely passwords. There is lists on GitHub, which is tremendously helpful, but I always recommend to come up with your own username, with your own password list, based on the business, based on the geographic location and things like that. Okay, so let's get started. Basically, let's head over. There is a login functionality, and if I put in test and test, I get invalid username or password. So that's not really helpful, right? Like, so you remember in one of the apprentice labs, it was a lot easier because it told us it's invalid username or invalid password and stuff like that. So this time around, the developers are more smart, but there are still ways to actually enumerate valid usernames. So let's head over to Burp. Let's take a look at this request. This is the login request. So what I'm doing first is I'm sending this to Intruder. Intruder is like my brute forcing tool of choice. And so basically what I'm going to do is I fill in a very long password here, right? Like, and I will tell you in a bit why I'm doing this. And the username is the one I want to enumerate first. So I basically want to find out what is a valid account there. So I add my payload position here, and then you see this in the paragraph signs, and that basically means that I'm going to run my payloads against that field. Okay, so I go over to the payloads, and I will copy paste the lab usernames, which I can find here on the Portsrigger website. So I think it's around 100 or something. And I'm copying this over and I simply paste it in here. It's 101 different usernames. So what I also want to do is I can go over to settings and I want to do a grab match, basically, a grab extract, whereby I want to make visible like the error message, right? The error message, which is this one here, invalid username and password. And I want to show this in my output column. So I simply highlight this and hit OK. And then I'm going to start my attack. Okay, and now my attack is running. And you see here, like, this is the warning message. This is what I was going to extract. So it has invalid username or password dot, right? So if I sort this now, I will find one entry and only one entry which has not got the dot at the end. Can you see this? Like, all of these end with invalid username or password dot, versus this one did not. So why is this response different? Well, that's something I want to try to find out. So I presume this is a right username. So I send this to Intruder as well and open a new Intruder session here. But this time around, I want to brute force the password. So I'm setting my payload position to password. Okay, then I head over to payloads and I copy the second list, which is the lab passwords. And I grab this, I paste it in here, and it's 100 passwords, and I start my attack. So I'm starting my attack, and once I'm done, I sort by status column, because typically on a login, you get a redirect. You get redirected somewhere, right? And there was one, and the password was pass. So with the username AG and the password pass, I got a 302 redirect. Now let me take this and open this in the browser, show this in the browser and see what happened here. So let's come here. And I'm successfully logged in as username AG with the password pass. So I was able to successfully, first of all, enumerate the username and then brute force the password afterwards. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the authentication vulnerability section, and today's lab is username enumeration via response timing. So the developers, compared to the previous lab, have taken some more security precautions so that the previous bypasses do not work in this scenario, but it's still vulnerable to username enumeration, and I'm going to show you how to do this. So first and foremost, we go to our login portal and we enter test, enter, and then we enter test again. This is just to show you something else which is in place there. Test, test, and another test, test. And now I get an error message. Okay, you have made too many incorrect login attempts. Please wait for 30 minutes. So obviously not good. So this is brute force protection. So, but there are still ways to bypass this. So we know from the lab description, no, we don't. Or maybe here in the hint. Yeah, so basically, and in order to shorten this video, there is a special header which is being supported, which is called X forwarded for, right? X forwarded for is being is a header whereby you can abuse this to spoof your IP address. So what you would do in a real world scenario, you would come over and use like an extension called paraminer, and then the paraminer would basically, you would run the paraminer against the application, and it takes quite a while to run. This is why I'm not showing it, but it would show you in this scenario an X-forwarded-4, not URL. This is another lab, right? But with that in mind, you then know that there is a header supported, which you previously didn't know about. So let's send this login to intruder first and foremost. So we know that we are not getting anywhere. We are not getting anywhere if we just start brute forcing, because we can make 5 attempts or something and then we are blocked for 30 minutes. So this is not an option for us, right? Because I don't want to spend hours on this. So what I can do here is I can introduce a header called X forwarded for, and I put in like a random IP address, right? Like something like this, 1.1.1.1. Now I'm going to change the attack type to something called pitchfork, because in pitchfork, I can basically use different sets of payloads because I need more than one payload. So first of all, I need to reiterate through the username. So I hit add here, right? So I want to do, this is the same like we have done before, but I also need to reiterate through the X forwarded for IP address, right? So this is important because every request I make, so the first request will be done from the 1.1.1.1, and then it will be done from the 1.1.1.2, 1.1.1.3, and so on, right? And so this should break the brute force protection they have in place. So if I head over here, so my payload position number 1, my payload, well, let me first of all put a really long password. We need this because of the response timing. So if we find the correct username, it will take longer to respond if the password is set really long. Okay, so let's head over. So we now need to set 2 payloads, basically. So the first one is basically we are using numbers. And we're using numbers from 1 to, I don't know, 100, right? With a step of 1. So we have 100 payload positions. So that's for the IP address. And then we have a payload position 2. This is basically where we are going to use our username list. And the username list I have here, or I should have somewhere. This is lab usernames. Yes, lab usernames. So I copy this out and I use this as payload position number 2. Okay, and now I simply run the attack and see what happens. Run the attack, and now it's basically changing the IP address. So you can see this here. So the .2, .3, .4, .5. So with every password, it's using a different IP address in order to trick the application that the request is not coming from the same IP address. Okay, so this is step number 1. Now here in this intruder menu, you have something called columns, and then you can select response received and response completed, which I'm going to enable. And now I look at a response which is really out of the ordinary. You can see it was all like 300 milliseconds, 250 milliseconds, stuff like that. But then this response here, number 38, is really out of order, right? Like this is, and this is probably my right username. So I'm going to resend this over to intruder for another intruder session. And this time around, I want to brute force the password, right? So I say just test, and I will also change the IP address here so that we come from a new range, and we redo the same thing again. So we go through different IP addresses with each request, and we are going to brute force the password. So first of all, I need to find my password list, which is here. and I will copy the password list. Yeah, here we go. So that's my passwords. And what I'm going to do here is I go over to the payloads, right? And in the first set of payloads, which is for the IP address, I choose numbers again from 1 to 100 with a step of 1, okay? And I'm going over to my second payload position. Oh, sorry, I forgot something. I need to set the attack type to pitchfork, otherwise it doesn't work. So I need 2 payload positions. And number 1 is numbers, and number 2 is my password list. Okay, then once I'm done with this, I hit start the attack and I see what's happening. So you can see request number 1 was coming from that IP address, request number 2 was coming from that IP address, and always the password is changed. So I'm looking for a 302 now, which is a redirect, and it looks like request 100 gave me that. So username AE, password Moscow, and I open this in the browser, and if all goes well, I should be logged into the account when loading this. And I am. And this basically solves the lab. I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the authentication vulnerability section, and today's lab is broken brute force protection with an IP block. So basically the developers thought like, hey, we put brute force protection in place. So if you enter credentials a few times incorrectly, then you get blocked for a certain period of time. However, where the business logic flaw comes into play is if you log in with a correct username and password pair like my own, that basically resets that counter. And so this now gives you the opportunity to do a brute force attack, but every second request basically, or every first request needs to be correct credentials followed by a brute force attempt followed by correct credentials. And so you need to interleave into the flow basically, right? And the victim username is Carlos. Okay, and we also have credentials to our own account. So if we head over and we type in test, for example, we get an error message. And I'm simply heading over to Burp and send this to intruder to actually do the brute forcing, right? So here, let's send it to intruder. And we are going to use a pitchfork attack. So because I want 2 different payload positions. Number 1 is the username, even though we already know the username, but we need to interleave with my own credentials, right? So I will show you this in a second, how this works. So if we go to the payloads tab, the first payload position is the username. But what we need to do here is basically we need to have my own username and then Carlos, my own username and Carlos. So basically every second request will be a brute force attempt against Carlos, but every first request will be valid credentials in order to not trigger the brute force protection and the logout, right? So this is the first step. And then the second step is we basically go to the second payload tab, and we have been given a password list, and the password list is basically starts off with my own password, so it matches Wiener Peter, and then comes Carlos 1 2 3 4 5 6, and then comes Wiener Peter again, and then comes Carlos password, and so forth. So this is again to protect against the or to bypass the brute force protection. So also important here in the resource pool, we need to go over to the resource pool and just choose 1 concurrent request so that 1 is sent at a time. And then once we're done, we start the attack, and then you will see what's happening. So you see every second, like the first one gets a 302, so it means a successful login, then the third one gets a 302 successful login. And so it's double the amount of combinations, because out of these 200 we sent, 100 are my own credentials, right? In order to not trigger the brute force protection. And once this is done, so we are there at 140, 150 already, we will look for all the 302s. And there should be 1 302 basically, 1 successful login, which is not Wiener Peter. So let's take a look at this. So we sort them here by 302, and we see there's all these Wiener Peter ones. Let's scroll down where the 200s begin. And these are all Wiener Peters still. So somewhere in there there is a Carlos access 172. That's a 302. I take this, I show the response in the browser, and if all goes well, I should be logged in as the user Carlos here. And I am, and that solves the lab. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the authentication vulnerability section, and today's lab is username enumeration via account log. So goal here is to trigger distinct error responses which allow us user enumeration. And to do this, we have to repeat the username multiple times in order to trigger a different response. Okay, so you will see this in a second and it becomes all clear. So we have usernames and passwords which we have been given. Let's head over and log in with incorrect credentials like test and test, and it says invalid username or password. That's not a good message from an attacker's perspective because you don't know what is wrong. Is it just the username or is it the password or both in this scenario, right? So let's send this to intruder first. And what we want to do right now is we simply want to enumerate the username. What we're also going to do is we put another blank payload at the end of the password. And that's because we are using an attack type called cluster bomb, whereby we want to send the same combination multiple times. Okay, so we now head over to the payload section, and in payload set number 1, that's straightforward, we simply put in the usernames, right? Like the usernames we want to enumerate through. But in payload position 2, we are going to send something called nil payloads, and we generate 5 of them. So what that is going to do basically is simply sending the same username 5 times, or I could put 10 or whatever, right? But 5 times should be sufficient. So let's start off the attack, and then you will see this in just a bit, how this is going to look like. Once the attack is finished, we can sort by payloads, and then you will see that, for example, the payload Carlos has been sent multiple times, or Academico, Vagrant, like all of these Vagrant, user, test, everything has been sent 5 times. Now, let's take a look at the length column, and we see that there is something called AS400, and it has a different length. And that indicates to me, so if I look at the response, I get a different response code here. And the response code says, you have made too many incorrect login attempts. Please try again in 1 minute. So this is interesting because the other error messages all say invalid username or password. And this one is different. So I presume that this AS400 is probably the valid username. I'm sending this over to something called intruder again in order to run another session. So this time around, I'm only interested in the password, right? Like, because I already presume I know the username. I've enumerated the username successfully. So this time I want to try this with the password. And what I'm going to do is I also head over here to the resource pool. I only want to, I go to settings and I do like a grep extract, basically. So I wanna filter on that specific error message. So you have made too many incorrect login attempts, and I want to see if anything differs on that, right? And so once I'm done, I hit start the attack, and then I'm going to wait until this is done. It is done already. And if I sort by warning, I would say, hey, I get warning messages here. I get a warning message for invalid username and password. I get a warning message, you have made too many incorrect login attempts, but request number 94 didn't give me a warning message. So what happens if I load this in the browser? This might be the correct username and password pair. And let's just head over, show this in browser, and maybe I have to wait a bit. Let's just see. So let me send this to repeater. And let's render this. And let me take the credentials, maybe that's easier. AS400, 400, and login. And I'm logged in as AS400 in my lab. So I was able to successfully brute force the password, and I was able to successfully enumerate the usernames with distinct error messages. Hope that makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the authentication vulnerability section. And today we will be looking at a 2FA broken logic, a bypass for two-factor authentication. So as you probably have seen this in your own careers, there is a lot of 2FA being used these days. Password, username and password alone is no longer sufficient. So a lot of companies employ two-factor authentication. And in order to, first of all, to analyze how this works, we head over to our application and we simply log in here with our own credentials. So we enter Vina and we enter Peter, and then we get prompted for the 4-digit security code, which I have access to because I have access to my own email, and I'm going to receive this 4-digit security code, which is 1663. So I'm going to put this in 1663, and I'm logged in as Vina and Peter, right? So I log out, and then now I take a look at what actually happened here. So you see basically there's a get login to. The get login to is basically your entry screen effectively to the 2FA. But in order to load this, there is a verification parameter which is called Vina, and that's user controllable. So interesting functionality. I'm sending this over to Repeater first of all, and then there's also like a login to, right? And the login to basically is the actual MFA code, if that makes sense, right? So that's the actual MFA code as it's being submitted. You've seen this 1663. Okay, so what I can do is I can send this to Repeater as well. So the first thing I need to do is actually to generate the 2FA code for Carlos, right? So I'm changing, so that 2FA code is being generated. I'm changing this to Carlos, right? And now if I would render this, it's asking for the 4-digit security code for Carlos, but I don't have access to Carlos's email, but I have access to this post request here. And now I can actually change this to Carlos and send this to Intruder. I sent this over to Intruder because I'm trying to brute force that specific code now. So I'm interested in this value. I'm hitting add. I go over to payloads. What I want to brute force? Well, I know it's 4 digits, right? So numbers. And I want to brute force from 0000 to 9999 with a step of 1, right? So 10,000 combinations. The minimum number of integer digits is 4 because it's always a 4 code. Maximum is 4, and there is no fraction digits, right? So 0 and 0. So this will be the example how this is going to look like. So we do start the attack, and now we simply have to wait what's going to happen. So you see it's now trying to brute force. It's now trying to brute force all these different combinations. And what is the response here? We take a look at the response, and there should be an error message or something which is going to say like, hey, please enter the code, so incorrect security code here, right? You see that? So great. At the moment, we still haven't found anything, but you see we are only like in 1600, 1700 region at the moment. So let's sort here by status. So these 200s are obviously not good because they all indicate the error message, but we're looking for 302 or something, right? Like we are looking for this specific code. So this can take a while, right? Like because it's going through all the numbers all the way up to 10,000. But the key point here is there's no rate limiting, and there doesn't seem to be any protection. Like normally what you should do is also to make sure that the 2FA code is only valid, like for example, for a minute, right? So once it's generated, it's only, you have a minute to enter it. That's one protection, brute force protection, obviously, that I can't do what I'm doing right now. But let's see, right? Like, so at the moment, this is still all running, and I still haven't managed to get my 302. Let's just wait a bit more. until we found the correct pin code, right? So sometimes this is quick, this is funny, like this is like real world, right? Like sometimes this is really quick, and sometimes it takes ages because the number is in the higher region effectively, right? So you don't have any control over this. But you can always, like sort around by status code to see if there's any 302 popping up. It's still not. And so that's our post, that's the response, and yeah, it's going through all these combinations. This is actually something I found, I think 2 times in the wild with customers where this was possible. And this is devastating because if you then combine this with social engineering or something, and you're able to phish the username and password credentials, and even if they have 2FA enabled, you can still bypass it by doing a raw brute forcing attack like this one here. We still haven't found it. Takes a bit more, so we are almost 8,000 combinations now, and we should be having our status results soon, hopefully. I think I've seen something here. Yes, I've seen a 302. But what I don't want to do right now is I don't want to stop it, just in case I was wrong. But let's scroll down here. How we do this best while it's still running. Well, it's almost done, right? Like let's finish it for the sake of completion. We are at almost 10,000 combinations now, and once this is done, so right now this is done, and now let's check here for status, and we see this was the actual pin. And now what we're going to do, we load this in the browser, show response in browser, and what should happen now is we are being logged in as the username Carlos, and that solves the lab. So this was an example of how to brute force 2FA. Hope this makes sense, and see you in the next lab. Hey guys, this is Martin, and today's lab is brute forcing a state logged in cookie. So basically, sometimes websites have the option whereby it sets a cookie, so even if you close the browser, it will still keep you logged in. It's not secure, it's not recommended, but you have seen those, and like if you go to a shopping portal, you usually have these kind of options. And if the cookie is generated in an insecure manner, you may be able to brute force it and reconstruct a cookie which gives you access to someone else's account. So we have our own credentials, Vina Peter, which we are going to take a look at, how to log in, how this cookie is set and stuff. And then we also have a password list, right, of other users' passwords, and we have the victim username Carlos. So let's head over here first and let's log in. So you see that we have an option here which is called stay logged in. And I tick this and I hit the login button, and now I'm basically logged in. Let's head over to Burp Repeater, or well, let's first of all analyze this in Burp. So what happens here is you see that there's a stay login cookie is set, right? When you log in, the stay logged in cookie is being set, which is this one here. And what immediately comes apparent here is that this is constructed in a very weak manner. So if I go to my account here, and I do this again, right here, let me actually send this to Repeater. So if I highlight it, you see it's simply base 64, and then within the base 64 we have Vina and then something like a number here, like a number and alphanumeric kind of thing. And let's copy this out, and let's head over to a browser and basically go to Google and put this in. And this looks to me like an MD5 hash, right? So I'm going in here, so MD5 hashing, and it basically looks like this is an MD5 hash. So with that in mind, I will presume that this is the password in MD5 format. So we can verify that as well. We can go to Google, say MD5 generator or something, and then enter Peter, because we know our own password, right? And then the MD5 hash ends in 770. So if we go to Burp, yes, This is actually our password, Bina Peter, in MD5 format, basically, right? So, so with all that in mind, and I have been given a password list, I may be able to construct a cookie of another user. So I'm sending this to intruder first, right? And what I'm going to do is I delete the session cookie first, because I don't think I need it. Let's just verify this real quick. Let's resend this back to repeater and see if the session cookie is needed in order to call my own account. And it's not, right? So the stay logged in cookie is sufficient. So this is important to know. And let's go back to the intruder here. So we have this state login cookie. Now what we want to do is, let's delete the parameter here. We want to impersonate Carlos, right? So the first thing I'm going to do is I will go over to payloads, and then I will add something called payload processing. So first of all, what we know is there's an MD5 hash, right? And there is basically an MD5 hash, and I know that there's a prefix and that it's base 64 encoded. So let's start off MD5. So when we put the payload in here, right? The payload hash MD5. So I will explain this in a second again. So basically, when we take the payload, which is our plain text passwords, we want to first create a hash from that. And more specifically, an MD5 hash. So that's the payload processing, okay? So before we send it out, it will send an MD5. But we also need to add something called a prefix, because we have seen that my thing said Wiener like this, right? So we want Carlos, because we want to create a cookie for Carlos. So I do this. And then last but not least, I also need to base 64 encode this, because this is how we found it in the request. Something like this, right? And this looks good now. We just need to set the payload position here. This is the payload position. This is the cookie we are brute forcing. And all that's left to do now is we need to grab these passwords, which we have a candidate password list. Let's open this. And those are our actual payloads. Let's take them. Let's put them in here. So our payloads are first being MD5 hashed, then the prefix Carlos is being added, and then they are base 64 encoded. And then I simply hit start the attack, and then you can see what's happening here. Right, so what's happening here is basically all these get a 302, which is not good, because that's a redirect to the login portal, but there should be one number 18, which gets a 200. So let's take this request, look at the response, and render it. And then you can see we are logged in as Carlos. And let's show this in browser as well. Let's copy this over in the browser, and that basically should solve the lab, because we're now logged in as Carlos. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin here. We are in the authentication vulnerability section, and today's lab is offline password cracking. So basically, once again, we are dealing with an insecure cookie, but this time around, we are going to trick a user, or basically we are using cross-site scripting to extract the cookie or steal the cookie from the user, and then we are going to use Google in order to try to crack it, right? So first and foremost, let's get started. Let's log in with our own account to see where the vulnerability is. So once again, we have like a state logged in option, which we tick. Let's go in. We are in there. It's all good. If I take a look at the state logged in cookie, it's basically the same stuff like before, right? So it's very insecure. It has the prefix Wiener, and then it has the MD5 hash of the password. So it's a very insecure cookie. So what we're going to do now is we take a look at the page. So there's a blog, obviously, and then let's go to a few posts. And this is vulnerable to cross-site scripting, right? So test.test.com, test, blah, blah, blah. And I take like a basic cross-site scripting exploit, like one of the most basic ones possible. I simply need to exchange this for my exploit server, right? Like I'm going to exchange this for my exploit server URL, which I control. very basic one, nothing special, as we have done this over and over in the cross-site scripting section. And I put this in here, I store it. Sorry, I don't put this in here. I actually put this over here in the comment because I want the user to browse there, right? Like so, put this in the comment. I go to the exploit server. I look at my access log, and then in the access log, okay, I need to say something here. Store in the access log. I should see the request which has been made, which is here, right? So this is the request from the user. And let's take this, copy this out, put it into the decoder, URL decode it. And we see that there is something called secret stay logged in. This is the one I'm interested in, right? The stay logged in cookie of that specific user. So let's take this first and let's copy this out. And then we decode this base64. So it is Carlos. So it wasn't the administrator, it is Carlos. And so we know the username already now, but we also have that MD5 hash of his password. So we could brute force this again, or we can go to Google and simply put this in Google and see if Google finds anything. And yes, it found something on md5hashing.net. And let's take a look. So this is the hash, basically. So it's an MD5 hash. Does it give me any more information around this? Does it actually reveal the clear text password? Does it do this? Yes, it does. See that? So here we have the hash, and the password is once upon a time. Carlos's password is once upon a time. So if we go back here and we go to my account, we log out of our own account and we log in as Carlos. And we put in once upon a time, and we are logged in as Carlos, and we delete Carlos's account. Again, we have to confirm once upon a time, and that solves the lab. Okay, I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the authentication vulnerability section, and today's lab is password reset poisoning via middleware. So there is a flaw in the password reset process, and effectively it allows an attacker to reset someone else's account. Okay, so we will take a look on how to exploit this. We have credentials for our own account, but first of all, we will run through the password reset process, how this actually looks like. So I hit forgot password, I enter my username, and then what's happening is an email has been generated with the password reset link. So I go to the exploit server, I go to my email client, and you will see here is my reset email, my password reset email with a temporary token. Okay, I click on this, and then I simply check my new password. Okay, so this is the process, pretty straightforward. So let's analyze this, what happened actually. So if I look at this one, this is the post request. That post request has one interesting thing already, which is the username is down here in clear text. So I can basically put in username Carlos. If I would send this right now, Carlos gets a password reset email to his email account. This doesn't really solve the problem for me because I don't have access to his email, right? So I need to introduce something else. So there is a header called X forwarded host, basically, which is supported. And what happens if I put this X forwarded header to my exploit server, because I control the exploit server. So if everything goes well, I should be able to basically see the reset token from Carlos in my log files. So you might be asking, hey, how you find out that there is an X forwarded host? Well, simple. There is a tool in Burp, an extension, and it's called Paraminer, and you can use this to brute force host headers, and it, amongst other things, including parameters and all kinds of stuff. But this is the easiest way to find out whether the machine actually supports it. So let me send this right now and see what happens. So I get a 200 OK, which is promising, so I didn't get an error message. And let's go to the actual exploit server and look at the access log, what happened here. And you can see, hey, there was one request from this particular user, and which is Carlos, and this is his token. So what I can do now is I can head over, copy this token out, and then I go back to my email client, right? So back to the exploit server, back to my email client, which is up here, and I simply copy that URL out, which I received earlier. And all I have to do now is to change the token with the token from Carlos, which I have stolen, right? Something like this. And then I take the whole URL, put it in here, and set the password for Carlos to Carlos, right? Let's do that. Submit. Looks good. Let's go to my account, and now let's try to log in as Carlos, and that solves the lab. Okay, so I was able to successfully retrieve Carlos's password reset token and then reset his credentials and log into his account. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the authentication vulnerability section, and today's lab is password brute force via password change. So once again, there is a logical flaw in the password change functionality, and this time it's a different one than we had before. So first of all, we will analyze the password change functionality with our own credentials, and then the goal is basically to change the password of the user Carlos, or more specifically, brute force the password of that user and log in as Carlos. So let's head over to the lab, and first things first, let's log into our account and analyze the functionality, like what's actually going on. And you can see here, this is interesting. So one thing which immediately stands out is there is a hidden field with the username. So this might be user controllable. So let's just change, or let's just make a test. We enter the current password, which is Peter, and we enter two different passwords for the new password, 123 and 456. And then we say change password. And now I get a warning message, the new passwords do not match. Okay, so if I put in a wrong password for Wiener, like 123, and then I put in 456 and 456 as the new passwords, so let's see what happens, is I get logged out. Okay, so coming back here, and I hope we're still logged in. No, we're not. We got logged out. Okay, so now we basically, now we have to wait for a minute, but we analyze the functionality, how the functionality actually looks like. So let's go over here to the post requests. So we had our first post, which was that one here. So that what we did here is basically we used our username. We had the correct current password, and we put incorrect new passwords. And that's basically the key to success here. Because if I basically, so I have to redo this again, so I have to re-log in. Hopefully it works now. And no, still not. I still have to wait a minute. But basically, you remember this is user controllable. The username is user controllable, so I can exchange this for Carlos. But the current password of Carlos, I don't know. So I will need to brute force this. But as long as I specify two incorrect new passwords, I'm simply getting an error message, right? I'm simply getting an error message, and the error message was, if I look back here, the error message basically was, let me just render this real quick, what it said. The new passwords do not match, but it didn't log me out, okay? Versus if I enter the incorrect password, like I've done here, it was basically logging me out completely. So I got a 302 redirect and I got logged out. But what I now need to do is I need to re-log back in, and I need to redo the whole thing again. So I need to be careful that I put my, or any password. I can put any password, test 123, and then new password 123, and the confirmation 456. That should also do the trick. And that now says current password is not correct. So this is exactly the error I wanted to trigger, because what I can do now is I send this over to repeater. Actually, let me send it to intruder. And then in intruder, I clear all the payload positions. And I don't know the current password. First of all, I want to brute force Carlos. That's number one. And secondly, the current password, I don't know. So I want to brute force this. And the new passwords do not match. Right? So that's the key to the whole success story here. So let's go over to payloads and let's copy the passwords, the password list we have been given. Let's paste that in here and let's launch the attack and see what happens. All right, so this all went through fine, but what I forgot is to actually one important thing, which I need to go to the settings, and then I need to do a grep extract, because I want to extract, I want to make sure that I basically get the correct response. So let's redo this again. So let me come in here and say add fetch the response. Okay, so I need to grab on the error message basically. And the error message was like current password is not correct. Okay, so, and then I rerun the attack, and now I get this, here's the current password is not correct. So for the correct password, I should get another error message. And that's payload number 36, and the payload is Jennifer. So the password is Jennifer because the new passwords do not match. So I get like new passwords do not match. Okay, so now I come back over here and I log out of my account, log out, and then I will log back in, but this time with the username Carlos and the password Jennifer. And that should solve the lab for me. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin here, and we are in the WebSockets lab section. Today's lab, manipulating the WebSocket handshake to exploit vulnerabilities. So you might recall from a previous lab in the apprentice section or around WebSockets that we were able to simply put in a basic cross-site scripting payload, and then it fired in both my browser and the browser of the customer agent in the chat functionality. So this time they have put in a cross-site scripting filter, and which is supposed to block our login or our cross-site scripting attempt. So let's just start off with test, and nothing spectacular happened here. So, but if I now say image source equals X, and then on error basically equals, say, alert 1 or alert 0, whatever, right? So normal cross-site scripting payload, I hit send, and then you see immediately the chat has ended. So something happened there. So again, when it comes to WebSockets, you don't see these kind of things in the browser HTTP history. You have to go to the WebSocket history. And then you see this was our chat, so we are connected. I sent my test message first, then that was basically sent over, then there was typing, and then the customer support agent came back to me, and then I was sending a cross-site scripting payload, and then attack detected event handler. So there was an attack detected. So let's first of all send this over to repeater. And maybe if I, like in the previous lab, if I try something like this again, maybe this works on error. And then let me remove the encoded characters and then see if this does any good. Right, something like this. Okay, that should work. Let's send it, or let's reconnect first. So this is our connection. We reconnect, and in the response, we say address is blacklisted. So not good, right? So after figuring out, so you can use tools, for example, like the Paraminer tool, where you can find if there's any additional headers being supported, and you would find out by running the Paraminer tool. Not going through this right now because we have done it in many labs before, but I can put in X4 forwarded 4, and then I put a new IP address, and then I try to reconnect and see if this works, right? So reconnect, And that looks good. So now I'm at least connected again. If I would now fire this payload, I will get an error again because it will detect this as a cross-site scripting vulnerability. But what I can do now is, now that I know that the X forwarded for allows me to launch more attacks, I can try to bypass the filter. Like I write, like say something like this, on error, like something like this. So I mix uppercase and lowercase and equals alert, and maybe I put the one into backticks, something like this, right? So just to try to fool the filter and then see what the result is. So if I send this over, this looks like good, it was taken. And if I go over to the chat, this solves my lab. So basically, there were 2 steps to bypass this filter. Number 1, you need to be aware of the fact that your IP address gets blocked. And then you can use the X forwarded for in order to change the IP address to another one. And then also you need to play with the XSS payload and try different combinations. So it looks like they were just filtering on the lowercase event handler on error. But if I mix it with uppercase stuff and things like that, then it goes through fine. Okay, so this is another example of exploiting WebSockets, and I see you in the next lab. Hey guys, this is Martin, and we are in the WebSocket section, and today's lab is cross-site WebSocket hijacking. So there is an online shop which has a chat feature using WebSockets as in the previous labs, and to solve the lab we are going to create a JavaScript, HTML JavaScript payload that uses a cross-site WebSocket hijacking attack, basically to exfiltrate the victim's chat history, and which should contain some juicy information like the password and then access the account of the victim. Okay, so first things first, let's go over to the application. We can play with the chat functionality, hit send, and can say hello. And then we go over to Burp and take a look at this in the WebSocket history, what happened. So you see always like the first command which has been sent was the ready command, right? And ready command basically retrieves the past chat, right? Like, but there is nothing to retrieve here because I just initiated the section, right? Or the session. So we need to start out with the ready command, and then basically we are going to create a URL or a JavaScript payload whereby we host this on the exploit server. What's going to happen there is we are calling the WebSocket URL. So the WebSocket URL, basically you can see this here in the HTTP history. So this one here, right, is the /chat is basically our WebSocket URL. So for that purpose, I've created a little script. So this is a JavaScript, plain and simple. So first thing we need to do is we need to update here the WebSocket URL, which is basically this one here of this current lab. You see it's not HTTP, it's WSS, which is basically WebSockets protocol, and then /chat, this is the URL. This is the same URL we've been using here, as you can see in the browser, right? And then we are starting with the WebSockets, basically, then there will be a handle reply function, right? So the handle reply is because we obviously want to exfiltrate information. So there's also a start function where the ready command is being sent, and then a function handle reply is basically being called. And what's happening here is we are calling the Burp collaborator server. So let me take go to the collaborator, copy that to clipboard, and insert the Burp collaborator. And we are basically going to log the event data, right? And this is all that does. So this is very similar to the previous labs, what we have done with exfiltration and things like that by creating out-of-band interaction. So let's copy this and let's put it into our exploit server. So let's head over here. Let's go to our exploit server. Let's save it, store it, and then we deliver it to the victim. Victim gets a link, comes to that page, code is being executed. And what should then happen is that the Burp collaborator gets interactions. So let's see if it did, and it did indeed. So first of all, the 2 DNS interactions, but now the more important ones basically are the ones which show the chat history. So you can see this here, right? Like you're now connected, and hello, how can I help you today? That kind of thing. And then I forgot my password. So if you can't read any of this, right, like it doesn't really matter, because you can always grab it and put it into decoder, right? So it makes it more readable, and not into decoder. So it makes it more readable if you URL decode it. So then you get this in a nice format, right? Like if you have problems reading it. But basically what I already see, it's about Carlos, right? And let's take this message again and decode it. Let's head over to the decoder. And it says like, no problem, Carlos. So it was the username Carlos, and so that is like the tick URL encoded, and that should be the password, right? And let's head over to our page, go to my account, and log in as Carlos with that exfiltrated password, and that solves the lab. So this is an example of a cross-site WebSocket hijacking attack. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the web cache poisoning section, and today's lab is web cache poisoning with an unkeyed header. So in a nutshell, what is web cache poisoning? It's basically that you, as an attacker, you can poison the cache, and the cache of the application will then be served to other users. So you can trigger responses which are not supposed to be triggered. And for example, in this lab, we have like an unkeyed header. So there is a header, which is basically, which I can inject into the application, and then the application will serve or will act on based on that information, and will then basically serve a poisoned cache to other users. That's the principle behind it, but please read up on this if you're not familiar with it. So let's head over to our application first. And one thing I want to show you right away is like web cache poisoning doesn't always happen. Like web cache poisoning is only when there's a caching engine somewhere. And this is increasingly popular to serve the right content to the right users and to limit amounts of backend interactions and things like that. Like when users are requesting the same resource over and over and over again, it's better to serve like a cached version. And one trigger here is like if you see the control cache, cache control, age, X cache, that kind of thing, that typically indicates that there's some caching in place. So next thing I see here, it's loading something called a tracking.js file, which is interesting because it's a JavaScript file. Now, if I could host something on my hosting server which says resources.js, tracking.js, and this is being loaded instead of the real content, then that is game on for me, and that's basically I can serve a malicious payload to other users. So those are the first two considerations. Let me send this over to Repeater now. And also I would like to highlight another tool which I mentioned numerous times already. So when you have web cache poisoning or something like this, you need like you always want to check for headers. Like, are there any headers which you may be able to use? So there's a nice little tool where you can then like right click here. It's an extension. It's called Paraminder. You can guess the parameters and you can guess the headers here, right? I'm not doing this right now because I've already done it. And it told me that there is an X forwarded host header which is being supported. So this is great. So first and foremost, let's start crafting our exploit. So let's copy this URL, right? Because I want to serve something out of the tracking.js. And I go to my exploit server, and then I simply create an exploit, which is called resources.js, tracking.js. And as a payload, I simply put an alert document.cookie or something like this, right? Something like that. Okay, so this is my exploit server. Here's my exploit server URL, and so on and so on, right? So now what I'm going to do is I start playing with the actual cache on the main page. So let me get the HTTP history. Let me send this here over. So you can also use something called a cache buster. So I will show you what this means. So basically you set like A equals 1 or anything you want to choose. And then if you send this twice, you see the cache is hit. So now the responses will be cached for, I think, 35 seconds in our scenario. But if you want to make changes and if you're pen testing, then you may want to change that cache buster to something else, like B equals 1 or something. And then it starts from the scratch again, right? So you have a cache miss. And then if you send it again, you have a cache hit. Right, so this is important to realize to speed things up. Otherwise, you always have to wait the full period until the cache has timed out. So we know there is an X forwarded host. So let's introduce the X-forwarded host, and let's simply set this to example.com for now. Right, I change another cache buster values to test this real quick. And I do this, I send it again, the cache has been hit, and now I can see something interesting. I can see that the JavaScript is being loaded from example.com. And for the next 35 seconds, this will be served to the users, and this is the exact path. So I already prepared that on the exploit server as you've seen it. So what happens now if I exchange the X forwarded host with the URL of my exploit server? So let me take my exploit server here. And that's the URL of my exploit server. I need to delete the slash at the end, something like this. And I change it to another cache buster. And what's going to happen is that now you can see my exploit server in there. So if I load this response in the browser, which I'm doing now, so I'm going to load this up in the browser, I get a cross-site scripting attack. Fantastic. So this is half the rent already. But the lab is not solved yet. Why is the lab not solved? Well, because I used a cache buster. So I have to replay this attack one more time for the main page. And now I'm poisoning the main page. And now, if you actually browse to the main page, show response in browser, it should fire right away. And here's our cross-site scripting attack on the main domain. Okay, and that solves the lab. I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the web cache poisoning section, and today's lab is web cache poisoning with an unkeyed cookie. So in the previous lab, we used an unkeyed header, but cookie is basically the same principle. This time we are modifying a cookie and then send it up to the server and hope to be able to modify that cookie so an incorrect response is being triggered for other users. So we are cache poisoning basically for other users. Okay, so let's get started. Let's head over to our application, load the home page, and then see what's happening. So we are loading the home page, and you will see that it sets a cookie, right? It sets a cookie called FE host broadcache 01. So if we refresh the home page again, I should be able here to see the cookie, the FE host broadcache 001. So I'm sending this to repeater first and foremost, send it again. And then I can see that it is already cached right now, right? Because the age is 25 and the cache has already been hit. So you see it's reflected here in a script attribute. So this is interesting to me because, hey, what if I can start modifying this broadcache 01? And don't call it broadcache 01, but for example, I call it Martin, right? So let's call it Martin. And then let's see how this reflects. And before doing this, I add a cache buster once again, so I don't have to wait the full 35 seconds each time. So I see, wow, cool. I can control that parameter. But that's only half of the rent, right? Like, because I need to break out of this. I need to break out of the double quotes here. So I put a double quotes and I hope it's not encoded. And then I say hello as my second word. I change the cache buster to B equals 1. And I see what happens. And you can see, hey, fantastic. I was able to break out of this. Wow, this is pretty cool. So what happens if I say instead of hello, I put like an alert, 1, something like this. And then I terminate this with a double quote. So let's try this. But let me change the cache buster again. See what's happening. And that looks good now. Now I have like an alert statement within the script tag. So maybe this fires an XSS, or let's show the response in browser. See what's happening here and reload this. And indeed, I'm able to successfully poison the cache and trigger a cross-site scripting payload. So all I have to do now is I have to remove the cache buster and send it again for the main page, for the home page. And the cache has been hit now, so it's poisoned now. Show response in browser. Let's head over. Let's put it into the browser, and we get our cross-site scripting fired. And this basically solves the lab with cache poisoning with an unkeyed cookie. Hope that makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the web cache poisoning section. In today's lab, we are going to take a look at web cache poisoning with multiple headers. So if you recall from one of the previous labs, we were able to successfully web cache poison our cache by simply hosting an external JavaScript on our exploit server, and then we use the header x-forwarded host to actually get there, right? This would not work in this particular lab because in order to successfully poison the cache, you need two different headers. And we go over to our application, and what you see immediately is basically that there is a resources.js tracking JS is being loaded, right? So the same as in the first lab. And basically, I will go to my exploit server and prepare that, which I have done already. So I have created the path resources.js tracking.js and put simply cross-site scripting alert in there, nothing else, right? So this is the preparation work. And now we basically take this and send it over to Repeater to play with it, right? So first things first, I will add a cache buster that we don't have to wait for 35 seconds or something for after each attempt we made. And in here, I will basically put in the x-forwarded host, x-forwarded host. This is exactly identical to what we have done in the first lab. And you will ask again, like, hey, Martin, how you found those and stuff. Well, there's an extension called Paraminer, and the extension has told me that there is two different headers which are hidden, but which I probably can use. And the other one is called x-forwarded scheme. And the x-forwarded scheme we set to HTTP. Why? Because it's always my first guess. HTTP, normal behavior is HTTPS, so I may be able to inflict a web cache poisoning if I change the protocol to HTTP or something. Okay, let's do that. Let's hit fire. Let's send it. And you see we get a 302 redirect, which if we would follow through, it goes to our exploit server, to the tracking JS, but it has the parameter attached. Okay, we don't want the parameter attached, so we redo the same attack here on the main file. We send this, and unfortunately the cache here is still poisoned, so we need to wait a bit longer until it is timed out, basically, and then we can re-poison it with that specific payload, and then we will see what happens if we load the home page. And if all goes well, we basically should be able to inflict a cross-site scripting attack against other users through web cache poisoning. So let's do this. So now you can see we are going to that redirect URL, and I do it again, and this looks good. And if I now come back to the website and I refresh the website, what should happen now is I should get my cross-site scripting payload, and I do. And that proves that the lab has been solved successfully. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the web cache poisoning section. And today's lab is targeted web cache poisoning using an unknown header. Okay, so it's similar to the previous labs we have already completed, but once again, the header is not known to us. So we first of all need to find the header out, right? So if we load the main page and we go over to Burp, and we see a couple of things here. So this is our main page, which is being loaded. We have our cache controls over here. Let's send this to Repeater first and foremost. And then let's also take a look here, we see that there is a resources JS, tracking JS is being called. So first thing I'm going to do is I prepare my exploit server once again, because I want to introduce my exploit server to the web cache, and then it's being served instead of the regular application JavaScript. And this is nothing new. We have done this in the previous lab. So I just say alert document cookie as my payload here again, and then I simply save it, right? So that's the first part. Second part then is, well, I need to find out which headers are being supported. So I would use something called paraminer. I go to the main side request, extension, paraminer, guest parameters, guest headers, right? I have already done this because it takes a bit, but I can see here that, for example, the X host is being supported. Okay, so let's use the X host, and we say here x-host, and then we put in the URL of our exploit server, right? So, which is basically this one. And we take this, we move over, and we also add a cache buster once again to not have to wait for the full 35 seconds after every iteration. And I'm going to send this over, right? And I do this twice, and now I have the cache hit, so the cache is effectively poisoned, and you can already see that it worked, that actually the JavaScript here is now being pointed towards my exploit server with my malicious payload. So let's open this in browser. Let's show the response in browser here and see if we were able to actually initiate a cross-site scripting attack, and yes, it was possible. That's perfectly fine. Now, one thing to keep in mind is sometimes it is very browser dependent, like when it comes to caching and when it comes to cross-site scripting attacks and things like that. So certain payloads work for some browsers, certain payloads do not work for other browsers. So one way to make sure that this is actually firing for the victim is you can come here and it says HTML allowed. So what I could do here is, if I'm merely interested, at this point in time, I'm just interested to find out the victim, how you say, the victim browser, the browser the victim is using. So if you go to Burp, this is basically our user agent. So I'm interested in the user agent, and what I can do is I can put like a simple payload in there, like image source, and then I load basically anything on my exploit server. And this is non-existent, right? Like this path is non-existent, but if the user browses there, so if we come back here, and if the user actually browses, let's just open one of those posts and put this in here as HTML. And if the user browses there, then I should be able to see in my log file that specific user agent, right? So let's do this, and let's head over to the exploit server. Let's go to the access log. And if we scroll all the way down, then we see here, like, here we had all the 404s, and this is all from the victim. And the user agent is Mozilla 5 victim. And this is probably why it's going to work at the moment, why my exploit worked on my own browser. So it looks like that the victim is using the same browser. It's also using Firefox. But in order to test this, what I'm going to do is I replace my own user agent here with the victim user agent, right? I do it like this. I just change the agent and I remove the cache buster. Then I send this, I send it again. I see here that the exploit server is mentioned in the response. So my poisoning was successful. And now I show the response in the browser, and I do this here, and I get my cross-site scripting payload fired, right? And that solves the lab for us. So I hope this makes sense, and I see you in the next one. Hey guys, this is Martin, and we are in the web cache poisoning section, and today's lab is web cache poisoning via an unkeyed query string. So we have done a couple of labs already on web cache poisoning. We used cookies, we used headers to initiate a web cache poisoning, and that also may work with an unkeyed query string. So effectively what you're going to do is you put like an unkeyed query string in there, and then if successful, you can poison the web cache, and then that's being served to other users. So let's take a look at the application. We go over to the application, we look at it in Burp, and we see like there's not much happening here. This is our main request, right? So let's take that request, send it over to repeater, and simply like let's just put in any parameter, like say evil equals Martin, and then we send this over. And you see that the cache is already hit, right? So it hasn't taken it yet. So we have to continuously poison that now. So one thing to remember is you cannot use a cache buster in that specific scenario, because my unkeyed query string is already the cache buster. And so you could probably use an origin header or something like this, but it doesn't matter. But you see what happened here? So I can actually reflect my payload in here. So what I'm trying now is basically, instead of putting Martin in, I'm trying to break out of this portion first, so that I'm free. So I'm getting out of this href tag effectively. So I do this, right? And then I try to introduce like a normal cross-site scripting payload, like just something simple like this, basically, right? And then fire that over and see what happens. And so we have to do this here and here again. And now we see, hey, I was able to get my cross-site scripting in here. So I terminated the href here, and I terminated the link attribute, and now I have my cross-site scripting vulnerability. And I do the show response in browser. I head over here, and I look at this, and I have my cross-site scripting executed. Okay, so this is an example of using an unkeyed query string to initiate web cache poisoning in combination with cross-site scripting. Hope that makes sense, and I'll see you in the next video. Hey guys, this is Martin, and we are in the web cache poisoning section. Today's lab is web cache poisoning via an unkeyed query parameter. Okay, so multiple ways to achieve web cache poisoning, but let's head over to the website first. The first thing I recommend to do is run the paraminer tool, basically, and this time you would not look for specific headers. You would look for query parameters, like the get query parameters options, as you can see here, extensions, paraminer, guest parameters, get parameters. I'm not doing this because it takes quite a long time, but once the scan is finished, it basically gives you something called UTM content. So there's a parameter called UTM content, and if I put this in and then send it to Martin, let's see what happens, right? So I can now see, hey, great, Martin has been reflected in the UTM content parameter, right, as a value. And now I can basically try the same thing as before. So I try to break out of this particular link attribute, right? And I do it like this. Well, let me delete Martin first. I do it like this. And now I try to actually put in a basic cross-site scripting payload. And then I will attempt to re-poison the cache and see what happens. So this worked fine. And you can see that my payload has been introduced here. Okay, so this worked. There was no encoding, no sanitization. If I call this response in browser, I should get my cross-site scripting through web cache poisoning. And there we go. Okay, so that's another example. I hope this makes sense, and I see you in the next lab. Hey guys, welcome to another web cache poisoning lab. And today's lab, we talk about parameter cloaking. So there's a web cache poison vulnerability once again, and because certain parameters are excluded from the cache key. So basically you can use them to effectively poison the cache and then display this to other users. And there's inconsistency in the parsing in that respect, and we will take a look how to exploit this. So if I load the main website, you will get something called an interesting function called a get function to JS geolocate.js with a callback to a set country cookie. So let's analyze this first and foremost. By the way, the first exercise I've done, and I'm not repeating this again, is I looked for other query parameters. So basically I ran the tool extension parameter guess parameters, guess get parameters, and I found out that the UTM content once again is in existence. So I put in UTM content equals Martin, and then I sent this over, and I'm poisoning the cache basically. I have to wait a bit because yeah, now it's actually working. So as you can see, there's no Martin reflected, so that's not good. So they did something right this time. So the UTM content cannot be used to initiate cache poisoning. However, me as a security researcher, I'm thinking, hey, what happens if the callback attribute is obviously shown right here? If I change that set country cookie, it breaks the function, it doesn't work. But what happens if I put a semicolon and then I put the callback function once again and I say callback function Martin? Okay, or no, let's call it hello. Okay, and then let's send it over. And you can see, hey, it's reflected here. It's basically reflected back to me. And that means I'm able to successfully poison the cache. And instead of hello, I would now say, hey, how about I'm going to trigger an alert function, right? Like an alert 0. And that should basically, in that application JavaScript response, that should basically poison the cache. So let's try this. And we have to wait a bit because the cache is still hit at that point. So let's see. And here we go. We basically have our alert function. So if I now go back to my browser and I reload the page, what should happen is the XSS fires because the JavaScript is being loaded, the poisoned JavaScript effectively, and this is being returned in application JavaScript. So this is another way to basically cache poison your application. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and today we are going to take a look at another web cache poisoning vulnerability. This time it's web cache poisoning via a fed GET request. So in short, what is a fed GET request? Normally a GET request cannot have body parameters. Okay, but in a fed GET request, the application accepts additional parameters in the body, because normally that's when you have a post request, right? Let's head over to our application. Let's take a look. I see there is an interesting function being loaded called jsgeolocate.js, and then there is a callback function, basically. So what I'm going to do, first of all, I try if I can actually put another callback function here. Like I say callback equals Martin. And normally this is not allowed because it's a GET request, right? But let's see what happens. So I do this. I need to wait until my cache timed out. So it should be momentarily 35 seconds later. And then we see something interesting, that Martin actually has been reflected. So we have successfully poisoned the cache with the keyword Martin, right? So all which is left to do now to create more impact is to put an alert 0 function in here. So to trigger a cross-site scripting for all the other users. And we have to wait a bit. It's another 15 seconds basically until the cache times out. And if all goes well, if there is no sanitization or encoding in place, I should be able to successfully poison the cache, and then other users get to cross-site scripting vulnerability. So here you can see this. This was successful. What we do next is we refresh the page, the JavaScript is loaded again, and the cross-site scripting functionality is fired for visiting users. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the web cache poisoning section, and this time we are taking a look at URL normalization and how to exploit this vulnerability to trigger XSS for the clients via web cache poisoning. So let's head over to our vulnerable application and we look at the GET request. We sent the GET request over to repeater, and the first thing I'm going to try is, like, I'm just trying a path which doesn't exist, like with my name. And interestingly enough, I get basically, if I send this twice, I even get a cache hit. So that means this is cacheable. So this is the URL normalization vulnerability. It's cacheable. But in order to get cross-site scripting going, what I need to do is I basically need to break out of this paragraph tag first, right? So I say Martin, and then I break out of the paragraph tag, and then I try to introduce my script payload, like a normal JavaScript alert 0 payload, and see what happens. And basically I hit the cache and my payload is being shown. So this was a successful attack. I show the response in browser and come over here, and that's basically the solution to the lab. But I think there's one thing missing, which is I need to take this and need to deliver it to the victim. So let's come here, deliver the link to the victim. So that should be the link, URL encoded, and it does not work. And I don't know why that's the case. It worked last time, but basically it's you may have to do this a couple of times. I can say copy URL as well. So, and then I can reload this here once more, but it's the same thing. And yeah, it does not fire it. Actually, when I copy the URL, this is funny enough, when I copy the URL, it basically does encode it, and then it doesn't fire for some reason. But if I if I send it in Burp, right, like this, it works. And if I show it in the browser, it also works. And normally I would just copy that specific URL here, and then let me just initiate this from another window again, something like this. But no, then it doesn't work. Actually, let me try something real quick. Let's see if I do not URL encode it and just put it in like this. It should work, you know. And let's come back here. Let's go in. And let's see, I have 2 double slashes here. Let's see if this fires on its own first, which also doesn't anymore. I don't know. This is strange, because if I launch it from here directly, let's recache, let's repoison, and we need to wait a bit again, because now we have the wrong poison in there. The wrong web cache poisoning. So let's just wait a second, and then let's redo it one more time, and then see if this works. If I put this into the browser or send it as a link. So let's see. It has to be sent obviously when it's active, because only then the victim will be poisoned. So let's try this again one more time. And if it doesn't work, then yeah, no, it doesn't work. But you've seen the result here. So if I show the response in browser, you clearly can see that we are getting our XSS executed, and that solves the lab basically. Okay, I hope that makes sense, and I'll see you in the next one. Hey guys, this is Martin, and in today's lab we are looking at modifying serialized data types. So we are in the insecurity serialization section, and so the lab uses a serialization-based session mechanism which is vulnerable to authentication bypass. So our goal here is to basically change the session cookie to access the administrator account and then delete the user Carlos. For that purpose, we have been given a Vina and a Peter credential to log in and to generate the session cookie first for ourselves. Let's get started. Let's go to my account. Let's log in here and see what happens. So we are logged in apparently, and we go to my account. And if I go over to Burp, and if I look at this request, I send this over to Repeater to be able to play with it. And if I try to access the admin account, then I get an unauthorized. So if I render this, it will tell me admin interface only available to administrators. Okay, so I can't do this. But what I see here is the cookie. So there's some base64, some URL encoding in there by the looks of it. So if I highlight this, I see basically it's URL decoding it first, then it's the base64 blob in here. So I can make this a little bit bigger so you can see this more. So this is how the serialized object looks like. So there is a user object, which is 4 characters long. 1, 2, 3, 4. There is a username object, which is 8 characters long. There's a Wiener object, which is an S. So the S stands for string. And it's also written in double quotes, as you can see this here, right? So what I want to do now is, first of all, I want to change this to administrator. And instead of Wiener, administrator. Okay, so but now administrator is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 characters long. So I need to update the string length to 13. So that's the first thing. And then there is a problem that there is an access token, right? And the access token is the access token for Peter, which I do not really have, right? So I wonder what happens if I just remove that access token value. And let me just remove this out here, right? Like something like this. I remove it out, and then I might be able to trick the application by saying instead of access token S32, I might be able to say integer. So I stands for integer 0. So I'm basically instructing the serialized object that there is no access token, right? So I might be able to bypass this, because if I would try it with the access token, it wouldn't work. Reason for that is that the access token is issued for Wiener and not for administrator, right? So this looks good, and this is really a neat feature here with the inspector in Burp, because you can do it on the fly. Otherwise, you could modify this object yourself, but then you have to send it through the decoder and get the decoding right and stuff like that. So let's hit apply changes, and now you see that our session cookie obviously has changed. Let's resend this to admin, and all of a sudden we get a 200, and we have successfully reached the admin panel. And all that's left to do now is we need to delete the user Carlos. So I'm taking out here the instruction from the source code. Like, what do I need to do? Well, I need to go to the delete endpoint, admin delete, and then I need to append the actual username I want to delete, which looks like this. So let me hit send. I get a 302 that looks good, and just to confirm it, I will call the admin panel again, and Carlos should have been deleted by now. And it has, and there's just Wiener left. Okay, so that's an example of a deserialization attack whereby you modify serialized data types. I hope this makes sense, and I'll see you in the next lab. Hey guys, this is Martin. We are in the insecure deserialization section, and today's lab is using application functionality to exploit insecure deserialization. So the lab has once again a serialization-based session mechanism, and a certain feature invokes a dangerous method on data provided in the serialized object. So this is typically like, for example, a delete or something where you can change things around, right? So our goal is to delete a text file from another user, right, through that functionality. And for that purpose, we have been given 2 accounts. One is Wiener Peter and the other one is Greg Rose. But that is because we may have to run through the process ourselves first with one account, and that may delete that specific account. And then we have a backup account basically to replay this in order to achieve what we need to achieve. So let's head over and let's log in first and analyze what's going on in the background. So let's log in with Wiener and Peter. And something interesting you notice here is there is something called a delete account functionality, right? So if I log in, you can see there's my serialized object, basically. So let's analyze this first. It's a user, and basically there is a username, and which is Wiener, and there's an access token from that specific user. But more importantly, there is like this S11, right? Like this is, and then avatar link. So there is an avatar link, which is probably a file, or well, it's a path to my avatar, I would say, right? And that sits in user Wiener avatar, basically. So that's interesting. So I believe what's happening is that when you hit the delete button, this is being invoked as well. right? So this is being invoked. That it effectively means that it's deleting that avatar when the user account is deleted. But let's find out. Let's actually do this in our Vina account. So we simply hit delete account, and now we are logged out, and our account is deleted. So this is the post we've just made. This is the post we've just made. Let's send it over to Repeater. And that's basically the delete account, right? And I still have another account, which is called Greg Rosebud, right? And so let's take a look at this here. Let's take a look. And what happened is, as I suspected, the serialized object was passed along. So when you hit the delete account, it's basically deleting the avatar link, which is located at this path, right? So what I'm going to do now is I'm opening another browser window. So I put this in yellow, simply for the reason that I see which account is which. So this is the virtualization software called PawnFox. It's quite useful. And I go in here and I use the Greg Rosebud. So this is another account, right? And I'm not hitting delete because otherwise the lab is over for me. At least I'm not hitting delete yet, right? So let me head over here, and I'm going to simply take that session cookie out, which is the serialized object, right? And I put it into my Repeater window here on the delete request. So right, so far nothing done really. But what I want to do now is basically what happens if I'm going to start messing with this functionality. So S11 is the avatar link that remains the same, right? Because that's what it's called. So I leave this as is, but maybe I want to not delete user Greg avatar. Maybe I want to delete, say, something like home Carlos Moral dot text. So this is the lab exercise told me to delete this object instead of deleting the avatar. But I also need to count here the numbers, the characters, and that's 23. So I need to change that to 23. So that always has to match, right? Like when you change the username, for example, the string here is 23 characters, and that needs to reflect that. And I hit apply changes. And if I send this now, what should happen in my theory is that the account gets deleted, but also that specific text file, Carlos Morali, home Carlos Morali.txt. So let's hit send. I get a 302, and if I go over to my lab, the lab has now been solved. So I have successfully deleted a file of another user through insecurity deserialization. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the insecurity deserialization section, and today's lab is arbitrary object injection in PHP. So once again, we have a session-based, serialization-based session management mechanism, and it's vulnerable to arbitrary object injection as a result. For that to work, you basically need to analyze some source code, which may be publicly exposed, but you need this, like to find this blind is pretty difficult, but if this is leaking somewhere, or the source code, the PHP source code is leaking somewhere, then this is something you can achieve. For that reason, we are going to log in with our username, Vina, and password Peter. And if we have done this and refresh this, we take this request and simply send it over to our repeater, and then we can launch this again here, and then let's take a look at the serialized object. So basically there's a username, Vina, access token, once again, so we have seen this before, right? So nothing special here. If I would start modifying around here, this would not work in this case. So this is not modifiable. But something else I can do is I can basically go to my target sitemap and start looking around. Like there's images, there's libs, and there's like, oh, interesting, there's a custom template. So let's send this to repeater and let's fire this over and we get a 200. So one trick you can do with PHP files is, for example, you can put a tilde at the end, and then sometimes this works and shows you the source code. And in this case, it does. And then you see basically PHP code in there, right? So something which, so we will go through this line by line and try to understand what each of these lines are doing in the function. But what catches my attention right away is something called a destruct function. So this destruct function basically means I'm deleting something, right? And then there's even a comment that Carlos thought this would be a good idea. So there's a little hint that if Carlos thinks this is a good idea, it's probably not. But what you can see here is that you have something called a log file path right here, right? And if this is invoked, the unlink function is basically triggered, which then leads to the destruction of a specific file. And this is also referred to as a custom template, right? So here we have this is the class. It sits in the PHP class. It's the custom template all the way until down here. So this is something we need to keep in mind because we need to create an object called custom template. And we need to set this to true. And then within the custom template, we want to invoke that log file path because we know where this leads. This leads to the destruct function. So with all this in mind, we can go over and craft our exploit, which I have done in advance. So this is how it would look like. So as you remember, I said like this is the object is custom template, which you can grab from here. So you always need to see like with which class this sits in basically. And then that's basically enabled. And then in there, in the curly brackets, you find that we are invoking the log file path, which is a string of 14 characters length. And then what we are going to do is basically we want to delete this file, right? This could be any other file, but you always need to update like the string length here. So it's 23 characters in this case. So let's just take this and let me head back here to my actual cookie. And then I'm going to replace all of this with my custom template, right? And if I'm happy with this, I hit apply changes. And all that should happen now is I invoke any function, like I hit send here, and I get an internal server error. Okay, yeah, because it doesn't match anymore. There's no username information, no access token, no whatever. But if I go over to the lab, it has been successfully completed. So the goal was not to reach an admin panel. The goal was actually to delete a specific file, and that's what we have accomplished. Okay, I hope that makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the insecure deserialization section, and today is exploiting Java deserialization with Apache Commons. So once again, we have a vulnerable application, a session-based mechanism that loads Apache Commons collections library. Okay, so this time around, not like in the previous lab, we don't have access to the source code, but we can use a tool called YSO Serial in order to use pre-built gadget chains to exploit vulnerabilities in Java when it comes to handling serialization and deserialization. Okay, so let's head over to our application. Let's go to my account and log in. And basically, you might be asking, hey, how do I know that this is running Java and things like that? Well, there's numerous ways. You can use passive enumeration techniques. You can also use the Burp Suite Pro scanner, which is pretty good on actually identifying Java deserialization, deserialization in general. And then you have multiple plugins as well. I'm not going into detail on that, but for Burp Suite, there's plugins like the Java deserialization scanner and things like that. So let's first of all take a look here, and let's go to my account. And if I look at the object here, basically one indicator is always like if you don't use Burp Scanner, like this is R0, RO0 are always like this starting characters on that, right? So what we can do now, like once you identified that this vulnerability exists, so you simply take this and send it over to repeater, right? And I can head over to a Linux machine or something, and basically you download this file here. This is a YSO serial, and you can find this on the GitHub repository of Frohoff. And you can read through this, like how it works, what it does, what the options are. You also have, like, for example, you can use java -jar, and then you get like all these different payloads and authors and the dependencies and whatnot. And based on what you found in your enumeration phase, you can then pick the right one. Okay, so what's gonna one thing of word of caution: if you use the latest Java development kit, it does not work. So you have to use like an earlier version. I believe it's before 13. So if your Kali Linux or whatever you use is on version 17, for example, it doesn't work. So you need to downgrade it effectively, right? And then the usage is very easy. So it's java -jar. So as you can see this here, java -jar, and then you call the jar file, and then you select what you wanna, like which deserialization technique you wanna act upon, like Commons Collection 4, for example. There's Commons Collection 3 and so on. So you can try all of them. And then the actual command you wanna issue. So in our case, it's rm, this is a Linux command, and then the path and the file, what you want to do. And important, base 64 encode that payload. You hit enter, and then that gives you your base 64 blob here, basically. So you take this out, you copy this, and then you head over to your to Burp decoder, put it in the decoder in here, and then you also say you want to encode this as URL, right? So you want to create like an URL encoded payload, and I copy this, and I head back to my repeater, and I replace my session cookie here with my newly generated payload, which looks like this. Hang on, there's the user agent down here that needs to be in a separate line like this. Okay, and then I simply hit send. And if all goes well, the deserialization process will then delete the home Carlos Morali. So I get a 500 server error, so I don't get a visible output on whether that worked or not. But if I head over to my lab, you can see that the lab has been solved successfully. So my exploit was successful. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the insecure deserialization section, and today's lab is exploiting PHP deserialization with a pre-built gadget chain. So this lab is similar to the one before, where we had the Java deserialization issues, but this time it's PHP. And once again, we do not have access to the source code, right? Like, so there is a tool called PHP GGC, as you can see this here on GitHub, which is like a generic gadget chain tool, which helps you exploiting insecure deserialization on PHP. And there's multiple gadget chains, like if you have Laravel, for example, or Magento, Monologue, and so forth. But this is all dependent on what's in use and what's vulnerable and which version it has and stuff. But we come back to this later. So let's get started first. Let's log into our account and take a look at the cookie which we get assigned. So we are logging in here, and we go over to proxy and take a look. So this is our cookie, basically. So if I take this and if I put it into decoder, so I move it over to decoder, I decode it as URL first of all. So I see there's a token in there, right? And token seems to be base 64, but more interestingly, there is like an HMAC SHA-1 signature. And so this indicates to me that this is being verified. So what I mean by that is that I cannot just modify the serialized object or create one on my own. I need to have the correct signing key for that as well in order for this to make it work. So what happens if I'm going to send this over to my repeater and I start messing with the cookie, right? Like I'm just deleting some stuff, so the signature should no longer be verified. Oh, I get an internal server error, and it reveals to me that the Symfony version 4.3.6 is in use. So this is something I am interested in, and I take a note of that, right? So that's number one. Then if I go to the home page, the main page, so let's send this to repeater and analyze a bit and see what's happening here. And you know, one thing I typically like to search for is keywords, and I just like to browse through, and I like to look for comments, for example, like if there is any comments. And yeah, there is a comment. So this is a comment here, right? href CGI bin php info dot PHP. So interesting, right? So let's see if we can find this here in the target. Yes, there it is. There it is. And we sent this. And so this is an interesting file, right? Like, because this should probably not be visible to the public. So I can go through this line by line, or I can start looking for keywords like secret. And then I see, hey, there's a secret key, which is defined here. And my assumption is that that secret key may be the signing key for our object, right? So that I can actually create an object and then I can sign it. And so this is quite interesting. So basically I keep hold of that. So let's head over. So I have downloaded the PHP GGC tool from GitHub, the generic gadget chains, and I downloaded this locally. And now what I want to do is, I know a couple of things already, right? So I know that there's Symfony in use, and I can basically, I know the version number of Symfony. So if I would head over here again and look for Symfony, I see that the version we encountered is RC4. So the gadget chain RC4 should work because our version number is within these ranges, right? So with that in mind, I'm going ahead here and I can actually create a gadget chain for this specific Symfony RC4 based on the version number. And I instructed to execute a command, which is removing the morali.txt from the home Carlos directory. And then I base 64 encode that as well. So I run this, and this is basically my base 64 blob, right? So this is what I'm going to use at a later stage. Now, if you search around, and the GitHub page also gives you a lot of information around this, but if you search around, now you need to find a PHP skeleton script which allows you to actually encode, to actually create the object and then sign that object with the secret key. And if I take a look, I found this online, by the way. So what I'm going to do here, I simply define an object. In the object, I put in the base64 blob of my command, which I just did here, right? This is basically the base64 equivalent in here. And then I also need the secret key in order to sign it, right? So let me come in here and remove this secret key, because this may not be, well, this is certainly not the right one, but the secret key we encountered earlier in the PHP info file, right? So let's put this in here and let's save this. And now we simply say PHP, and then one.php is basically the command. And that generates my my new cookie effectively, right? So let me put this in here. This is my cookie, and I copy it out, and I will head back to Burp, and I will now, I believe it's this one. Yes, it was this one. So I'm going to replace the session cookie with my own creation, right? And then I hit send, and I get a 500 server error. But if I head over to my lab, it's basically solved the lab. So I was successfully able to use that gadget chain to delete a user file based on all the findings I have demonstrated. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. So today we are in the insecurity serialization labs, and this lab is exploiting Ruby deserialization using a documented gadget chain. So the application here uses a serialization-based session mechanism, which is based on Ruby on Rails. You could find this out via passive fingerprinting. You can run the burp scanner, and you can start messing with the actual cookie. And so basically, this is a very simple lab, effectively, because there's a pre-built exploit out there on the web, which I'm going to show you in a second, but let's take a look first at my account. So if I logged in, I can basically see here, this is my cookie effectively, right? So, and I can now take it, copy it, put it into decoder, see what it looks like, and so decode as base64, for example, and then you can see when you base64 decode it, you can see that there is some serialization going on. So username is Wiener and things like that. So you can already guess that there is something going on. So what do you do next? Because we know it's working on Ruby, is you would simply go out to Google and look for a deserialization gadget for Ruby. You find numerous websites like devcraft.io, and then they provide you the full script basically. So just to show you this, here, this is another one. This is, I believe it's a Japanese or Chinese website, but this is basically the full exploit, and it has been pre-written for you. I'm not going through all the details here. It's just for you to see that a lot of these gadget chains can be found online. The exploit database from Offensive Security is pretty good on that as well. And then you just need to modify it to your needs. Like the only modification you would really need to make here is that you remove the home carlosmorali.txt or whatever you command you want to issue. You know, like obviously in a real engagement, you would not want to delete any information, but you may want just to have a proof of concept where you put in ID or LS or something like that, right? And then once you downloaded this, you put it on your Linux machine, and then you simply run the Ruby again. So you need to save it as .rb for Ruby, and then you simply fire it, and it gives you your payload. There's some errors in the script, which I haven't troubleshooted yet. But basically, so this is your hexadecimal payload. You can also specify that you output this in base64, and then you basically output it in base64. You take the cookie, or you take the hex value and encode it in base64, like whatever you like, and then you simply put it in here into your repeater, and the lab is being solved. Okay, so this is very simple, not much to do here because you're using someone else's exploit. Okay, I see you in the next lab. Hey guys, this is Martin, and we are in the information disclosure section, and today's lab is information disclosure in version control history. So this lab basically exposes a file called .git, which is a repository, right? And this is like GitHub and places like that, like repositories, local repositories, is quite common these days. And if you understand, you know, like how this works with your repositories, like for example, you have a version control history, like when you make a new commit, then the version control history may still be available, like what it was before and things like that. So this is basically what this lab is trying to exploit. So if we're heading over to our application, like you're not only looking for robots.txt and you know, like admin panels or backup folders, you also always should try something like this, which is called /.git. And then if you get a hit, you see that there is a repository at the .git path. And now in order to analyze this, the easiest way to do this is to download it locally to your local machine. And this, you can do this like with a command like this, like wget. So you need to install wget and then -r, and then basically the URL of that specific Git directory, right? Once it's downloaded, I prefer to use a tool called GitHub Desktop, which is free. And you simply head over here and you say new repository, then you get that screen, and then you can choose a local repository, like for example, this one, right? This is the one I just downloaded. And then I hit open, and this directory, this appears to be a directory, a Git directory. Would you like to add this repository instead? Yes, add repository. So we do this basically, right? So, and then you're in your current branch, like this is the master branch, right? And then you see there is like two files. There is like an admin PHP an admin_panel PHP. and then there is an admin conf. And then you see like in the admin conf, there is like an environment variable set to admin underscore password, which doesn't really help me. So this is obviously the latest version, but the trick comes when you go to the history. So if you go to the history, you see previous, like right now. So this is the latest, the green one. It's using a variable, so which is a lot more secure because it's pulling it from elsewhere rather than hard coding it. But you see, before that, they had hard coded the admin password in the repository, and in the control history, it's still visible. So if I take this, if I copy this out, I head over to my application, and I'm now trying to log in with the administrator password, that should work in theory, right? And it does. So, and I basically solved the lab by doing so, and now I have to delete the user Carlos. But this shows you the danger that sometimes like information, juicy information, valuable information can be found in the history. Even though right now this is no longer the case in the code, but if the history is enabled, basically you can basically see, so Carlos Montoya admin.conf, and this has been changed effectively, right? Like before that, password was in clear text in there, and now they made it more secure, but in the control version history, you can still see the password and they haven't changed it. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and today we are looking at business logic vulnerabilities. In today's lab, low-level logic flaw. So once again, we have our shopping cart. There is a leather jacket for $1,300, which we would like to buy, but our budget is only $100. We only have $100 credit, and let's see if we can bypass that logic and still buy this jacket. So if we come in here, we go to our jacket and we add it to the cart, you will see what you see before, that basically we cannot afford it. We have $100 store credit and it's $1,337 to buy it. Okay, so it doesn't work, right? So something I can try is I can send this post over, first of all, to Repeater and see, hey, can I actually put 100 leather jackets in there? And it will say like, no. So the quantity is too high probably. So what about 99? All right, yeah, that worked. So if this has gone well, I should have 100 in my shopping cart now, and I do. And that's great. And you know what I want to try is maybe I can inflict an error. Like I send like a lot of requests with 99 orders or 99 in the jackets in each shopping cart request. And then what should happen is this will count up significantly here. You can see that, right? Like the sum goes up. So my thinking is maybe there's a logic flaw. Like if I send enough of these requests that the number gets so high that the application will throw an error or something like this. But doing this manually takes a lot of time, so I use the intruder. And say, like I'm coming to the intruder and I am going to use something called nil payloads, where I basically can just specify like, send me 300 times the request with 99 each, right? And then we simply hit start attack and see what's happening. So you can see this is counting up fairly quickly. And I should now have a huge number in my shopping cart. But look what happened. It actually went into negative territory. So there is some overflow, some code logic overflow. When it reaches a certain number, it throws an error and basically starts counting on the negative side. So there's certainly a vulnerability here. So now I basically need to get between 0 and 100 to actually buy my item, right? So what I can do here is I can go back to Repeater, and then in the Repeater I send like 10 requests with 99 manually, like something like this. And if my logic is correct, then basically the number should now get closer to 0, and it does. Okay, so let's keep doing this. Let's send another 10. And then let's see what my number says. And we are still $3 million is still minus $3 million, sorry. So let's keep sending here until we get closer to 0. So it's 1.6. And let's send another one, and that will be 1.5. So let's send another 1, 2, 3, 4, 5. And now it's minus 800,000. It's still far off. 1, 2, 3, 4. And let's see where that gets us to. Minus 300,000. 1, 2. And now we are at minus 64,000, right? So this is now it's getting more interesting. So now let's just add 10 leather jackets, which should be like $14,000 or something, round about that. So let's see what the figure is. 50,000. Okay, let's send another 10, 20, 30. And now we are at minus 10,000. Now it gets really interesting. So I don't want to play with this with the 1300 anymore. So or well, basically let me just add them one by one. So I add like 1, 2, 3, 4 at 1300 each, which brings me to 5,000. Okay, let's do this 1, 2, 3 again. Now what's the price? It's minus 1,200, right? So this is interesting now. So now let's see if there's other products I could add to my shopping cart. So I've just added another product, which now brings the price to minus 1,100. So let's see which one that was. So it's basically, it was the last post to the cart. Send this to repeater over as well. And let's send like 5 of those. Those are like just $100 each or something. And that brings us to 700. And then another 1, 2, 3, 4, 5, 6. And that brings us to 135 or minus 135, and put another one in, and that brings us to minus 36. So if I now add another $100, I should be at a positive value, but I should still be within my budget. So let's try this. Send another one. Take a look here. And we are at $61. Perfect. So now we can place our order, and basically we trick the application into giving us the leather jackets. So we are getting now 32,000 leather jackets. And we probably bankrupted the store right now. And 13 of those now delivered to your door. So this is a classic example of an application logic flaw vulnerability. Hope that makes sense, and I'll see you in the next lab. Hey guys, this is Martin, and we are in the business logic vulnerability section, and today's lab is inconsistent handling of exceptional input. So once again, we need to exploit a logic flaw, basically to gain access to administrative functionality. Okay, so let's head over first, and we haven't been given any username or password to log in. So the first thing I'm going to do is register. And I need to register. So if you work for Don't Wanna Cry, please use your Don't Wanna Cry email address. So this is the first hint that maybe the email address once again is linked to account privileges. So if you have a Don't Wanna Cry email address, you basically probably get admin privileges. The problem is I have an email account here on my exploit server, but I don't have a Don't Wanna Cry email address, right? So I need to register first with my own name, username Martin, and my email address, and then password Martin. And once I do this, I go over to my email, and then I get a completion link for the registration, and now I'm registered. So if I now go in and log in as Martin, I see that I don't have the option like in the previous lab to change my email to don'twannacry.com. So that's certainly not an option which is going to work. But let's check other things, right? So what happens, for example, if I put in my username at Martin, right? And then password Martin as well. No, I can't do this. Let me call this Peter, because Martin already got registered. So I call it Peter. And as an email address, Let's do the following, right? Like, let's first of all see what is our domain. So assuming that I can control my own domain, which is this one here, right? So now I'm creating an email account, and the email account will be a very long string, for example, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I repeat this like, say, I want to get at least 300 characters or something like this. So down here I can see, yeah, it's like more than 300 characters, 307 characters now. And I use this to sign up and see if this works, right? Like just testing out things. Register. And I got a registration link, hopefully. So let's try this. And I get the registration link. I click it. And now I should be able to log in as Peter. All right, and now I see, look at my email address. So what I immediately spot is, hey, this truncated some certain things, right? Like it basically did not put the full email address. So there must be a limit in number of characters, and then the application gets confused afterwards. So let me copy this over and see, like my original one, if I redo this, my original one was 307 something characters long, right? Like 306 characters long. And if I look at this one here, I see that this is 255. So it stops processing the input at 255. So what I'm going to try now is I will set up another account where basically I use this really long string once again, right? But this time I basically make sure that I will put the @wannacry.com as a subdomain of my own domain. And then basically I will put the exploit server at the end. So what's important here is that the don'twannacry.com has to end at character 256, because then it's basically still being displayed, right? And I don't care if the rest is being displayed. I only need the rest for me to actually be able to register and receive that email. So let's log out here. Let's go back to the register, and then let's say hello and password hello. And then let's use this email address and see what happens. So I register. I should get an email address because it's on my subdomain. That should work in theory. And yes, it did. And I was able to confirm this. So now if I log in as hello and hello, if my assumption was right, it's now ending in .wannacry.com. So I have successfully tricked the application because the application cuts it off after 255 characters. And I put the don't wanna cry there. So it now thinks I'm a don't wanna cry user, and I have the admin panel here. And I can now delete the user Carlos and solve the lab. I hope this makes sense, and I'll see you in the next one. Hey guys, this is Martin. We are in the business logic vulnerability section, and today we have a lab called weak isolation of a dual use endpoint. So there is a flawed assumption that about the user's privilege level based on their input. And I will be able to exploit this in order to access the administrator account and delete the user Carlos. But first, I need to log in with my own credentials to see what kind of functionality we have. So I log in as Wiener Peter, and then you can immediately see something interesting here. So you have basically a function where I can put in my password and my current password, so it's Peter, and I want to set the new password to Wiener and the new password confirmed to Wiener. So I sent this, and that should have worked. Yeah, password successfully changed. So let's take a look how this post request actually is constructed. So let's send it to repeat, and we see here we have a CSRF token, we have the username. Now we can control the username, right? So I say Carlos, and I want to set the new passwords to Carlos and Carlos. But the problem is I don't know the current password, so I put in anything, right? And then I send it, and I get an okay, but did it actually take it? No, your current password is incorrect. So that's the problem. So that's a problem because I don't have Carlos's current password. Now, as an attacker, as a bug bounty researcher, thinking, what happens if I supply no current password at all, right? Something like this, and then check this again, and it still complains because it was a blank password. It still complains about it. Now, what happens if I actually remove the whole parameter altogether, right? Like something like this, username Carlos, new password, new password. Does this work? And surprisingly, it did, right? So if the parameter is removed altogether, the application will no longer require the current password of Carlos. So that in mind, I'm going to log out of my account here, and now I should be able to log in as Carlos. But that was just like one example, right? Our task actually is not to compromise Carlos. Our task is to compromise the administrator. So I will simply replay this once more. Okay, and let's see if this works for administrator now. And the password should be Carlos. And that didn't work. And I can also tell you the reason why this didn't work, because I logged out. So I log in as Wiener and Wiener again. Okay, so I run through this one more time here. So now I say administrator, and the current password is test, and the new password is admin, and the new password is admin. Change password, I get the error message like before, but I need to resend this to the repeater. I send it over to the repeater, and now I delete the current password parameter, including the value, right? Like something like this, hit send, that should have worked. Then I log out again, and now I should be able to actually log in with the credentials administrator and admin, and this worked, and now I have my admin panel and I can delete the user Carlos. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the business logic vulnerability section, and today's lab is insufficient workflow validation. So the lab makes a flawed assumption about the sequence of events, and you will actually see this quite often in the real world, that developers think a user should follow a certain process, like on a checkout. But you can often mess with the application when you do not follow that specific sequence, and that may introduce risk and vulnerability. So let me show you how this works. So let's head over and log in with my account. Job is the same as always. We are supposed to buy the leather jacket, but we don't have enough budget. So we have $100. We want to have this leather jacket, and we can add it to the cart right now, but there's no good, right? So I cannot buy it because I don't have enough money. But there's other nice articles around there. So for example, this one here, I may be able to buy this. So it's called ComTool, and I add it to cart, and I just want to make a purchase right now, right? And then I say place order, and that order went through. So the store credit has been adjusted. And if we take a look at what happened, is actually we put the item into the cart, right? So sorry, the item was put into the cart here, this one here, and then basically this was the product ID and this was the quantity. And then in the shopping cart, we said, hey, we are going to simply check out, like we want to buy this now. This is when I clicked, and then something interesting happened. Then we were doing a get cart order confirmation, order confirmed equals true. This sounds interesting. So what happens if I put this to repeater and play with this? Because that seems to be the actual confirmation that we have made the purchase successfully. So if I go back here and I now add my leather jacket to the cart, right? So I add the leather jacket to the cart, and now I'm trying to buy it. So place order, and it will give me an error, not enough credit for this purchase, but it's still here in the cart, right? So what happens if I now basically have it still in the cart, but I send the confirmed true request? So I'm not following the order, right? So I sent this over, and that basically solves my lab, because now I have sent a confirmation that the purchase was successful, which should never come from the client side. There should be server-side only, but this was a classical example how you can actually trick the application. And then I made the successful purchase here. Okay, I hope this makes sense, and I'll see you in the next lab. Hey guys, this is Martin. We are in the business logic vulnerability section, and today's lab is authentication bypass via flawed state machine. So there's certain assumptions being made around the login process. And if you do not follow exactly what the developers intended to, what the user is supposed to follow, you may be able to gain admin credentials. And then our goal is to delete the user Carlos. So first and foremost, let's head over to our account. There is probably an admin panel somewhere. So I'm unauthenticated now. I cannot reach it. Let me log in here first and then see if maybe there is a flaw that see like I have like a role selector or something like this. This is interesting. So what happens? Let me go first and say admin from within, and I get an error message, right? Like, so I also cannot access this, and I'm even getting kicked out. So let me log in again, Peter Wiener, and I can change the role selector here to content author. Well, now I'm a content author. This is also not really interesting, right? So maybe there is something. So if I look at this here, right, like there is like this role selector kind of thing, and there's a role called content author. But I don't have the solution at this point. So what I'm going to do is I log out and I log back in. But this time around, I'm actually going to proxy the traffic in Burp so that we intercept it and then we can modify it on the fly. So let's log in with Wiener and Peter. And the request is now proxied, so it's not sent yet because it's hanging here. So let's look at the first one. It's called post login. And then there's simply a CSRF token for cross-site request forgery protection and the username and the password parameter. So nothing special here. Forward that. But now there's something called a get role selector. That is weird, right? Like get role selector. So maybe this has something to do with the privilege level or whatever, right? So let's actually drop this. Like what happens if we drop it? So maybe it will default me into a group if I drop it. I think the role selector might be just saying like, hey, you are not an admin or something like this, right? So let's drop it and then let's turn the intercept off, right? So obviously we get an error message here. And now if we browse to my account directly, then you see we are logged in as an administrator. So this is a very interesting flaw because the role selector, as I suspected, indeed determines on whether you are an admin or not. And if the role selector is not being sent, if that request is not being sent, it's assuming you're an administrator. And then all you have to do is browse directly to that page, right? Now you can see I can go to the admin panel and I can delete Carlos. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin and we are in the business logic vulnerability section. Today's lab is infinite money logic flaw. So let's head over to our application. The same task as before. Basically, we are supposed to buy this leather jacket and we don't have enough funds in our account. So if you come over here, you see the score credit is 100 and the leather jacket is 1337. So what can we do? Basically, first of all, I see here there's a newsletter sign up, and so I sign up with test.com, sometimes to get vouchers or something. Yeah, we got a coupon code. It's called sign up 30. Cool. Okay, so if I can't buy the leather jacket, I might as well buy a gift card, take this gift card, post it to the card, head over to the card, actually use my coupon code, the sign up 30 here to apply this. And I get a 30% discount. Great. So it only costs $7. I place the order and I get a code, a voucher code basically from my gift card. So if I head back to my account and I can redeem it here, right? So I redeem it and bang, I have $103 in the account. So this is great. I made $3 out of nothing. Here's your vulnerability. This is the flaw. And I could do this forever and ever until I hit 1337, but we are going to automate this in Burp, and this is the purpose of this lab. So let's head over to Burp first of all. And you can see here, like when I post the gift card, basically I get a 302 found, and this is basically my gift card parameter down here, right? Like this is, and I'm now generating, so my goal is here to generate like loads of them. And so let's head over to sessions first of all, and then when you go to sessions, we go to session handling rules. And so we create a new rule, and the rule will say like include all URLs. And what we want to do is we actually want to run a macro. So what is a macro? A macro basically, we need to select the macro. So add, no, hang on a minute. Actually, let me quit this, and actually let's create a macro first, right? Like, so we have our rule and we have a macro one now, basically. So yeah, we just need to come in here and say like run macro one. Okay, so this is basically what we want to do. So this is our macro we select. So you will ask, what is a macro? Well, a macro basically is a sequence of events where you automate certain things, right? And basically we now need to come into here into our macro, hit the edit button, and actually it's not showing this. Okay, so let's remove the macro one more time and let's add a new one. Okay, so this is great now. Now I see actually my burp history here, right? And so what was important from our flow perspective? Well, first of all, it was the postcard. That was number one. Then we basically posted the coupon code to get the discount, the sign up 30 code, right? And then we performed the checkout, then we got the order confirmation, and finally we redeemed the gift card. So those are really like the important ones for us, those 5, right? And what I'm going to do now is I need to modify them so it suits all my needs. So let's come to this one here first, and let's configure this item. This is the confirmation, basically, and what I want to do here is I want to add like a parameter, and the parameter I call gift card, because I want to associate the gift card parameter with the actual gift card code, which I can find down here, and then I just need to highlight this and say okay. Okay, so I'm associating the gift card parameter with this gift card code. I do this and I hit OK again, and that's basically it, what I had to do in this particular one. And now when we post the gift card, so we will configure that item as well. And we don't want to use a preset value because this is changing, like as we iterate through this flow over and over again to exploit it. Basically, I want to derive the response derived from a prior response. And that is response number 4 in our case, because that is when the gift card becomes visible. And then I need to take it out of this response, and then I need to apply it and redeem it. Okay, so that's basically it here, what I need to do in this scenario. So now I test my macro. So I hit test macro and I simply see like what's going on here. And this is great because the last one posted already a different gift card number than before. Okay, so my macro seems to work fine. So it's called macro 2, by the way. Let's keep a note of this. And then over here, we simply come in here and let me actually remove this rule, which I've done earlier. Remove it and add a new one. And this is called rule number 2. And the rule action is run a macro. And we want to basically select macro 2, right? Select macro 2. And we also want to make sure that the scope, we have all URLs in the scope. Cool. So we are pretty much ready here. And then now I take the get my account request and send it over to intruder. And all I want to do now is like to generate a lot of requests. So for every request I send, this flow will be kicked off one more time. And so what I need to do is I select payloads, and in the payloads I say null payloads, and I'm generating 412. Reason for that is because I get $3 per round, and then that should be enough money to buy the leather jacket. Also, I need to make sure in the resource pool that I only have one concurrent request. So once I'm done with this, I hit start, and then you see like the flow kicks off. And we will not go through the whole flow now because this takes a long time. But what I want to show you is if I refresh here, we are at 132 now. If I refresh again, we are at 145. So see, this is counting up all the way until we have achieved like our $1337, and then we head over and buy the card. I'm not waiting with the video for this to complete because you see it's quite slow, but this is the process in automating this. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the business logic vulnerability section, and today's lab is authentication bypass via encryption oracle. So whenever you hear the term encryption oracle, it's basically where there is a logic flaw in the application whereby it uses encryption on the one hand, like on one function, but another function within the same application can be used to decrypt that ciphertext, basically. So with that in mind, you may be able to pull off attacks whereby the developers thought like, hey, we are encrypting, and but on another function they basically allow you unintentionally to decrypt functionality. So to understand this better, let's head over to the application, and if we go to my account, so I'm logged in here, right? And what I want to show you is, first of all, there's a state logged in option. So if you choose the state logged in option, basically you have an additional cookie set, which is this one here, right? And what I can do, so now there's another functionality on the block, right? Like if you go over to the block, so first of all, you have an encrypted cookie. That's the first thing to notice. But then you have the functionality basically that, for example, you can put anything in here, like a test, and let's put just test in the email field, right? Like instead of a real email address. And then you notice something interesting. You get something called invalid email address test, right? So nothing special so far, but let's put this post command into repeater. And let's also put the subsequent get command into repeater, right? So we have them both. So what you see here, that when I put basically the email as test, right, I get a notification cookie set. Now this is interesting because I can copy this cookie out, right, the notification cookie, and I can head over basically to my get request and then replace the notification cookie here with that cookie I just generated. And if I do this, I should see something interesting. If we scroll down a bit, invalid email address test. So basically what happened here is that function down here, the post request, when you input an incorrect email, is generating a ciphertext, is generating this encrypted value, the notification cookie. And on the other hand, with the get request, you can basically decrypt it. Now with that in mind, let's head over to our Burp history, and let's take that real notification, that state logged in cookie, sorry, this one here, right? And let's try to decrypt this one, right? Like, so this is certainly encrypted. And if I head over to repeater, go to my get request, and now I replace that state logged in, or I use the state logged in cookie and put it into the notification cookie. Let's see what happens. So if I scroll down here, I can actually see there's something called Vina, okay? And this is a timestamp, right? So I copy this out, first of all, right? Like this. And so now I have already confirmed that this is my encryption oracle. So what happens now if I take administrator instead, right? So if I take administrator and my timestamp, right? So let's try this. Let's head over to our encrypt function, and instead of saying test here, I put in administrator and then basically the timestamp, right? I send this, I get a new notification cookie over here. I copy this notification cookie and decrypt it in the notification cookie section of my get request. I do it like this. Okay, I hit send. And what I can get to see now, there is like something called invalid email address. And this basically means that there is some padding going on. And what you typically see with these kind of encryption oracles that the encryption algorithm usually takes blocks of like 16 bytes, right? And what you need to do, and I'm not going through this, you can actually read through this in the lab documentation, but what you need to do is to make sure that when you supply your input, you need, in order for this to disappear, the invalid email address, you need to calculate the bytes. So one way of doing this is like putting invalid characters in front of the administrator, right? Then put it into your decoder, and once you put it in your decoder, you basically can see what is cut off and what is still valid. So let me show you this real quick, how this works. So you would, for example, put like 9 invalid characters before the administrator with the intention of having this cut off, right? So let's do this. Let's send it in our encryption request first, like something like this. And this is trial and error, right? This is not necessarily, it depends on the length of your cookie and on length of the username and stuff like that. But basically I generated my notification cookie once again. I head over and I basically replace it here in the decryption function once more. And now I send it and I want to see what is coming out here. And now you see, hey, I was able actually to I was able to introduce those X's, right? And now if I calculate, so the best way of doing this now is basically take this notification cookie, which we generated ourselves, and put it over to something called the decoder, right? So first of all, what we need to do is we need to decode it as URL. So URL decoded first, then we need to decode it as base 64 because it's a base 64 block basically. And then with some calculations like how many bytes we have and where's the cutoff and stuff like that, you need to delete the first 32 bytes out of this. So basically I will mark all these, so you can mark them like this and then say delete the selected bytes, right? And then once I'm done with this, I need to re-encode it. So basically here I need to say encode as base 64 and then encode as URL, right? So this is basically my generated cookie. I take it over to Repeater. I come here and I put it into the notification cookie to decrypt it and see what the result is. So I send this, and if I scroll down now, I only see the administrator, right? So I only see the administrator. So I was correct with my logic. And how many bytes you have to delete and stuff, it's a trial and error, right? But we already seen that it's taking like in 16 byte intervals. And so in this case, it was fairly easy. But normally you would need to go in and then delete like a couple of them and see what's left, and then delete more and see what's left. And then maybe you delete too many, and then part of your administrator word is missing or something like this, but this is exactly right now. So this is my forged cookie basically, right? So I was successfully able to forge my cookie, and now what I need to do is I go to my, well, first of all, let me copy this. This is number one. So this is my forged cookie. I go to my to a GET request, right? Like this is a normal GET request to the website. And what I will do is I will delete the session cookie completely. So all together, I will delete the session cookie. And then I have just the state logged in cookie. And if I now basically replace that state logged in cookie with the cookie which mimics the administrator, let's see what happens. So I send this over and I do a render here. And I see my admin panel. So this means I'm now actually logged in as an administrator. So now it should be easy. I should be able to say get admin and get admin. So I see I can delete user Carlos. So I just need to come here, say delete, and then the parameter username equals Carlos. And once more, so I got a 302 found, and I delete that path to verify that this actually happened, and that solves the lab basically. So this was an example of an encryption oracle, quite common actually, like you find this in the wild quite a lot, and this is the methodology how to solve this. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the HTTP host header attack section. And today's lab is web cache poisoning via ambiguous requests. So you will find similarities to what we have seen in our previous labs around web cache poisoning, but the focus really here is on the host header attack. So let's get started. So if we load our main page, what we're going to see is that there is once again a JavaScript being loaded, which is located at resources.js tracking.js, right? So you can see this here. What I'm going to do right away is I'm going to craft a little exploit on my exploit server before doing anything else. So I simply go in here, put in this path, and I also put in like an alert 0 or something as a payload. I simply store this, and nothing spectacular had happened yet. If I load the main page, right, I will see there is some caching information like the X cache and the H cache control and things like that. So this might be susceptible to web cache poisoning, right? So first and foremost, as you probably remember from the web cache poisoning section, I put a cache buster so I can reinitiate the cache poisoning without always waiting for 35 seconds, right? So I simply change the value here. So this is the first thing. So one thing you can see is that we're going to our host, which is our application, right? But sometimes applications are misconfigured that basically two hosts are being accepted. So what happens if I put another host header in there, but on this host header, I set it to my exploit server, right? I set it to the exploit server. I copy that, put that over, and I forgot the E here, so exploit, right? Exploit server. So let's just make sure that this is fine. And what happens now if I send a request, right? So let me change the cache buster once again, and I send a request, and I get a timeout, which is strange. This may be related to the fact that this is HTTP version 2. So let me change that quickly to version 1 and see what happens. Okay, so I have the miss, and now I have the hit, right? So what you can see here that basically the script is loaded, but from my malicious exploit server. So if I request this in browser, show response in browser, and I head over and I load this here in the web browser, I get my pop-up. So I was able to use an HTTP host header attack by duplicating the host header to facilitate this. Now, all which is left to do is remove the cache buster and then send it again. So I will poison it for regular users as well. And that should be the case now. And if I now reload this in the browser once more, then I should be able to get my pop-up, and the lab should solve theoretically, which it doesn't yet, but don't worry about that. I mean, there's some flaws recently in the labs. Like you have seen, I also had to change it to HTTP version 1.1 instead of 2 because it didn't work on that one. But you can clearly see that if I reload the home page, I basically get my pop-up and I have poisoned successfully the web cache. Okay, I hope this makes sense, and I see you in the next lab. Hi guys, this is Martin. We are in the HTTP host header attack section, and today's lab is routing-based SSRF, routing-based server-side request forgery. So there is a vulnerability associated with the host header, and we can exploit this to actually get to an admin panel on an internal IP address. Now, we know there's an admin panel and we know that it's in that range, but that's all information we have been given so far. Okay, let's head over to our application, load our application, and first thing we are going to do is send the GET request over to repeater, right? We also want to change the HTTP protocol to version 1 because I've seen problems with this in the past in the new Pulse Rigger labs, and it may not be fully configured yet. So if I'm going to send this out, first test I want to do is basically I want to head over and simply introduce my Burp collaborator client in here to see if I can trigger an out-of-band reaction to my Burp collaborator client. I'm sending this out. It seems like that this worked. I just confirm it by polling here, and yes, I get an out-of-band interaction. Perfect. So that means I can start meddling with my Burp collaborator client or with the host header, so to speak. And now I want to say 192.168.1.0.1, for example, right? Something like this. And do I get a response? No, I get a gateway timeout, which probably means that this does not exist on that specific host. So let me put this over to Intruder to brute force this. So I want to brute force that one position, basically, which is this one here. So I want to go through the whole Class C network in order to basically find this open admin panel. And I'm going from number 1 to 255 with a step of 1. And one thing I also need to do is I need to untick this update host header to match the target, because that's intentional that I'm actually brute forcing the internal range from here, right? This is the SSRF attack through the host header. So also, I want to make sure that we use a resource pool of only one, that we send one request at a time, and we ignore this message. So we deliberately want to brute force our internal range here, right? So let's get started. Let's see what happens. This may be really slow and may take a bit until it actually kicks in. So it's now, well, the first one has given me already an error, and we shall see how this continues. So one thing, a word of caution, Portswigger recently updated a lot of their labs, basically, and they moved from HTTP version 1.1 to version 2, and it has broken an awful lot of functionality in the labs. Hence these kind of problems. So let me stop this and actually see if that's the case. So maybe I need to do this with HTTP version 2, and then let's try it again. Let's see if this does any better, if this does any change. And maybe it does, maybe it does not, we will see. It looks like this is also not gonna work. I'm also getting errors thrown here, right? So blank responses. So this may be a problem on the server in general. It's still responsive here. And yeah, maybe, yeah, it's working now, right? Like it just took a bit to kick off. And so it's trying this now. And what I see is I get 504s everywhere, which is like gateway timeout. So this indicates there is no portal on those. But what I want to do is I want to look for a 302 or something, right? Like where I get a redirect. And so far I'm almost 200 brute forced through. And here is one, right? So the 180, 82. So let's take this over, send it to repeater, and now let's browse to the admin panel and see if we can get any response here. And we do not. So maybe on version 1.1, we get a response. Also not. Yeah, and I should be able to see the admin panel now. And let's change it back one more time to HTTP 1.1. And now it worked. Yeah, see, now I can actually start deleting the user. So what I want to do is, first of all, I need to find out, I want to delete Carlos, I presume. But this may be hidden here. So from my previous labs, I know the syntax, right? So I basically need to call the delete endpoint, and then I need to say username equals Carlos. And if I send this, then I get, oh, there's a missing parameter, which is basically a CSRF token is missing. So let me just browse back to the admin panel real quick. And let's look for CSRF, right? So there should be a CSRF. So, and there is a token in there, right? So let's basically come over here again and then append that token and see srf equals and then that value. So I need this for cross-site request forgery protection. Hit send, and that should have solved the lab, basically. Yes. So sorry about the little hiccups, but this is out of my control at the moment with the upgrade they're performing at the Web Security Academy. But I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the HTTP host header attack section, and today we are looking at another server-side request forgery, SSRF, via flawed request parsing. So once again, there's a vulnerability in the routing-based SSRF, or it enables routing-based SSRF, and our goal is to reach a secure internal admin panel and then delete the user Carlos. All we know is that it's located in this range 192.168.0.0/24. Let's head over to our lab and let's take a look what's actually happening here. So let's refresh the page first and then let's send this main request over. So if I start playing with the host header, I say now instead of .net, .ne, I will get an error, right? So basically the host header seems to be checked, and so I cannot mingle with it. But something else I could try is maybe I can get a GET request to the full URL. Okay, sorry, that was the wrong payload. I'm going to grab the URL here, and then I try to put that in instead, right? Something like this. And hey, that gives me a 200. That's strange. The next test I want to do is I want to replace the host header with a Burp collaborator payload and then hit send and check my collaborator. And you can clearly see I am able to now modify my host header. So here's our latest collaborator interaction. So this is interesting. With that in mind, I will send this over to Intruder. And in Intruder, I will now brute force the host header with the range I've been given, 192.168.0.0, and I'm interested in the last octet of my IP address. So I will brute force this. I need to ensure that I do not update the host header to match the target. I untick this because I want to brute force that specific host or those specific hosts effectively. And then I simply select numbers as payloads from 1 to 255 with a step of 1. And then I hit start the attack. And I ignore this warning. And what should be happening is my my brute force attack should begin shortly. Let me refresh this page once again, and you can see it's running here. So I get a lot of 504s, but there's one which is request 12, which was 302. So this is probably the admin panel at the .12 IP address. So let's send this over to Repeater to start playing with it. So if I now say /admin here, see what's going to happen. And I don't get an output yet. Let's try this again. And I can currently not get to the admin panel. So let's just try this again, whether I can even see anything. Let me refresh the page. Okay, and let's try that again. And I'm currently not getting any response here for some reason. Here I had the response to 302 to the /admin, so this looked good. Let's try this again. Let's send it again to the repeater. Or maybe I can open this in show response in browser. Let's check that first. Not found. Yeah, of course, because it doesn't take the host header into account here. Let's send it over to repeater once more. And no, this again doesn't work. So let me rerun the attack one more time. The problem with Portsrigger Labs at the moment is that they have changed from HTTP version 1.1 over to version 2, and that broke a lot of the web functionality. And unfortunately, this may be the case here. So let's rerun this again. Let's rerun this, the same attack we have just done earlier. And we will then see what's happening here. So let's refresh the page one more time. And then we should be able to get our payload here at the .12. Yeah, it's still the .12. It hasn't changed. Let's send this to repeater. And let's see if we can actually get to this. No, we cannot. So let's change the HTTP method to 1.1 instead. And then it works. Yeah, this is a bit annoying at the moment because of the changes they made. So they broke a lot of the lab functionality. Apologies for that. But yeah, so now I can actually try to get to the admin panel. And that works, right? As you can see here, I can now render this, and now I can input the username. So one thing which is important, so the delete endpoint is at /delete as in the previous labs. Username equals Carlos, which we want to delete. We sent this, but it says we have a missing CSRF parameter. So let's head back to admin and let's look for CSRF, right? Like CSRF, and here's the CSRF parameter. And I'm going to punch in delete and then question mark username. So I have username parameter equals Carlos and our CSRF, sorry, and CSRF equals. Okay, and then now hit send, and that gives you a 302. That looks good. So let's just verify on the admin interface once more. And we should have been able to, yeah, we have solved the lab and we have deleted the user Carlos. Hope that makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the HTTP host header attack section, and today's lab is host validation bypass via a connection state attack. So once again, the lab is vulnerable to routing-based SSRF via the host header. But initially, it seems that the front-end server may be more robust in terms of validation of the host header. However, there is a flawed assumption as well about all the requests on a connection based on the first request it receives. So I will show you this, like if it receives the first request to be something, and then it will assume that the subsequent requests behave in a certain way as well. Okay, so what we need to do is we need to access an admin panel located at this IP address /admin, and then delete the user Carlos. So let's get started. First and foremost, let's reload the page, and then we send this first get request, we send this over to repeater. Now let me also do something. Let's change the protocol to HTTP 1.1 because Portswigger has problems at the moment with their migration to version 2. So first test I'm going to do is I change the path to admin, right? And then I see what happens, and I get a 4 not found. So obviously there is no admin panel on this specific host. So what happens if I actually change the host header and say I want to go to 192.168.0.1 /admin? Let's see if this works. And it says like no, and I'm actually getting redirected to the home page. So that didn't work. So let me basically duplicate this real quick. So sorry, this was my bad. I didn't want to put the Burp collaborator payload in there. Let's just try this again. Okay, so let's duplicate this request, send it to repeater. So now we have 2 requests. And so in the first one, we are changing the path back to the normal /, and we also changed the host header back to the host header of the real machine, right? Like of the main application. So this is what we're doing here. Okay, I hope you follow so far, but now what we're going to do is we create something called a tab group. So we are creating a group where we group both of these requests together. And we say create, right? And what I also do here is I will say send the connection to keep alive. And if I now send this request, so I do have this option here, you can send these requests in sequence, a single connection. That's what I want to do. And then I want to see what's the outcome of this. So if I send this, I get a 200 OK because I'm going like in my first request in this connection stream. First request is going over to our main page, right? So this is, I'm not accessing anything forbidden. I'm going to the right host, but the subsequent one is actually going to the admin panel. It's going to the admin panel and it's basically going to 192.168.0.1. And if I render this, you can see that my second request, but only if you send this as a group, will be able to access it, right? Because the verification takes place only on the first request in the connection stream. And because this is going to the correct host and it's not accessing anything illegal and I'm not tampering with the host, it will then assume that all the subsequent requests in that group are basically the same. So now that we have been able to access this, now let's go and type in admin/delete username equals Carlos, and probably we need a CSRF token as well, right? Like, because we probably don't have the correct CSRF token. So let's send this first and see what's the outcome. Yes. So it basically says like, hey, I need the CSRF token. So let me take this back once again and let's reload the admin page. And then I look for CSRF in here, and there's my CSRF token. So I need that as well. I will then here say delete username equals Carlos and CSRF equals the CSRF token. Let's send this. And that looks a lot better. And I have solved my lab effectively because I was now able to delete the user Carlos. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin and we are in the OAuth lab section. Today's lab is forced OAuth profile linking. So this lab gives you the option to attach a social media profile to your account, and then you can basically log in through OAuth instead of normal username and password. However, there's a secure implementation in that specific flow that allows you basically to obtain other users' accounts or to hijack other users' accounts. So what we need to do is we need to craft an exploit whereby we attach our own social media profile to the admin user account on the blog, right? And then we access the admin panel, we delete Carlos. And for that to happen, first and foremost, we need to start off with logging in as a regular user, right? So to see how this whole functionality works. So I log in via Wiener and Peter, nothing spectacular. So let's head over to Burp. So you see here, just the login, post request, Wiener Peter, and then I get to my account. So nothing really out of the ordinary, not OAuth flow related at all. So now I have the option to say attach a social media profile. So I hit attach a social media profile, and now it says like you have successfully linked your social media account. So I wasn't prompted for username and password and stuff because I was already logged in. I already did this before, prior to the lab, but one thing you can see here is basically there is a code being passed to the OAuth linking, and that's a code which is basically being passed on, and that completes the linking process. Like if you render this here, you get the message you have successfully linked your account. So one thing I immediately see here, there's no state parameter or anything like this. So this is dangerous because a state parameter means like it's like a CSRF protection, right? So that the person who initiates the flow also needs to be the person who does the linking, right? And so that no one can take this over, that I cannot generate my own code and then have someone actually attach my profile to their account and then I can take the account over. And that's exactly what we are going to do because we have a missing state parameter, so we don't have CSRF protection in that scenario. So let's just do this again for you to see. So let's clear the burp history once more, and then we go through this again. So I can click here, attach social profile, boom, And once I've attached this, you can see there is another linking code generated. Now, this is no good right now because that linking code is already expired because it was used in this function, and then I cannot reuse it for someone else. So what I need to do here is basically I need to intercept in Burp, and let me go here to the proxy intercept, turn the intercept functionality on. I attach, now, well, not yet. So turn intercept off again. I attach the social media profile. Now I turn intercept on. I attach the social media profile, and that is basically the initial request or authentication request with my client ID. The redirect URI goes to this OAuth linking. And this is the one you see in the next step, right? Response type code, the scope, and no state parameter whatsoever. Let's forward this. This is fine. This is the one I'm interested in because this is now basically the code, right, which has been generated. And what I'm going to do now is I say copy URL, and I copy this URL out here first, and then I drop this request. It's important that I drop it because if I would not drop it, it would have been used already, right? So going back here, and now I say log out. I simply go to log out. I'm logged out now. Now that I have this code, the code is still good, right? Is effectively I'm going to take my URL here, and I create an iframe. So this is the URL I just generated, and I create an iframe, and in the iframe, I basically just put that URL. So what that means, if this is being loaded, my social media profile with my code is being linked to the administrator, and that should then enable me to access the administrator account. So let's take this, let's head over to our exploit server. Let's head over to our exploit server, let's put it in the body, let's store it, and let's deliver it to the victim, which is the administrator, right? Administrator loads this, la 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 la. I go back to my page, to my account, and then I say login via social media. And now, because the administrator linked my profile to his account, I have now successfully taken over because I now logged in with social media, but the profile is basically attached to the administrator account. And you see, I successfully was able to go to the administrator account. Now, if I click on admin panel and delete Carlos, that basically solves the lab. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the OAuth section, and today's lab is OAuth account hijacking via redirect URI. So if you remember in previous sections, I always told you, like, even though an open redirect on its own is a low vulnerability, but always hang on to them, always keep them, always keep in mind that you may be able to escalate it to steal tokens, to perform XSS, to perform SSRF and whatnot. And this lab is exactly one of these scenarios. So you have an OAuth service, once again, where users can log in with their own social media account, but there's a misconfiguration which basically allows you to leak authorization codes out to a third-party server, in this case mine. And then once I have this authorization code, I can complete the flow, and then I can log in as the admin user and delete Carlos. Okay, so let's take a look how this looks like. Let's go over to my account, and you can see that I'm right logged in. Let's log out again, and let's do this again. So we are redirecting you to log in via social media and blah, blah, blah. And because I've done this before, I'm already logged in. Okay, so I'm logged into my account, and there's a couple of interesting things happening, particularly these two. So the first call is like a GET request to the authorization server, effectively, right? With the client ID, with the redirect URI, along with the response type code. So this is the request for code, basically, right? And what's happening here is, the problem is that this redirect URI is user controllable. So instead of calling the OAuth callback endpoint, I want to call my attack server in order to leak that code. And then I want to do this OAuth callback myself, basically with the leak code of the administrator in order to take over their account. So that's the goal. So first of all, let me copy this out as I copy this as URL because it pretty much has all data I need. And let's come here, put this in there. So first of all, I need to create an iframe because the user, my victim, will be loading this iframe and then this URL is basically being called. So first of all, I need to have this authorization server URL, which is basically this one here. Okay, I need to put that in. Okay, that looks good. Then the client ID, which is this one here. So I need to put the client ID in there. This is all not special yet, but now comes the interesting portion is basically I need to put my exploit server in there instead of, like in a normal redirect, it's redirecting to the auth callback endpoint, but I want to steal the code or yes. So I basically will delete this and I will put my exploit server in here. So I head over to my exploit server and I basically copy this and put it in here. And then we have response type equals code and scope, OpenID, profile emails. That's all good, right? So we don't need this one anymore. So this is now my iframe. And what happens if the administrator now gets social engineered and clicks on the link, what it will actually do is it will leak the administrator's access code to me, and then I can use this to complete the login via social media. So let's try this out. Let's first of all put this in here and store it. And then we are delivering this over to the victim, in this case, the administrator. So nothing seen as yet, but if we go to the access log, we will see, hey, here is a victim request, the request the victim made. Let me copy this. Okay, and there is an access code. And this access code is the one I was looking for because now I can actually call the OAuth callback endpoint. So I just put myself here in the middle, if you see what I'm doing. And now I take this code and I will also obviously need to make sure that this is the right URL, and which is this one. And now I need to make sure I'm logged out of my account. So because I'm still logged in as me, right? So as Wiener, so I log out. And now I call this URL with the code. And then let's see what happens. And I have completed the social media login flow with the stolen code from Carlos, from the administrator. I hit continue, and then I have my admin panel and can delete other users. Okay, so this solves the lab, and I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the OAuth section, and today's lab is stealing OAuth access tokens via an open redirect. So this lab is different than the one before. The one before we had a redirect URI parameter, which we were able to control and basically set this to an external server in order to facilitate a leak. This time it's actually being checked that it has to go to that local URL. However, there is another vulnerability in there, which allows us to then facilitate an open redirect to our external server. Okay, so let's come over here and let's log in via the OAuth flow, and then let's take a look in Burp what actually happens. So you can see this is like a standard OAuth flow whereby we send the auth request out with our client ID, the redirect URI. That's the one I was talking about. So if you would change that, and I'm not doing this here, but if I would say HTTPS, google.com and stuff, it would not take it, right? So because it's checking that it can only go to this specific URI. However, if I come over here and take a look at certain other parameters. So if I do a few posts on this post ID, I see something interesting down here because there is like a path parameter which may be controllable by me. And I actually wanna verify this. And if this is controllable, I can I can change the URI parameter to that URL which you show here, but then in the path, I actually will redirect out to my malicious server, right? So let's check this. And for that purpose, we are going to log out first, and then we are going to proxy the functionality. So we put the intercept to on, and we hit our account. So let's forward this one. And that's a social login. We can forward that as well. So let's see what's happening. This is the interesting part, right? So what happens if I now go in OAuth callback here? So I cannot change this URI. You agree, right? Like you could try it, but it doesn't work, right? But what if I put in something like this, for example? So I'm saying, no, sorry, for /.dot, and then I say post, and then I put another parameter, post ID equals 1 or something like this, right? So I change this, and now I forward this on, and I forward it on, and you see, you already seen it in the next request, but basically it's redirecting me to my blog post, which I specified. So this is all I need to know now, and now I can actually launch a successful attack in that respect. So I'm able to control this path parameter, okay? So with that in mind, I will be able to craft an exploit and then deliver this exploit over to the victim. So I have prepared this here. So first and foremost, we need to populate the right data. So we first of all need the OAuth URL, so which is this one here, right? So this is the authorization server, basically. So I'm taking, so this is what the victim is going to visit, right? Like this is, let me see if this is correct. It should be OAuth dash, yes, so I forgot that, OAuth dash. And then this is the OAuth server, right? Like the authorization server where we are going to. Then the next thing we need is the client secret. So the client secret can be found here. This is the client secret basically. And I put the lab client secret, sorry, not the secret, the client ID. And then the redirect URI is basically my own application or the application I'm targeting here. So let's put that in as well, which it comes in here. And then you can see we make this call to the OAuth callback, which we have just done, by the way. So I've shown you that this is successful, but we direct it over to a blog post. But this time around, we don't want to redirect to a blog post. We actually want to take this to the exploit server because we control the exploit server. And that's an external domain, right? Like this is external, but we are controlling this. And this, the purpose for this is basically that I want to leak out the token to that exploit server. So something like this. And then the rest we can just leave as it is. And so what's happening here in this little script is when the victim loads this JavaScript, the victim will first of all be redirected to, or the victim will be called with this URL. So this is the malicious URL basically, which has this embedded payload to redirect out to my exploit server. And then in the second step, it's basically extracting the hash fragment and log it to the server. And the hash fragment, in this case, is the access token, right? So let's do this. Let's copy this exploit, and let's try it out first on ourselves. So let's see how this works. I do a view exploit, and you see that the redirect took place, and it's basically appending the access token to the log. So let's go to the log, and you can see here, this is the access token, but this was from my IP address. So I have successfully stolen this access token. So this proves that my exploit is working. But I'm going back to the exploit server now, and now I'm actually, let's make sure I'm logged out here. Let me log out. Or I was already logged out, that's fine. Let's log out again. My account, log out. And now we are actually going to deliver this to the victim. Now we are delivering this to Carlos, or administrator, or whoever it is. And when the victim plays this, then basically they will be called with this URL, and then there is the extraction functionality taking place right afterwards. So it's two functions in one. Let's go over to the access log, and then we see, hey, here we were successfully able to steal the access token from our victim. Let's head over to the decoder, put it into the decoder, say decode URL, and then you can see this is the access token here. So I want to copy this access token out, and let's copy this. And then basically in my Burp history, I should be seeing like a request somewhere like this one, right? The get me is effectively extracting the information. So this was my own get me request where I can see the API key. So I want to take this over, and I basically want to call this this functionality, right? So let's head over. And you can see here, so this is still Wiener Peter. This is fine, but because I have the bearer access token in there from Wiener Peter. So let me replace this by the token I've just stolen, and I hit send, and now I have it was actually the administrator account which was compromised. I take this API key and I put it in here as a solution, and that should solve my lab. Okay, I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the OAuth section, and today's lab is SSRF via OpenID dynamic client registration. So this lab is different than the previous ones because we are dealing with OpenID. So OpenID is like another specification put on top of the OAuth framework, primarily used for authentication, because traditionally OAuth is an authorization framework. But OpenID is heavily used to authenticate clients. So the problem in this particular case is that when you want to use OpenID, you need to register yourself as a client. And if there is no authentication on doing so, then you can basically register yourself, and this may have adverse effects on the situation overall. So let's get started. Well, our task here basically is to facilitate an SSRF attack to this specific, so this is like on the cloud on AWS, but we want to actually make a call to this specific path in order to extract admin credentials and stealing the secret key, right? So we have our own credentials here, and I've prepared a couple of things so to make this easy to follow. So the first thing is our base URL, right? So this is our base URL and nothing special here. But what I always check when it comes to OpenID is something like this, right? Like, so we have an authorization server, which you can see in Burp. Then we make numerous calls to our authorization server. And there is something called, like very often you can find this .well-known OpenID configuration. This one here, actually, this is written correctly, and that gives you information. So let's browse through this because it often contains useful information around the setup. And one thing we immediately notice here is there is something called a registration endpoint. This is basically where you can register your application with the OpenID specification. And if I click on this, I get an error message basically because it says like, hey, the get method is not allowed, right? But maybe the post method is allowed. So if we head over here and we want to register our own application, which we call martin123.com, and I hit send, I can see I get a message called 201 created. Now this is interesting because I should not be able to do this because I'm unauthenticated at this point in time, and so I'm able to basically facilitate my own creations here, and this is the first vulnerability. And so you will also notice if you go through. If you go back here, you will also notice a couple of calls which are being made. Like for example, there is a client call with my client ID made to the logo. So this indicates to me that there is a URL being called or something like this, right? And if we head back and look for something here called logo, so there's a logo redirect URIs, right? And they are not set at the moment. And so this is interesting. So what happens if I start setting my own logo URI in that request? whereby I'm going to register an application and I set a logo URI. So this then basically means it fetches that picture, or it's supposed to fetch that picture and register that application for me, right? So this is what I've just done. But what happens if I put something like this in, right? So I'm putting something like this in, and let me go through it, what it actually means. So I'm registering martin999.com, and I set the logo URI, but instead of setting it to a picture or to a graphic image to load, I'm using it to attempt an SSRF attack from the application to an internal well-known path where the admin credentials on AWS are usually located. So let me do this. So let me send this over, and this was successful. And so what immediately stands out is basically now I have the, so if I look at your logo once again, and let's not log out, logo URI. So now I have the logo URI set. You can see this here, right? And so what should happen now, if I call my client ID, instead of loading the image, it may load this information for me, right? So I have a client ID. I received a new client ID. Now, if, as you remember earlier, we are using that client ID to load the logo. Like this is the call. This is the get call, client ID, and logo. What if I replace this for this new client ID for my newly generated asset? And then I hit send, and look at this. What I'm getting is basically the secret access key. So I was successfully able to launch an SSRF attack and basically display information and not the logo itself, right? So I get a lot of information, including the secret access key. And then I head over to my application and I simply submit this as the solution, which should solve the lab. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the file upload vulnerability section, and today's lab is web shell upload via path traversal. So this lab once again has an upload functionality where I can change my avatar, and there is a vulnerability or multiple vulnerabilities associated with that. First of all, it doesn't check the extension type, like I can upload a PHP, even though I'm supposed to upload a graphic image or something. And secondly, there is an issue with path traversal. And we are going to head over to our application right now, right? And first and foremost, let me show you the code. So this is basically a small snippet of PHP code, which simply outputs the contents of home Carlos secret. And that's what the lab is asking us to, that we extract that information, right? So I have saved this as a PHP file, nothing special so far. So let's head over and log into our application here, right? And you can see we have this upload functionality. So let's browse there and let's upload that exploit.php. This is similar to one of the previous labs, and it says like, hey, exploit.php has been uploaded. Great. So let's go back to my account and let's open this image in a new tab. And you see nothing really is happening here, right? Like, so there is, it's not extracting the information as I want it to extract, right? So this is not good. Basically, or in reality, what it actually did here, if you look at this, so when I made a GET request, it only gives me the PHP content of the file, so the actual PHP code, but it doesn't run it. So this means that this directory where it's being uploaded into is not executing the PHP code. So what can I do? Well, first of all, let's send that post request to repeater, and you can see we were uploading this as exploit.php. So I'm wondering that maybe this specific directory is protected, that it doesn't execute PHP file for files within, right? So what happens if I actually do something like this, if I do a path traversal sequence, and then I try to upload it again, right? So let's do this. And now it says basically the file avatars exploit.php has been uploaded. So this is probably again a problem because it looks like it has stripped that path traversal sequence. And let me just confirm this real quick. And it indeed has, right? So it has stripped that path traversal sequence out. So there's some kind of filter on there. So I'm wondering if I take the forward slash, if I take that forward slash, put it into my decoder and actually encode that, do a URL encoding on this. So which is %2f, right? So I'm replacing that with %2f, try to upload it again. And now you see the message is different because now I was able to bypass this path traversal filter, and now it has been uploaded into the // directory exploit.php as the file, right? So let me refresh this here one more time. And now let me open this image in a new tab and see what happens. And basically, what if I now go to the browser and exchange that to a normal forward slash? And here we go. So basically, if I then call this, so you can see this here, right? So I can effectively extract the information. So I attempted a path traversal directory attack in order to write it into a directory, into another directory, whereby the PHP code is actually being executed and not just displayed over to the user. So if I submit this as a solution, that should solve my lab. Okay, that's it for today, and I see you in the next video. Hey guys, this is Martin. We are in the file upload vulnerability section, and today's lab is web shell upload via extension blacklist bypass. So this particular application is vulnerable once more, but this time around it's actually filtering PHP extensions, so I cannot just upload my exploit or use a path traversal sequence like in the previous labs. So it's actually blocking the PHP extension. However, there is a file called htaccess, and that htaccess file of the Apache web server is writable from the outside. So what I can do is I can specify another type of extension and which I associate with PHP so that the code will be executed, and I give this extension a random name, and then I can upload my file, my PHP file with that extension, and it should work. Sounds all super complicated, but it's actually really easy in reality. So let's just head over here, log in with Wiener and Peter, and we are browsing here to our exploit.php file, which is the same as before, simple PHP file to read out contents of a file on the application server. So let's do that. Let's hit upload, and we get an error message. As I explained earlier, so it's basically not allowing me to do that. So let's send this twice to the repeater, first and foremost. So let's go to request number 1. And now we know that it doesn't allow PHP. So, but the htaccess, so htaccess is writable, right? And now I delete my PHP payload, but I add a specific instruction which is called add type, right? And then application. So that basically means associate that extension with PHP, which is the syntax like this. And then I call this .martin, basically, right? So I'm now writing an instruction into the htaccess file. And let me send this, see what happens. And this has been successfully uploaded. So this looks good, right? And basically now I head over to the other request. And all I need to do now is basically rename the exploit from PHP to Martin. So because of that association I've created here, I am now uploading the file with the file type called Martin, and see if this works. And it says like, hey, the exploit.martin has been successfully uploaded. So let's head back to our account and let's load this image in a new window, and there you go, right? So basically it's now loading exploit.martin, and it has successfully executed PHP code, which allowed me to extract those contents of that file, and that basically solves my lab. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin. We are in the file upload vulnerability section, and today's lab is web shell upload via obfuscated file extension. So once again, the application is vulnerable but it is filtering and it's trying to prevent me from uploading PHP files, but this can be once again bypassed. So let's head over to our application. Let's log in with our credentials, and you will see that we have the avatar upload functionality as before. My little snippet is basically this one here. Once again, simple PHP code to read out the contents of the file, right? So I'm uploading this here, or I'm trying to upload it, and I hit upload, and I get an error message. And this time it says, sorry, only JPEG and PNG files are allowed. Okay, so it did not work, right? So it prevented me from doing this. Let's head over to Burp. Let's take a look at my post request, send it to repeater. And you can see that basically it says exploit.php. So it's really checking on this extension, right? And if you remember from the path traversal directory section, there is sometimes the possibility to introduce a null byte, right? And the null byte effectively makes the code stop at that null byte and ignore everything which is coming afterwards. So if I put in exploit.php and then a null byte, the application might read it as .php and ignores everything else, but I put in like a .jpeg here, and the reason why I'm doing this is that the filter might say, hey, it's ending in .jpeg, so it must be good, but the application will read the null byte and will say like it's a PHP file. That's the logic behind that. So let me send this, and the exploit has been successfully uploaded. So that looks good. Let's come over here. Let's refresh. And then let's open this image in a new tab, and it says not found, right? And this is because the browser has problems displaying this because we still have this extension on. But if I remove this extension, I am able to actually get my PHP code executed, and I get the solution of that specific file. I hope this makes sense, and I'm going to see you in the next lab. Hey guys, this is Martin. We are in the file upload vulnerability section, and today's lab is remote code execution, RCE via polyglot web shell upload. So this lab once again contains a vulnerable image upload function, and basically it's checking for certain things. So for example, it's checking that the content type is actually like a JPEG, right? But we may be able to introduce JPEG or code into our JPEG, so PHP code into the JPEG. So to understand this better, basically, you can head over to payload all the things into the upload insecure file section, and there's a lot of good descriptions and things like that on how this works. So this is quite interesting. And then also on hack tricks, on the book.hacktricks.xyz, it explains like what polyglot files are. They are often used like to bypass protections. So for example, if the content type is being checked that it has to be a JPEG or something, then the magic number or the magic byte will basically match a JPEG, but then within that we embed PHP code and other things, right? So this is just like, there's another good write-up here on Medium around polyglot files, hackers' best friends, and stuff like that, right? So let's head over to the application, and then you will see immediately when we log in that we have our upload functionality. And so let's kick this off by, let me upload a picture of my wife. So this one here, I hope she doesn't mind. I'm heading over and I'm just uploading this file as my avatar, right? So let's put this up. And I received an error. It obviously does not like it. So that is funny. Let's try this again. Okay, it has been uploaded now, and it should show as the avatar. Yeah, it does. So this is normal functionality, and if you try now to introduce a PHP file or something, it will not allow that because it's checking certain parameters. So if we head back to our post request, you can see like this scrambled stuff here, right? And this is also like from a server side perspective, they're using this. It's called like the magic byte, and every file type has a different one. Like PNG has a different one, JPEG has a different one. And if it's only looking at that basically, and then it says like, hey, if I see that in the code or in the upload, then it must be a JPEG file, right? And this is exactly where Polyglot comes into play. So what I've prepared here is there's a tool called EXIF tool, which you can usually use like to read out GPS information, camera information, but you can also put in comments and cross-site scripting payloads sometimes and stuff like that. So what I'm using the EXIF tool for is simply to put a comment in, but it's not a real comment. I could put in here like normally what is the expected behavior is I would say like, hey, this is my wife on vacation, but I'm actually putting PHP code in here, right? And the PHP code basically instructs to read out the contents of the file home Carlos secret. And then it takes basically my input file and it creates a polyglot.php. So this is basically what I'm going to run locally here, right? So I put this in and I run this tool. And now it says one image file created. If I do an ls, I see, hey, here's my polyglot.php. Now let me upload this one, right? So I'm going back to browse and I upload the polyglot.php, hit upload. It's going to upload this. And same as before, it doesn't want to do it on the first go. Let's try it again. All right, now it has been uploaded successfully. Let's just take a quick look how this looks like. And you will instantly see here that it looks like the same signature, right? So this is where the trick comes in. So if the application is only checking on that magic byte, basically, you can bypass it, right? So I have uploaded it successfully. Let's go to my account. And now I will open this as a new image. Let's take a look here. And it's loading this. And now you see, hey, there's a lot of scrambled information. But if you remember from my command here, which I issued earlier, there is like something called start and end. So somewhere between the keyword start and end in the output, there must be my solution. So if I look here, here is start and here's end. So right in the middle, this should be the file content of the output of the home Carlos secret file. And let's submit this as a solution and that solves the lab. I hope this makes sense and I see you in the next video. Hey guys, this is Martin. We are in the chart JSON Web Token attack section and today's lab is chart authentication bypass via weak signing key. So if you remember that the chart tokens have like three portions. They have the header, they have the payload, and they have the signature piece. And the signature piece is kind of like a verification that it's authentic. And if that's not the case, then, well, this is problematic. And we have seen this in the previous labs. But this time the signature is being checked, but it uses a very weak signing key. So let's get started and try to brute force this. So first of all, let's log into our account. And then, by the way, something I'm going to show you right away is once you're logged in, if you go to Burp, you will see that the color is changing from blue to green. That's because I have chart edited keys installed and it's highlighting everything in green, which contains a chart token, which is quite useful. So for example, here the chart token is being set. And then here the chart token is being used in my first request to my account. So let's send this over to Repeater first of all, and then let's try to access the admin panel. So that's our job once again, reaching the admin panel, become admin, and then delete the user Carlos. But it doesn't work, obviously, because the chart token does not permit that. So let's copy this out first of all. And remember, there is a website called chart.io. So we put it in here, and then we get interesting information. So first of all, we get the header, and then we also see the algorithm, which is HS256. So which immediately indicates to me it's a pre-share key. So there's just one key. It's not RSA or RS256 or something where you have a public and a private key. With HS, that simply means there's one shared secret. That's a problem on its own, in my opinion, because if this key gets leaked or into the wrong hands, then basically all your JSON Web Tokens are compromised. But that's another topic. So basically, if I make a change here, if I would put in administrator, then my JSON web token is being changed and blah, blah, blah. If I try it, it doesn't work because the signature requires a secret key to sign it. And the server is verifying this. So what can we do? Well, basically, there's a lot of tools out there. One is called the Jaw tool. There's JawCat and so many different ones. But you can basically feed a brute force word list against the JSON web token, and then it tries to brute force it and see what is the key. So you might be able to do this. So let's start off. I already prepared like the command. I just need to replace the JSON web token. So that's the JSON web token here. And I just need to put in my JSON web token, which is basically, I could have taken this, but let's take it from Burp. Okay, and then let's put it in here. So what this does is like Python 3, run the jaw tool, and then you just put the JSON web token in, the whole thing, right? And then -C is for crack, and -D, you give it a word list, right? And we take this and we put it into Linux, Kali Linux in this case, hit run, and it was able to brute force it because the secret key is secret 1, right? It's a very weak key. It was able to brute force this. So I now can head over to Jaw tool once more, and I can change the username to administrator, and I need to now sign with secret 1. So now I have a JSON web token which has been signed correctly, and that should be accepted by the server. So let's try this out. Let's head over. Let's delete our JSON web token here, and let's send it, and we get a 200 OK. So which means we are successfully able to get to the admin panel. And now all which is left to do is basically we need to delete the user Carlos. So we need the /delete and then the parameter username equals Carlos, and we append this here, and then we hit send, and we get a 302, which is a good indication, but let's verify by looking at the admin once more, and that user should have been deleted and the lab has been solved. All right, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the chart attack section, JSON web token, and today's lab is chart authentication bypass via the JWK header, or via an injection through that header. So basically, there's a flawed implementation once again in the lab. Basically, those JSON web keys are basically sometimes used. You can embed them in your request to instruct the server which key to use to verify the authenticity of your token. Now, it obviously should only trusted resources, right? And not you, so that you basically can self-sign a key, and or you can generate a key pair and tell this server, hey, use that key pair please to verify me. And that's exactly the vulnerability in this lab. So let's head over, let's log in first, right? So Vina and Peter, and then let's head over to Burp. And in Burp we see, hey, it's in green, so there's a JSON web token, as I explained this in the last section. Let's send it over, and if I change this to admin, right, I should not be able to get to it. Yeah, again, unauthorized effectively because I'm Vina and I'm not an admin. Okay, so let's get started here, like how you exploit the JSON web key vulnerability or how you test for it. First and foremost, you need an extension called the chart editor keys, which is a Burp extension, and then that Burp extension allows you to do various things. So what we're going to do is we're going to create a new RSA key. So a new key pair, public-private key pair, basically, and we simply hit generate, right? And we select the JWK format. So that's it. Then you have your key generated in here. You head back to Repeater, you go to the JSON web token option, and then you can basically see here, first of all, we are going to change our username to administrator. But then down here, you have something called attack. And then if you go and select embedded JWK, so then effectively you're sending the public key of your key pair to the server and instruct the server, hey, please verify my JSON web token with that key. And if there is no sanitization and it's not checking for trusted resources, this may work. So I do this, and then you can instantly see here in the header that it added the JSON web key information in there, right? And all which is left to do now is I have to hit send, and now I get a 200. See, like now I'm able to actually access the administrator panel. So my attack worked. And what I want to do now is basically to delete the username Carlos. So I find Carlos here, and then I need to find the path, like the instruction on how to delete it with the delete path and the parameter attached as before. We send this, we get a 302 found, that looks good. Verify on admin that it's actually gone, and it is, and this solves our lab. I hope this makes sense, and I see you in the next one. Hey guys, this is Martin again. We are in the JSON web token attack section, and basically today our lab is short authentication bypass via something called a JKU header injection. So if you remember from the last lab, we used JWK header parameter, whereby we basically embedded our public keys for verification. This time around, we use another header called JKU, or also known as JWK set URL header, whereby we basically instruct to go to a third party, a server we control, and then the keys are being placed there, and then the keys are being verified basically from a server I control. And they're obviously my keys because I will generate them first. Okay, so let's take a look how this works. Let's head over and let's log in. Here with Rina and Peter, we get our JSON web token, as you can see this here. And we send this to Repeater to start playing with it. And let me change it to admin. And what happens is unauthorized because I have no admin privileges as Rina and Peter. So first thing we have to do is we head over to JWT editor keys. We create a new RSA key. Okay, we choose the JW key format, generate it, and copy the values out basically, right? And then we hit OK. We put the values in a text editor, and then on my exploit server, I've prepared like a little skeleton, which is like a classic one, how this looks like if you host your own keys, basically. And I need to make a couple of changes here. First of all, I have generated a new key pair, so I need the key ID. I need to copy the key ID and replace this here with the correct key ID. Right, this is step number one. And then step number two is basically I need this N value, and I need to copy this N value out because that's specific to my newly generated key pair here as well. So I just need to come in here and then basically put it in there. I hit store, and that's pretty much everything needed on the server side, right? So requests will come in, keys will be verified, and I should be authenticated because I obviously generated these keys myself. So let's head back over to the repeater, and then let's go to JSON web token. So one thing I need to make a couple of changes here. So the first thing is the KID value, the key ID value, obviously doesn't match the default one. So I need to instruct the correct KID value, which I put in here, right? So I just delete this. And now comes actually the thing that I need this JKU header, right? Like what I mentioned before. So it's going out to an external URL basically in order to do the verification there. And that's my exploit server URL. So if I just copy this out and I head over here, put it in there, that looks good. And then finally, I need to obviously say administrator for my account takeover. And then I need to sign this, and I need to select the keys, which I've just generated, and it's RS256, and don't modify the header. And hit enter and go back to raw. If everything goes to plan, I should get a 200, which I do. So this was successfully working. So I now just have to delete the user Carlos, and I need to find, as in the previous labs, the delete command in there to actually delete the user Carlos. Let's do this. let's send it. I got a 302, that looks good. And if I verify this on the admin, it should be gone and the lab should be solved. Yes. Okay, so that's another lab. I hope this makes sense, and I see you in the next one. Hey guys, this is Martin. We are in the chart attack section, and today's lab is chart authentication bypass via kit header path traversal. So a couple of things first is that servers often contain like multiple keys, right? Like for signing basically, and then you need to instruct them which key they use for signature verification. The problem in the framework is that there is no specific kit specification, like how a kit should look like what kind of format that specific cryptographic key shall have, right? And this is like, for example, if they're using symmetric keys to sign the tokens, then basically you can, if you can achieve a path traversal attack, you can basically point the kit value to a predictable static file, right? Like, and then you can basically create your own symmetric key where you basically have similar content. And in order to make more sense out of this, we go through this now step by step in the lab. But this is another common attack against JSON Web Tokens. So let's head over first and let's log in. And so we simply log in with our credentials as before. We have been given that, and we get a JSON Web Token. I use this JSON Web Token to try to access the admin portion, and it's probably going to be failing. So first things first, I see that it's signed with an HS256. So it's not an RS256 like in the previous labs. It's an HS256, which means it uses a single pre-shared key. So there's no public-private key involved in this one. It's a static pre-shared key effectively. Okay, so now how can I exploit this, or how I'm trying to exploit this? So let me head over to my chart editor keys. But first of all, I'm going to create a symmetric key this time around, and I hit generate. And what you see in there is basically there's something called the K value. Now, if I set this K value to 0, and I need to basically base 64 encode this in order for this to work. So the base 64 equivalent of a null byte basically is AA and then equals. Okay, so I set this to a null byte. So that means I now just need to point the chart verification to something on the file system which also returns nothing or a null byte effectively. I hope this makes sense so far. So I'm simply doing this, right? Like I'm changing that K value to a null byte. And then I hit enter. So I head over and I start playing with this. So first of all, of course, I need to change it to administrator, right? And then the kit value itself. So the kit value here in this particular case is vulnerable to something called directory traversal. So what happens if I put in ... like a couple of sequences like this, right? And then I say, I'm pointing this to device nil. And on Linux file systems, this is basically a blank file which equals like, or which has the same contents like a null byte, basically. So I'm attempting this. So all I have to do now is I have to sign my token with that key I've just generated. So I hit sign. I used that algorithm. So this is a symmetric algorithm. As you can see here, this is the signing key. Don't modify the header and go back to raw. And now you can actually see that I'm able to access the administrator panel successfully. So all that's left to do now is I need to delete the user colors as in the previous labs. I simply need to get out the path for the deletion command. I do it like this. I get a 302 found, and I head back to admin and just to verify if it has actually been deleted, and it has been deleted and the lab has been solved. I hope this makes sense, and I see you in the next video. Hey guys, this is Martin speaking, and in today's lab we will take a look at discovering vulnerabilities quickly with targeted scanning. So this is particularly important if you attempt to do the Burp Suite Certified Professional exam, or if you work in real world engagements. You need Burp Pro for this, right? The Burp scanner, but the Burp scanner can help you tremendously to find vulnerabilities much quicker than you could do by manual fiddling. So the problem is, at the end of the day, you will always find vulnerabilities, or most times, if you have enough time, but that's not realistic. Like whether you're working on a bug bounty program or whether you're working on a penetration test, you usually have some sort of limited time, right? Because you cannot hack 24/7 a day. And so this lab is basically designed to show you how to quickly identify things. So if we head over, you see there's a clock, a timer now. So we basically have 10 minutes to find something out. So first steps first is always analyze the website. So there's no login functionality or nothing visible. So let's click on one product, right? Let's click on the product, and then there's a check stock functionality. Similar what we have seen earlier in certain labs, like particularly around XXE and things. So I just checked the stock. I go over and take a look at this request, right? So this is the basically the request I've just sent, and it takes in a product ID and a store ID as input. But so I could now put payloads in and stuff like that and try it manually. But what I can do is I can right click a request and then say do active scan. And what that provokes is basically the Burp scanner is now just scanning this specific request. And that's incredibly useful, because if you have a large web application, sometimes this can take a significant amount of time if you scan across the whole application. Versus in this particular scenario, we are only now interested in scanning this specific functionality, right? And then if you head over to the dashboard, you can see that the scan is finished, which it shouldn't. This is funny. So let's retry this again. So let's go over and say do active scan. Maybe I hit passive scan before. I think I did. Yeah. So active scan. Here it's running now, and it's estimating the time remaining and things like that. So you can see as the requests which are being pushed out. And then you have here something called issue activity. And it's quite nice, because if something is found, so you see here already like input returned in response reflected. So you see the request which has been made, like here product ID, and then this was being reflected. So this could be something else, right? But immediately I get like a high alert here, right? And the high alert basically says like, hey, there's an out of band response. So there was an out of band response. So if you read through this, it indicates that there is a problem with the XML parsing of something called X-include, of the X-include definition. And you could also, like, it sent out something to the Burp collaborator and stuff. And so it quickly identified the problem here, right? So, but now if I want to exploit this, and my task is, I believe, it says you're supposed to read out the etc pass WD. But now I know that the problem is related to XML input parsing, and it's also related to X-include. I can head over to book.hacktricks.xyz, and if I take a look at X-include, right, so it's like a hidden XML surface which the scanner has identified. So I have a payload in here which I can copy out, and then I can see if this matches my specifications. So it looks like it does, because it already says product ID, and in the product ID comes my specific payload, which then instructs to read out the etc pass WD file and store ID equals 1. So I probably can take this one-to-one, because I believe they have actually taken this from the Burp folks. So let's just remove the whole thing, put it in. This looks pretty good. And let me send this over. And there you go. You actually get the results of your etc pass WD file. And that should have triggered my lab to stop. So you see, this took me like less than 4 minutes in total to uncover. And this is how you use the Burp scanner to discover vulnerabilities more quickly. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the prototype pollution section, and today's lab is DOM XSS via client-side prototype pollution. So in this particular lab, we have a DOM XSS vulnerability, which can be invoked via client-side prototype pollution. There is numerous ways to find these kind of vulnerabilities. In practice, you use something called DOM Invader, which is built into Burp. And then just in a nutshell, real quick, what is prototype pollution is basically a JavaScript vulnerability where an attacker can add properties, like random properties, to global object prototypes. And then they may be then inherited by user-defined objects. So that's it in a nutshell, but I recommend to read up the theoretical portions in Portsrigger as well to get a better understanding. So to do this today, we are using the Chromium built-in browser because that has basically the how you call it, the DOM invader, right? And the DOM invader you can find up here. And the first thing you're going to do is you select attack types, prototype pollution is on, and then you need to reload the page basically, right? So that's the first thing you're going to do, and let's do that. And then basically you can see here there's a red little pop-up which appeared, right? So now in order to play with DOM Invader, you have to go to inspect, and sorry, I don't think that was the right one. So it should be actually. You move over here to DOM Invader, and then in DOM Invader you see that there was a prototype pollution, or actually two prototype pollutions which have been found, and you can see the respective code here. So what we are going to do is we are going to do something called scan for gadgets, right? So this is basically DOM Invader is now scanning for gadgets, and then DOM Invader found one sync via prototype pollution. So once again, this is very much like the DOM section we have discussed in depth. You have something called syncs, and you have something called sources. And when a source is a user controllable input is being sent to an unsecure sync where you can execute code, you have a problem, right? So now let's head back over once again to our DOM invader. The DOM invader should have been done its job now. And it actually says like, hey, here is like a script tag, and basically I found my prototype pollution vulnerability. So if I hit exploit, you can basically see here is the prototype which is being injected, and then along with the data, which is a simple script alert. Don't worry about the percentage signs. This is just URL encoded, but this is like the easiest way to find these kind of flaws with DOM Invader. Okay, and that solves the lab. I hope this makes sense, and I see you in the next one. Hey guys, this is Martin speaking, and we are in the prototype pollution chapter. And today's lab is DOM XSS via an alternative prototype pollution vector. So this is very similar to the previous one, but we need an alternative prototype pollution vector this time around. So this time I'm going to show you this how to do this manually, not using DOM Invader. In real world scenarios, you would always use DOM Invader to speed up the process, but you can do this manually as well. So let's take a look first and foremost. This is our page, this is our URL. So we start off with like a standard prototype pollution vector, like something like this here. And then we basically we go to the inspect option. And what we're going to do is we take a look at the object prototype, right? So I'm looking for the foo keyword in there, right? So I go to my console here in developer tools, enter this, I see the object, and then I can scroll through this, and it seems true that my foo injection did not work. So it seems like that this particular type of vector is not working in this scenario. So let's try another one, right? So there's numerous ones. You can go to payload all the things and stuff and try them out one by one. And let's try this one here. And once again, we will run our object.prototype to inspect it, which I put in here. And then you can see, hey, this one worked basically, right? So this one basically worked, and it reflected my foo bar in there basically, right? So I can see it here. So this is a good first start. But then now, secondly, I need to find a sink, right? So a sink is always like a dangerous function which takes unsanitized input, and the best way to find these things is basically going through JavaScript. So you would come over here and you would go through all these different JavaScript files. Particularly interesting for us is this one, search logger alternative, but in a real world engagement, you will go through all of them, right? And then if you take a look here, so there's basically an eval function where the manager sequence is taken in, right? So this is interesting. So I may be able to control this and then put it into the eval function. So what's happening is I'm going to try something like this, right? So I'm injecting like the prototype and then dot sequence, because it needs to be like in the dot sequence syntax. So let's head over and let's try this, what the outcome of this might be. Okay, so we do this and we basically get an error message. So you see this search logger, an uncaught error. And let's go in there and actually examine what happens. So what basically happens here, so the dot sequence is appended with a 1 at the end. And I believe this is why it's not firing. So it will be like you only see alert 1 here, but what it's actually doing when it's being passed to that through that function and when it's being put into the eval function, there is basically a 1 appended at the end. So I'm thinking, how can I break this code? And so typically a dash should do it, right? Like I just put a dash at the end and then I hit enter, and basically I get my pop-up, because now I don't get this uncaught error message, because I told the function to basically ignore everything it was putting in automatically afterwards. So it ignores the 1 in our case, and this is why it fired. So this is a way like you can manually research this, but in reality, you will use DOM Invader for these kind of exercises. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and we are in the prototype pollution section, and today's lab is basically client-side prototype pollution via flawed sanitization. So this time around, the developers thought about certain prototypes which they are going to filter. So, but because there are so many, they have only filtered on 3 of the most common ones. So our first job is basically to identify a source, a suitable source, and then identify the gadget to execute our JavaScript, and then lastly put a payload in there. So let's start off. Once again, you could do this with DOM Invader, but this time around I'm showing you this manually again, like how this works. So first things first, you're going to do is you just try regular payloads, like something like this, the constructor property, and then you put it in here and you see what happens. And in order to see what happens, if it actually was or if actually an object was created, you go over to DOM Invader, to the developer tools, and then you simply put in the object prototype command, prototype, and we should be seeing something like foo, right? Like, oh, sorry, I mistyped this. I said unchecked. I need to say object. And so if I take a look into the object now, there is basically my foo was not created. So this one obviously did not work. Let's try it with the next one and then look for the keyword foo again. So first of all, we are trying to find a source, right? And there in payload, all these things and stuff, you basically find all these different payloads you can try. It's the same here on the second one, and once again there is no foo reflected. So let's use another one, right? Like let's, for example, use this one here and then see if that works. And let's remove it. And again, DOM Invader does all this job for you, right? Like, so you would probably not do this manually. It's just from an understanding perspective. Object.prototype. And here we go. So basically, this is one of them, and let's mark this here. This is basically one I can use. So I have successfully identified a source, because you can see that I now see my foo bar, which I introduced, and I was able to successfully pollute that specific scenario. So next thing I want to show you real quick is how the sanitization actually works. So there's two JavaScript files, right? And you will basically see that there is a function in one of those, in the search logged filter JS. There's a function which basically defines bad properties, and it defines it as constructor __ proto __ and prototype, right? So developers thought that's fine, but the pro __ proto 2 has not been filtered out, and I can equally use that, right? So and then if you look at the other JavaScript file, this is basically the actual sanitization. You can go through this in your own leisure, but this function is basically, the other function is basically calling that one. And so now I would go over to documentation and basically identify, well, I need to find a gadget, right? So one of the gadgets I intend to use is, well, this time not around is foo, but it's transport URL, which is quite a common one, quite a common gadget, and I leave it, I set it to foo, like the value. I head over to my browser and put this in here instead. And then I do an object properties once again, prototype, sorry, object prototype. And then I basically see the transport URL was taken. So now I found a gadget as well. And all I have to do now is basically modify this accordingly. Like I can, for example, say data, and then my actual payload, like alert 1. Something like this, right? And if all goes well, this now should fire my DOM-based XSS through prototype pollution. Let's see. And it hasn't fired yet. So let's just check this again. Object.prototype. And no, it actually took it. I don't know why it's actually not going to fire it at that point in time. Let's see if the syntax is correct once more. So we are calling the transport URL and equals data. That's fine. And then we put our payload in there, and we finish the payload. Yeah, this should be working maybe with an alert 0 instead. It should be firing, and I don't know why it's not firing, but it's certainly correct, and you've seen it in the developer tools as well. So let's just head over one more time and say object.prototype and I was able to successfully pollute it, and it's in here, but if for some reason it doesn't fire. So that's fine. There may be a glitch with the lab at the moment, but this is certainly the way to do it. And I see you in the next lab. Hey guys, this is Martin. We are in the client-side prototype pollution section, and we today look at the lab called client-side prototype pollution in third-party libraries. So one thing up front is the lab does currently not work, like this specific one, but I still will run you through all the necessary steps, like how you would exploit this normally, and we go through the solution together as well. But for some reason, the DOM Invader does not pick up on this vulnerability. It did a week ago when I tested it. It doesn't do today, but we will still take a look at it. And so basically what you would do is you would first of all head over to your Chromium browser, because the Chromium browser basically supports like the DOM invader, and your regular browser doesn't have that. So all you gotta do is you need to make sure first and foremost DOM invader is activated, and then also the attack type that prototype pollution is set to on. Okay, those are the only two requirements. You will see like a little nice red tab down there, which basically indicates that I found something. You go to inspect, you inspect the DOM, you go to DOM invader over here, and then it shows you like the sources it identified. And basically they are correct, but it fails to exploit them basically. So if you do a scan for gadgets, what you would usually do, the DOM invader is running, and then once it's finished, it shows you like which prototype was able to pollute, and then it will also suggest you on the actual payloads and things like that. But it doesn't find it. And I have been analyzing the JavaScript myself manually, and I also don't see the respective code at the moment. So basically what's happening here, or how they explain it is, well, you do the scan, what we've just done, and then you need to look for the set timeout, basically. So the set timeout can be accessed via the set timeout sync can be accessed via the hit callback gadget, right? And the hit callback gadget basically is only a variable, but I don't see this used in any function or something like this. So I don't know, maybe it's a hidden file or something, or it's just currently not visible. Anyway, so DOM invader would come up with the complete payload. And the payload is then basically, in order to deliver it over to the victim, you simply need to put it into a script tag on the exploit server. So let's head over to the exploit server, and then DOM invader would have actually given you this, right? Like this is basically the payload effectively. Now, the funny thing is, like if you take this and you move over to a new tab and you put it in here, and well, now it's actually firing, but DOM invader does not actually detect this, right? Like it does not currently detect this on its own for some reason. And also, like when you want to do the manual analysis, you don't find the correct function where the source is actually leading into the sink. But you can go to the exploit server also, and you can run it here and say store and view the exploit, and it's showing this to you. And like right now, it doesn't work. It's probably because of a hash change event or something like this. So let's just copy this out real quick and go to the gift section, and then I get like another hashtag event down here, and then I put it in here. Let's try that if that works. Let's refresh it. Also not, no, it seems broken at the moment, but regardless, this is how you would basically do it. And if you go to the exploit server once more and we deliver this to the victim, then maybe it's firing in the victim context, and it does fire in the victim context. But there's something missing at the moment in this lab. But the steps I've shown you with the DOM invader are certainly correct, and it worked for me numerous times in the past when I tried it. It just doesn't work this week for some reason. Okay, I hope this makes sense, and I see you in the next video. Hey guys, this is Martin, and we are in the prototype pollution section, and today's lab is client-side prototype pollution via browser APIs. So once again, this lab is vulnerable to DOM XSS via client-side prototype pollution, and the website developers have put some precaution mechanisms in as they filter certain potential dangerous gadgets where you can basically execute your JavaScript, but they have not patched this correctly on all of them. And so the same methodology applies as before. First, you need to find out if you can add random properties for the global object prototype. And then you actually need to find a gadget to be able to execute the JavaScript, and then you need to put in your payload to execute that JavaScript. And once again, you can do this manually like we have done in the previous lab, but this time around we do it automatically again, so that you familiarize yourself with something called DOM invader. So if we go to the DOM invader section, first of all, make sure DOM invader is on. The attack type has to be set to prototype pollution, and you need to put in a canary. So I'm using Martin, and then reload the page. and see what happens. And basically what happens here, I see this red little warning message. So that means I can go over now to my inspect and then hit over to DOM Invader, and you will see that it identified sources, and it actually identified two sources which seem to be kind of similar. One is the constructor, basically, and the other one is the proto property one. So now, instead of manually testing this out in DevTools, you can simply hit scan for gadgets. So you find suitable gadgets on where you can actually inject your JavaScript. And when this is complete, you get a red error warning that there is basically, it found one sync where it's being executed. So the source, the user controllable source, is executed in the sync. Now you see there's a 1. So once again, you go over to the inspect, to open developer tools, go to the DOM Invader, and now you basically have an exploit button, which you click, and that exploit button basically uses here the payload, URL encoded, and the injectable prototype was the value, as you can see this here in our POC, okay? And then this basically solves the lab. I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin, and in today's lab we are looking at privilege escalation via server-side prototype solution. So this time around it's server-side, it's no longer client-side. We have a lab built on Node.js and Express, and it's basically vulnerable to prototype pollution because it takes user controllable input and then merges it into a server-side JavaScript object. Okay, and this is where the vulnerability is. So first of all, we need to find a source. Then secondly, we are identifying a gadget to make sure that we can escalate our privileges. And thirdly, we access the admin panel and delete the user colors. Okay, let's head over to our application and we log in with our credentials. And once we log in, you will see you can update your billing address. So let's do this here. Let's update the billing address and let's send this over to Burp Repeater to play with it, right? So what I can see here is I can put JSON information in here, and then that JSON information basically is reflected in a key value pair. I see a couple of interesting things already which stand out. First and foremost, this one is admin false. So interesting. I will copy this over. But first of all, what I'm going to do is I try to basically do prototype pollution by simply adding another JSON object here, right? So comma, and then I put in a foo bar, and I send this, and you see, hey, it was reflected. So perfect. So this now confirms that I have a server-side prototype pollution vulnerability here, but hey, I don't wanna put a foo bar in there. I actually want to say like, is admin true? Right? So I want to gain admin credentials. So let's send this over, and here we go. So now I should be admin because it set admin to true, right? So let's refresh the page here, and that gives you the admin panel, and I can delete the user colors, and this solves the lab. I hope this makes sense, and I'll see you in the next one. Hey guys, this is Martin. We are in the prototype pollution section, and today's lab is detecting server-side prototype pollution without the actual polluted property being reflected back to you. So unlike in the previous section where we have seen this is admin true or false, which we were able to modify and gain admin access, we don't get this response this time around. So let's take a look how we still can confirm that prototype pollution on the server side exists. Let's log in with our credentials here, and you can see that you can update your billing address. Let's do this. Let's hit submit. Let's head over to our Burp repeater, and it pretty much looks identical than what we have seen in the last lab. So once again, what we try to add the object foo bar. So let's put this in here in JSON and hit send, and it's not being reflected. That's what I meant, right? Like last time you have seen this here as a key value pair. It's not being reflected. Let's do something to basically break the syntax, right? Like let's put another comma in here to see how it behaves. And this is interesting. So I can now generate like an error message, and I see that foobar actually seems to have been taken, but it's under the status code of 400, right? Like, but what I just did, like the foobar was actually taken. And I can confirm this by actually removing that and put in Martin here, like foo Martin, and I don't see it, but if I generate an error, I am able to see it. Yes, here, foo Martin. Okay, cool. So that works, but maybe I can actually change the status here, right? Like, so let's say if we say status, and then I put this to, instead of 400, I put it to 555, right? Like something like this. And I don't see any error at that point in time, but if I put an error in there again, syntax error, you can see that the status was actually changed to 555. And that solves my lab, because that proves the point that I'm able to successfully pollute server-side properties. Okay, I hope this makes sense, and I see you in the next lab. Hey guys, this is Martin. We are in the prototype pollution, and again, we are in a server-side prototype pollution lab. This time it's bypassing flawed input filters for server-side prototype pollution. Let's take a look. Our objectives are the same as before. So first of all, we need to find a prototype pollution source. Thereafter, we need to identify a gadget we can use to escalate our privileges, and finally accessing the admin panel and deleting Carlos. Right, let's head over to the application and let's log in. So Vina and Peter, and you can see here that I can submit my address just like before in a previous lab, right? So let's send this over to Repeater. And the first test I'm going to do once more is I'm trying to basically inject a prototype here and foobar, right? So I don't get it reflected, right? So I don't get it reflected back, but so there may be the case that they're actually filtering this particular prototype, right? So let's remove this and let's use constructor instead. Constructor. And let's see what happens. And foobar is still not reflected. Constructor, yes, of course, because if I use the constructor type, I actually need to put in the prototype manually, like this, and I need to put a curly bracket around this, and then I have my payload, and then I need to close it out down here. Okay, so let's try this. And what you can see now is I get an internal server error, but it seems that it has reflected it, right? So interesting. So let's now try something different. Actually, I had a syntax error in here. I need to finish this with a double quote. So let's see if this works. And it worked, right? Perfect. So basically the filter they have in place is not exhaustive, basically. So I can use, for example, the constructor prototype instead of the prototype, and I can bypass this restriction. And now it should be relatively easy. So if I now say is admin equals true, that now should reflect in my JSON response, and it does. Okay, so I was successfully able to prototype pollute the server side. I have my admin panel, and I can delete Carlos, and that solves the lab. So thank you very much, and I see you in the next one. Hey guys, this is Martin, and welcome to the Prototype Pollution Labs. Today we are looking at remote code execution via server-side prototype pollution. It's pretty similar to what we have done in the previous labs. We are finding a prototype pollution source, and then we find a gadget we can use to execute our system commands, and then finally we need to trigger the execution and delete the home Carlos Morali.txt. Word of caution, don't do this in the real world unless you have the authorization, because you can do a lot of damage. And especially for bug bounty, this kind of stuff is not required. It's typically like a harmless payload just to prove the point, but don't do something like this in the live labs or in the live environments if you don't have the customer permission and this is all agreed upon. So let's log in as Wiener and Peter, and we can update our billing address, which I do here, right? So you can see that, and I sent this over twice to repeater. So let's take a look at the first one. What I'm going to do once more is I'm going to introduce my own object here, and I call it Foo Martin, and I send it over, and it has thrown an error because I probably need to put this into speech marks, and I do this again, and yes, so this has proven the point. And when it comes to bug bounty, that would be game over here. You would report it because you would say like, hey, I can successfully do a prototype pollution on the server side, but we want to take it a step further in this lab, and for that reason we are basically using something like this. And this is, you can find this if you go through JavaScript documentation, but effectively it's like executive arguments, whereby we issue a Linux command called rm home Carlos Morali.txt, and now I'm trying to pollute the server with that information. So I'm going to go to my other tab here, so we have a clean slate. I need to put a comma at the end first and foremost, because we have another JSON object. I put this in, and I will hit send. And I get an internal server error, which is not much of a concern at this point, but let's go over to the admin panel. And now we need to run the maintenance jobs, because then the code will be executed when these maintenance jobs are being run. And what should happen now, let's restart the Node application as well. And let's log in one more time. Let's try this again. Wiener Peter, and we have the admin panel here, and we run the maintenance jobs. And yes, it actually should have done the whole thing, and I got the success error the success messages, but for some reason it did not delete that file yet. So I don't know what's causing this. I strongly believe there's a little hiccup with the lab. I was doing this before and solved it successfully. Let's just try it one more time. Let's come back here to my account. Let's submit this, and let's basically send this over to repeater once more. And let's add our pollution in here, and let's hit send. And now this looks better. So now we have this exec arc v in there. And let's come to the admin panel. Let's run the maintenance jobs one more time, and that solves the lab. So that the file has been successfully deleted through server-side prototype pollution. And that is the end of this lab. See you in the next one.